All right, everyone. Let me add everyone for the intro. So here we have Ed, our CEO. We have Paul.
Hey, yeah.
And we have Ksenia, who's our amazing community manager of this event. And my name is Nick. I'm a director of events at Geekle. So hey, everyone.
Hey
This is
everyone, hey, I'm
Hello.
so excited. We do it again, people. Worldwide Architecture Summit 2022, I believe second edition, right? It is live now, and I'm so happy. And as always, I see so many people on the stage here watching us, and I so excited to read all these comments from South Africa, Costa Rica, Netherlands, Kiev, of course, and we will talk about Kiev a little more because we're a Ukrainian company. Started from there, and Germany, and Hungary, and South Korea, Nigeria, Germany. Ah, my God, from everywhere. I'm so happy to welcome you, people on our stage, and I'm so excited to be surrounded by people who are interested in development, in architecture, in software, in moving this world forward. Hey, yeah. Ksenia, how are you?
I'm fine, thank you very much. Of course, I'm excited for this actually fourth edition for the global worldwide architecture events. Of course, the second of this year. And please don't tell others, but it's my favorite community. So yeah, it was
Uh,
a really pleasure to create one more event, to work with our program committees, to check all this content we will have during the next 2 days. So yeah, I waiting for have so much fun.
yeah, we're still having fun, and we're trying to not think about the Kiev situation, electricity, how it works there. Do you still have any kind of power or what?
Yeah, actually, every 3 or 4 hours, sometimes 12 hours without any electricity. But today, I hope we'll be so lucky. It's the Tuesday, and I told everyone,
People.
please, please stay with the electricity today.
Oh, people, come on. I'm with you. I'm with you. Yeah, hold on there. Yeah, but we still do it. And we do it during the pandemic, during the war, because actually Geekle has born at the hard times when no offline community conferences, was possible, like during the COVID. And we created this project just to find the most exciting news or trends or know-hows or something like that, and spread it out around the world without having any need to move to some crowded places or fancy and expensive conferences. I love it, but still it's not necessary to go there to know something really fresh and new. That's what Geekle about. And yeah, Geekle is something what we like really love. And Nick, uh, or someone tell us more about this event. How many registrations we have today, or yeah, what's going on today?
so we have more than 5,000 registration for this event, and we have so many hours of content. So basically, we have 3 days.
Hmm.
Today is a career track, and we have 16 topics. And tomorrow is a pro track where we have 16 topics more. And we have the entire event for 36 speakers going to present on this event. And we have also third day, which is a workshop day. So don't miss it. If you're watching this on a platform, and you should go and click on top of the chat. There is a 3 days career pro and workshop, or
Wow.
two if you don't have a ticket for pro. You still have access to
Wow.
the workshop for
Yeah.
that we have on Thursday.
Cool. And Ksenia, how did you manage 36 speakers? It's a lot of like people. Like, wow.
I actually told them too that we didn't plan to have such big event like the previous time because I think like 50 topics and people were like, oh my god, too many contents. But actually we wanted like to close the season, to have like to finalize what we've got through this year, what happened, so what big plans they have for the next year. And actually there's not too many speakers, just we have someone who speak like with friends or with the colleague. So I'm sure from the two-person you even get much more than from the one speaker sometimes.
Cool. Thank you very much. And how big is your program committee?
It's 11. It's 11
11
amazing,
great
amazing members.
persons, and thank you
Yeah,
very
great.
much. guys.
Yeah, some of them
and
even
girls.
join us as a speaker too.
Cool.
And because they couldn't just do not join us today. So yeah, of course.
Yeah. So many people support this product, and I'm so happy because thank you to all members of our program committee, of course, and thank you to every speaker, and thank you to every person who purchased any ticket, even for $1. I always say thank you because every dollar supports this project and help us grow. And of course, I want to mention and say huge thank you to CodeScene as a company who support us, actually, not just this time. They contributed a lot this time, but during all this our entire history, because their CEO Adam Thornhill, he's like Paul say, serial speaker here. He always join. He does his talks, and he supports us. Guys, thank you very much. And please, Paul, maybe you'll tell us more about this amazing partnership.
Yeah, absolutely. So, as Ed mentioned, CodeScene and Adam, they were with us since the very beginning of the Architecture Summit, and they're going to have 2 talks and the workshop during the course of this conference. So today we will have Emil Aasa with us, and he will be talking about the refactoring, domain-specific refactoring. So we know that there are differences in how you can refactor your code in different domains, and what tools to use, and what kind of tips and maybe tricks and things that you can learn regarding refactoring. Tomorrow we're going to have Adam, and also, as Ed mentioned, we're going to have, and Nick mentioned, we're going to have a workshop. It's going to be a free workshop, so free hands-on workshop, 2.5 hours of intense content. And if you want to partake in that workshop, if you register for architecture, you already have the ticket. Just join for the 3rd day. And also in the email, you've received a reminder email from us today. You will have all the links that you need to register and to get a free trial, because CodeScene was so kind to give us a free trial of their software that actually will help you to navigate through the workshop. And just stay tuned for all the good things that we will have during the conference.
Thank you.
And also, I forgot to mention that also CodeScene was so kind to provide us additional some funds for the sponsor giveaway. So we're gonna have an iPhone giveaway today.
How can I win it, actually?
So you need to fill in the form. We're gonna have it in the chat.
No, I didn't.
So you will have the opportunity. So we'll post it in the chat, and you basically you can enter this raffle, and you can win yourself a new iPhone.
New iPhone can go. I for sure will go to someone of our people who watch us right now. And people, every time I start, especially Architectural Summit, others communities are great also. I love them too. But when I start Architecture Summit, I feel like I touch the kind of holy grail, or some I don't know, some energy that moves world's technology forward, and I really love it. I like feel my personal contribution here. So I really love it.
I
Anyway,
like you touch creme de la creme, but then I thought it's kind of like
yeah, we still have more and more people writing in the chat. I wrote, I'm in France, in Nice, Chiruga, DRC, go Malta, Emir, Argentina, Brazilian living in Spain. Wow, yeah, I'm Ukrainian living in France. I understand you. South Africa, Cape Town, people so happy. And I believe we can start sales.
But we need to tell about the next event.
That's what I was doing. And
every 6 months we are preparing something interesting, like for the 5th worldwide software architecture event. So stay tuned. As I know, the dates make it like May 16th, 17th, I suppose. Maybe we'll have 2 or even 3 days of content. So we'll be happy to see you there too.
And how do we get there? Who knows? Nick, can you?
We add a banner. We'll turn on a banner. I will also post a link to the chat. We have exclusive price just for the days of this event. For the 3 days of this event, we have price just for our community who will be joining our event. So yeah, this is going to be our 5th Architecture Summit next year.
Yeah, you can be absolutely sure this is the best price for people who attended today, and links and banners. So make sure you saved your spot to the next event on the very best offer. No more chatting. I think it's time to start, right? Nick,
Yep.
Right. Yeah, we have our first moderator, who is also our amazing speaker, who've presented so many times already.
This great person.
So let's invite Otavio to the stage and leave him to start the first block. So hey, Otavio.
Hi.
Hello, everyone. Good morning. Whoa!
Let's get it started. How are you, man? Where are you?
I'm fine, of course. First day at Architecture Summit at Geekle is impossible. It's impossible to be less than amazing, right?
Thank you.
Yes. Let's start then. So great conference. Thank you, everybody. And let's leave the stage to talk a little bit more.
Yeah. We're getting out. No worries. Yeah. But where are you now? Where you are right now?
Right now I am in Leiria. It's a Portugal city. It's
Portugal.
2 hours from Lisbon.
Yes. Cool. Yeah. Okay. Have a nice your duty, and yeah. Take care.
Thank you.
Okay. So hello everyone. Let's start Architecture Summit. Who wants to know more about architecture? Please raise your hand. So let's start right now talking about Web 2 to Web 3.2 with, okay, let me try my spell. Hopefully I say correctly. Vaclav Pavlin. Hello.
Hey Otavio, hey everyone. It's great to be here again. This is my second appearance on the Worldwide Summit, so I'm really excited about that. You got it almost right, but everyone screws my name this way, the way you did, so it's perfectly fine, and I'll always respond to that form. The proper pronunciation is Vaclav.
Vaclav. Okay.
But I'll respond to basically anything.
I know that feeling. My name is Otavio. Usually they say Octavio.
Yeah.
It's hard to see somebody who say my name correctly. And by the way, it's Italian. Everybody should use the hands like Otavio, something like this. Oh yeah. So the stage is yours. So have a nice presentation.
Thank you. I'm gonna actually turn off the background because I think it's slowing down my computer a bit too much. And I'm gonna present my slides, I guess. Let's do that.
Okay, yeah. We need to share your screen so I'm able to.
Working on it. Okay. Can you see my screen fine?
Yes, everybody can.
Why is it not full screen? Okay. Well, welcome again to the Worldwide Software Architecture Summit. And again, this is my second appearance, and I'm really excited to be here again. My name is Vaclav Pavlin. You can see my email. Feel free to reach out. The bottom one, V Pavlin, is GitHub, Twitter, LinkedIn, all the social networks. So feel free to reach out, ask questions, or just connect. My talk is about Web 2, which is kind of like our traditional internet, Facebooks, Amazons, Twitters of the world, to Web 3.2. And I'll explain why 3.2 in a bit. My last talk here on the last Architecture Summit was about blockchain and why I actually switched from kind of traditional development, traditional space to blockchain-based applications. So now I want to talk more about the actual architecture and infrastructure of things. So who am I? In the past, I worked mainly, most of my working days were spent at Red Hat. 9.5 years. And I did a lot of things. I was an architect there. I did containers when Docker came on. I did OpenShift when Kubernetes came on board. I did some SRE work. I worked in a team that focused on AI ML, and I've built, I have led a project. I didn't build it myself. There is a lot of people involved, but I've led a project called Open Data Hub, which is now as a product offered as Red Hat OpenShift Data Science. But then I stumbled upon blockchain and Solidity and smart contracts, and I was really interested in that. So I started learning, and I left Red Hat and I joined a small Czech startup called BlockCheck as their blockchain lead. And I did I developed smart contracts and designed Web3 applications, and then we did some NFTs and things like that for our customers. And then I got connected with a bunch of people over in Asia and Australia, and we started a company together called Rubix, and we are building. Our end goal is to build something that will help people make more money and get connected between like people that need work done and people that want to do the work. But that's our end goal, and we are starting with something slightly different to kind of get more into the space, and that's a tool and a platform for brand engagement through NFTs. And I'll talk more about NFTs. It's not just fancy pictures of weird monkeys and things like that. It's a slightly different thing, but to me at least. But that's kind of what we are doing right now. As we go, we'll see. We see where it takes us. So what is my talk about really? So I will go over blockchain basics just to kind of refresh what I talked about on my last presentation, and so that we are kind of on the same page. You don't have to have any particular knowledge about blockchain or Web3. I'll tell you about that. And I'll also explain how I understand blockchain, because the explanation of what blockchain networks and smart contracts mean, it's kind of different for everyone, because everyone expects something slightly different from it. Then I will talk about how Web3 applications look like. What is their architecture? What is the infrastructure that's being used these days? And then I'll want to talk about what I think is missing and what I think can help us and can kind of help us to move faster in this space. So what is blockchain to me? I think it may sound stupid, but we are all probably familiar with databases, Postgres, MySQL, Oracle database, right? And to me, blockchain is just a database. As a software architect and software developer, all I care about is that the blockchain stores my data and that it's there forever, that is distributed, that is global, and that it's accessible, right? So I think about blockchain as a distributed database. We have some basic blockchains like Bitcoin, which basically just stores information about the transactions of like moving Bitcoin around, but it can also store more information in that database. And we have more complex things like Ethereum, where you can deploy code. And that's where we are getting to the second point, which is like, it's also kind of a distributed computational platform. If we want to bring it back to that analogy of a database, you can think of smart contracts as stored procedures in a database. So it's something that manipulates the data in the database. It's not a complex function usually. It can get more complex as you grow, as you implement more complex things. But usually it's not that complicated stuff. It is a relatively simple data manipulation software, the smart contracts, right? And we have other kinds of blockchain. We have blockchains that focus on actual compute. So there's something called Akash network, which actually does like a distributed compute. We have, and then it's based on blockchain, so that you basically can offer your computation power on your laptop by joining the network, and then other people can pay you to actually use that. And we have things like Arvi, which takes care of storage, and it's like a permanent storage where you again offer the storage, and you're paid for other people using that storage and offering basically permanent storage. But if I talk about blockchain, I usually mean something like Ethereum or Polygon or Solana, where your data stored on the blockchain are relatively small and the compute power is relatively small, but together it is still pretty powerful combination. Then when I talk about blockchain, I mean something that I call open public API platform. If you're building an API and you deploy it to some cloud like AWS, DigitalOcean, or something, and you need to manage API keys and access and roles and authorization and authentication and all these things, right? When I talk about blockchain, I think about it as an open API platform because it is there always on, and you can use it, you can read it. All you need is wallet. To read it, you don't even need any money to pay. To write to it, you need to pay the gas fee. I'll talk about that a bit more. But it is a completely open public API platform, and there are standards that make this easier for us to integrate with various smart contracts, various kind of objects on the chain. You can also talk about blockchain as a magic internet money management platform. If you think about all the tokens, be that NFTs or fungible tokens, as money, that's not what I want to talk about. Especially now with like that fail of FTX and everything, a lot of people lost a lot of money. And this is not that I think it should be the main use case for blockchains in general. I think main use case is the database, that global distributed public database. I think blockchain is also an opportunity for communities because it is global and distributed, and a lot of code is open source, and all of these smart contracts are open in a sense that you can read them and you can build something out of them. And that helps communities to interact, and the communities around Web3 projects are pretty welcoming and really cohesive, I think, most of them. So I think it is a great opportunity for that. And then also, I think blockchain brings us to global workspace and workplace. Workspace, as in I deploy code that anyone can immediately use it. I don't have to replicate across zones. I don't have to figure out some like disclaimers for each country. I just deploy it, and it's by default, by design, it's global and distributed across the whole world, basically, right? And then global workplace, if you look at Web3 projects and startups, they usually are not collocated in one place. They usually hire globally. People work on these things globally, and we don't really care where we are. It's remote by default, basically, right? So I've used some of these terms, but I want to go a bit deeper into them because they are important to just like understand the architecture of things. So first term, wallet. What is a blockchain or Web3 wallet? If you're familiar with cryptography, then wallet is just a private key and public key. Basically, you use your private key to sign transactions or messages that are then sent to the network. And based on that, you verify that you are the sender of that message. So the network can work with your funds or with your smart contracts or generally do anything on your behalf, right? Obviously, you need to make sure that your private key is stored properly. And there are different kinds of wallets, hardware wallets, software wallets, browser extensions, things like that. But in a sense, it's just the private key that you are signing messages with. And transaction is basically sending some information to the chain, and the chain reacting to it and persisting some results, right? So the basic transaction is I'm sending you some tokens like Ethereum or Matic, but then more complex transactions will contain data, and the data will be used to call a function on the smart contract. So it's basically an RPC, remote procedure call. It uses JSON RPC to communicate with the nodes usually, and then inside it's basically just decoding the data in the call and using that as a smart contract function call and the input data for that call. Then what are the smart contracts? I've mentioned it's basically like stored procedures on the database. So that means that you write some code, you deploy it, and then you define some storage in that smart contract. Say, okay, I want to store these numbers, I want to store these addresses or these strings, and I want to modify them with these functions, right? And that's it. So there's different kinds of variables where they actually live. They live in storage, they live in memory, they live in call data, which is a separate part when you're calling functions. But basically, storage modifying storage and using storage is more expensive with regards to gas fees. Memory is more cheap, but then if you want to use anything, you need to use the storage, obviously. Or you want to persist anything, you need to use the storage. Then there is a concept of events. Every smart contract, every function can emit some events, which is basically a log message. But that's very useful because doing the operations on chain and reading from the chains is expensive, computationally expensive, and potentially even like expensive from the point of money. But reading is like free from the point of money, but expensive computationally. So if you want to make be able to query information about a smart contract or some history and things like that, that's where the events are used for. So let's say I have a method that sends my NFT to someone else, and that will emit a transfer event, and I can index that, and I can have a database of events and a database of NFTs and how they moved hands, and I can basically build a history of a single NFT. For example, this is something we are leveraging at Rubix. As we are building the brand engagement platform, we want to make sure that that the brands, and the brand does not have to be a brand as in Adidas or Nike. It can be brand as in university or a football club or your kid's party, right? But we want to make sure that we can track particular objects historically and see what happened with them. So that's what the events are for. And then the concept of revert, as we are using the analogy of the database over and over again, if you're familiar with databases, you can have like a transaction in the database where basically you make multiple modifications in various tables or something. And then if at the end, if something fails, like a unique key is not unique or something, then whole transaction will revert. And that's the same for blockchain. If your smart contract is calling out the smart contracts and changing things left and right, and then suddenly there is some condition that doesn't pass, whole thing is reverted and whole transaction fails. So that's why the database analogy works that great for me. And there is concept of gas fees. This is something that is, when we start thinking about architecture on top of blockchains, this is something very important. Usually, when you deploy your application, you pay for it to be deployed and to be running, right? You deploy some API, you deploy some database, some storage, and as long as that is there, you pay the cloud provider fee for it to be available. Blockchain works differently. You pay the deployment, so you pay the gas fee for the transaction to actually deploy the smart contract, but then for it to be there and available to anyone, you don't pay anything, right? And then anyone interacting with the smart contract will pay the fee for the transaction. But if, let's say, I create a smart contract that tracks how often I travel to Portugal, and I don't travel to Portugal for 10 years, the smart contract will be there for 10 years and I will not pay anything until I travel again to Portugal, right? So that's a different way of thinking about this, about how the architecture and how the actual like longevity of these applications can work, because we think in terms of blockchain will be there forever, hence the applications will be there forever, and it's great that we don't have to pay for them forever, right? Then there is concept of tokens. That's more in the sense of that, like the fungible ones are more in the sense of that magic internet money, but they can also be used for governance and rewards for someone doing work and things like that. And then there are non-fungible tokens, so like a unique tokens, which are usually represented these days by NFTs of Bored Apes and CryptoPunks and these things. But when I think about non-fungible tokens, I just think about an object in a database with a defined API. That's it. No images, no music attached to it, no videos, it's just that. And I think that's good because it's a very important concept and a very important thing to realize that we are really talking just about an object in a database, because then that object can be anything can be attached to that object, and that object can be attached to anything else, and we can build complex structures based on these objects, these NFTs. So now there is a concept of indexer, which I explained the events, the logs being emitted by the smart contracts. An indexer is a tool or a system that goes and tracks those events and builds something on top of that, builds some entity on top of that. The most popular now is probably the graph protocol, It's really great because you can develop basically an indexing component in JavaScript, and it gets encoded into WebAssembly, and then they execute it based on your smart contract events, and it builds a GraphQL entity for you, and you can easily query it. So that's a very powerful tool. There are new coming up every now and then, but the best one seems to be the Graph protocol still. And then there is a concept of permanent storage, which is used mostly for the NFTs themselves, but also for like zero knowledge proofs and things like that. And that's basically represented by IPFS, which is not a blockchain-based thing, but it's often used in context of blockchain, which is interplanetary file system, which basically should be that you can upload anything there, and it should be there forever unless some conditions happen. And then there is Arweave, which is a blockchain-based project, which allows you to upload data, pay for the upload, but then do not pay for the data storage, but it should be there forever. So that's an interesting thing to think about when you're developing applications. So now, what is the minimal Web3 application architecture? Well, this is it, 4 components. The permanent storage is not necessary for many applications. I just put it there because as we focus, as like Rubix and I focus on NFTs, we need to store the information about the object somewhere off-chain, usually. So that's why I put permanent storage there, but maybe that's not even necessary for the minimal Web3 application. Then there are smart contracts. That's like the core piece that actually is your database and execution layer and tracks everything and kind of glues everything together. And then we have a web application. That's usually like a React.js with libraries like Ether.js or Web3.js that are helping you manage your transactions and your wallet. But other than that, it's just basic React application. And then there is Indexer if you need it, if you actually want to have some queryable database on top of the smart contracts. I have built initially when I started with blockchain and Web3, I've built applications that basically did not use the indexer because it was so simple and so straightforward that I just queried the contracts directly and it worked perfectly fine, right? So it's more of like when you get more data and more things to kind of go together and you need to query it, that's where the indexer comes in. And this is great. This is great architecture because it really helps us to get quickly to the market, get quickly to test our things. But where it fails is, for example, user experience, because the user has to have their wallet. There is no way to integrate it into like Web2 infrastructure, Web2 applications, because there is no API that they can call potentially, right? You would have to integrate the JSON RPC communication to a blockchain node into your Web2 applications. The web applications grow really large for complex systems like decentralized exchanges, and then they are basically useless on mobile phone because the phone browser will not be able to like give you a reasonable speed for that complex web application. So most of the projects then move to something like this. So they have still the smart contract, they still have the web application, but it's more lightweight. And there is the permanent storage and indexing that doesn't really change. But then they add some database to track their own stuff, their own actions. And they potentially add like a mobile app maybe to it because we are very mobile these days as in world and the access to internet. And then they add mainly the API. And the API should be something that allows you to make the web application smaller, that allows you to bring a better user experience, and then also like take care of some of the things. One thing that I didn't mention here is that when something happens, when you call the smart contracts, like there is an error, there is an execution revert, or there is something bad with the transaction happening, it's hard to track it in the web app. If the user reloads, if the user just, if the connection is lost or something, they may not get the information. And then you need to go to something like Etherscan or PolygonScan, which are big applications running on top of blockchain, indexing all the transactions, and then they give you some insight into what's happening there. But it's not for an ordinary user. It's a terrible user experience. So here with the API on top of the smart contracts, you can actually go and you can do some retries and timeouts and replacement of transactions that look like they might be failing. And then you can also give user back some error messages, some cleaner error messages and things like that. So this is good. And we can look at applications like Lens protocol, which is built on top of Polygon. It's a social graph built on top of blockchain. And they do something like this. They have a database and GraphQL on top of that. And basically, you can either interact with that, or you can go directly and talk to the smart contracts. Like here, the web app has a weird shape, and that's because you can still go directly to the smart contracts and kind of circumvent the API if you have to or if you want to, but then the API will give you the better user experience. So this is where I think like we are coming to now with more complex applications in Web3. So once the smart contract protocol grows, you need some abstraction layer on top of that usually. And there are things that make it, or there are tools or services that make it easier. So these days, there are something I would call cloud service providers for Web3. Most of them started as node providers. So when you talk to blockchain, you need to talk to a specific node. If you use public node, that's fine for one-person usage. But once you add that API layer and you start making a lot of calls for many users through your platform, then the public nodes will rate limit you, obviously. So you need your own node. And most of these companies and startups started as a node providers. But then they started to build API for common things like those NFTs or fungible tokens. One that I want to just point out here, I'm from Czech Republic, and Artsiom is from Czech Republic, from my hometown, Brno. And they are pretty cool. They can do wallet management, they can do API calls on top of blockchain and do retries and all these things that I mentioned. My general issue with this approach is that Web3 should be about decentralization and should be about self-custody and permissionlessness and trustlessness. But once we start building with these cloud service providers, we are giving them our trust that they will process the transaction, that they will not fail, that they will be there, that they will not change something that will break my stuff. And I'm basically losing a lot of this decentralization and trustlessness in favor of slightly better user experience for the developers, or the developer experience, right? So now I stop talking about Web3 for a couple of minutes, and I'll talk about Kubernetes. Maybe it look like different, like a weird jump, but I'll explain that. So if you are not familiar with Kubernetes, which I believe that most of people here watching this will at least know the name, but how I define Kubernetes is consistent API for deploying and managing applications, right? If you have a bunch of cloud providers, they will all have some way to deploy and manage applications, but those APIs will differ based on the cloud provider because everyone has the best one, right? And has to have the best one. And that means that they will all be slightly different. Kubernetes solves this by providing a consistent common API. So you can deploy it to any cloud provider and it will give you a same API to deploy and manage your applications. And the best way is that you define the state. The best thing is that you define the state. So I want my WordPress running, period. And what Kubernetes does is it will take that container and that manifest and all that information and try to achieve that state of WordPress is running and maintain that state. That's all it does. It doesn't do really anything else. And it sounds simple, but obviously we know as people that deploy applications that it's complex task, but Kubernetes takes a lot of that complexity away from us. So as I said, it's cloud provider agnostic. You can deploy it and you still get that consistent API for deploying and managing applications. Extensible, there is something called CRD, custom resource definition, where you can actually extend the API, the native core Kubernetes API, you can extend it with your own API objects and then do different things than Kubernetes originally knew to do. But you can do it in a consistent way of extending the API using the same style of API. It is definitely battle tested because everyone uses that. We at Red Hat, when I was there, we were developing OpenShift on top of Kubernetes, and it's still very popular Kubernetes enterprise distribution, and many, many large companies use that. And once you understand Kubernetes, I think it makes sense. Like when you first look at it, it is just a complex pile of spaghetti to you. But once you get into it, once you understand the core concept, it makes perfect sense how things work and why they work this way. Now, why do I explain this? I think we need something like Kubernetes in Web3 world, because I have big issue with this as a Web2 architect, let's say, because it doesn't give me enough flexibility and it doesn't give users good enough user experience. This is good, but then everyone goes and builds their own API, use their own database, and builds everything from scratch, which is current state, right? And we have this, which helps, but it is very centralized, and I have to rely on someone else who relies on someone else. So like if I go to Alchemy or Tatum or whoever, they will run their APIs on some cloud provider. So not only I'm trusting this startup, I also have to trust that cloud provider. And we have seen what happens when AWS S3 goes down and not even GitHub status works, right? And like everyone has day off in software development because GitHub doesn't work. So that obviously will still happen, but at least I don't have to rely on another middleman, which is one of these companies. What I'm basically proposing here is that someone should go and build Kubernetes for Web3 kinda. And the components that I see that are kind of like obvious, and there will be probably much more or many more, is generic API layer, like the Kubernetes has, and you can think about it as CRDs and the core kube API. Basically, be able to work with common standards of Web3, so like ERC20, ERC721, ERC1155, and many other standards built on top of Ethereum or other chains through the API that is stable and well understood, but then be able to extend it like with CRDs in Kubernetes. Then have some kind of cache there so that all those API requests can be kind of cached and executed across the against the blockchain as needed. So maybe it doesn't happen immediately. Maybe there are some things that need to be resolved first. Maybe there is some queuing or some ordering of things, and that's fine. Have some layer like that in there. That's what etcd basically takes care of in Kubernetes. It stores all that information that the user needs, and then various controllers can go and grab things that they can work with, right? And then we have the execution layer, which would be something that actually goes and produces the transactions, verifies, validates the data that are sent to the blockchain, checks that there are enough balances of people sending each things maybe, or check the reverts and check the stuff that can be retried or that can be easily fixed on the code level. And then I have something called wallet management here. That is a controversial thing because we don't want to manage user wallets, but sometimes it helps with user experience if the platform actually manages user wallets. But in any case, you will need to manage wallets that then call the execution to the transaction. So I left it there. I wanted to remove it, but I left it there. But basically, this is it, right? Have a thing that you can just go to a repo or go to some marketplace, fork it, or click a deploy button. You deploy it to your cloud of choice or to your machines, and it gives you a common API it gives you a consistent API for common objects on blockchain or common smart contracts, and allows you to execute transaction against them, and then it allows you to extend that. How to get there? I don't know. I've been building something like this for us at Rubix. It is not general enough to be like a solution for these things. It's not a Kubernetes for Web3. It's just for us. But when I'm building it, I'm thinking about these approaches and how they can be generalized. So maybe this exists and I just haven't found it. So if you know about Kubernetes for Web3, please let me know. I would love to see it, and I would love to contribute and maybe use it. What I do now is that I found something called Temporal IO. It's a workflow manager, and it's really good workflow manager, I think. I love their approaches. Go check it out. I definitely recommend it. I keep talking about it with my software engineering friends. And I think it could be easily used to build like a reusable blockchain-focused task workflow library so that I can then deploy Temporal, take this library, deploy it, and suddenly I can easily send blockchain transactions from my code without any crazy hustle to get there. So that's what I want to do, but we'll see if we get there. But anyway, I think that's basically it. So to conclude, in Web3, we have very simple architectures that we start from. And as it gets more complex and when reinvents the wheel, we need something like Kubernetes for Web3 to be able to quickly spin it up and quickly provide a good user experience to our users. This talk is based on my blog post here, so if you want to check it out and maybe share, I'll be happy to get more traction there. But anyway, thanks for listening. Thanks for watching this. And if we have time for questions, I'm happy to answer them.
Hello. Thank you. It was an amazing presentation. Unfortunately, we don't have time to Q&A. However, we have the power of the internet. Please follow him on LinkedIn, on Twitter as well, so you're able to stay closer. Of course, he has much more than this presentation to show, so follow him on Twitter. And thank you again for your time. And congratulations for your presentation. Okay. Let's move on to the next presentation. This time to talk around how to approach software efficiency problems in 2023. And of course, we need help to talk about it. So let's invite who is Principal Software Engineer at Red Hat.
Hello, welcome everyone.
Hello. Good morning, good evening, good night.
Morning for me.
Oh, nice. So the stage is yours. Please share your screen and let's go.
Let's go, yes. Let me find the correct screen. Should be this one. And let me know if all set up. Yeah, should be fine.
Yeah, everything is okay.
Okay. Welcome everybody. Thanks for organizing the conference. Thank you for joining as well. I'm here to talk about software efficiency and why it matters and how to resolve potential problems with your software being or your system being too slow or using too much resources, so it costs more than it should, right? So I'm about to give you 4, I hope, actionable tips that will hopefully, in my opinion, they can easily yield, millions of dollars in savings. I'm really not exaggerating here. If you are, a PM or manager or architect or engineer in any of those kind of roles, you can incorporate those things. So hopefully you'll find it useful. Before I start, short introduction. My name is Bartlomiej Plotka. You can call me Bartek, and I maintain many software, mostly in Go, in open source, including I'm maintainer of Prometheus, which is a monitoring project, and Thanos. I'm kind of like active in CNCF as well. I'm mentoring, and there is some tag observability you can join, which is like a group we discuss observability things in the Cloud Native Computing Foundation organization. And recently I wrote a book as well. It's called Efficient Go. It's all about creating efficient software in Go language, but really Go is just used as an example. Majority of book is really language agnostic. So you might find it useful. Feel free to grab this link and look at the book. So let's start. And as proper, they say the proper presentation should start with a proper story. So let's talk about story. And the story is about really a pattern, a pitfall I see in the REST and the DevOps SRE software development space. And this happened, a few years ago, I think 4 years ago, actually, in the open source project called Thanos. I kind of co-created this project 6 years ago or so, and it kind of grew into a CNCF landscape, and majorly, now it's kind of led by the community, and it's kind of big. And you don't need to like understand what this project is actually doing, but it's generally like scalable monitoring systems, lots of microservices. You can run it, on your infrastructure for free. It's open source, and it stores metrics essentially and allows to kind of query them and do alerting. You can think about that as like scalable version of Prometheus, which we use underneath. So the story is as it goes here. So we have multiple microservices in this Thanos system, and one of them is called Compactor. Again, it doesn't really matter in this context of the talk, what exactly it is doing, but it is just doing some processing work. Lots of computational work, right? It has to compress, compact the data periodically, maybe do some retention, maybe do the downsampling of the metric data. So pretty useful thing in the system, right? And the point is that it is computing a lot of data, a lot of data, and we're talking about gigabytes, sometimes terabytes every day processed, pulled from network, processed, and so on in the memory usually. So as everything goes, in the very beginning of Thanos, we had issues with this, with this component. And the first iteration, as always, was kind of successful. Everybody started to use it, and like at some point we saw problems, we saw issues. Like people were claiming that compactor is ooming, so essentially making just using too much memory, more than surprising amount of memory, essentially, right? And that's not kind of like uncommon, not surprising to like developers, because our initial implementation, as usually it is, was very naive. We just want to have a POC, just see if this is even working. So it was naive and inefficient implementation, right? However, it was just working for majority of people until this point, right? So what happened? Like you can see that more and more users were starting to kind of showing, hey, the graphs of memory, and like, hey, why it's kind of ooming. So definitely that was a problem to solve within the project community. So something has to be done, right? So what we did, we had like long discussions what to fix, and what solutions we could apply. Like our system is not efficient in this point. And what I found very interesting, and I didn't notice in the beginning, but now after years of experience, I found out that there are some patterns of the suggestions we saw within the community. And I just want to highlight, like, the suggestions, the discussions we had was not only with developer team, but also with users who usually are DevOps, SRE kind of type of roles, architects and managers, and like everybody involved in the situation. So some community members perhaps said, okay, let's just give me the configuration that works. Like just give me the flags I have to specify and to make it work, right? So one kind of area of optimization is to find a right configuration. And I'm kind of surprised. I'm not surprised why this happened. Like, if you look on Java JVM with so many tuning performance options, where literally some companies have to create a AI system or machine learning system that actually try different flags and to find the configuration that works the best, like do this tuning. We see some systems that can have a better kind of efficiency, better kind of cheaper execution, use less memory if you configure your garbage collection properly. But in Go, and especially in the new projects, there are no flags like this, like useless memory, useless CPU, please. Like like it's not like if the implementation is inefficient, it is inefficient. Like there is no flag to change it, right? However, some people try to kind of suggest this. Second suggestion is to just don't do any work. just scale your node, like put more memory into this. And by the way, that might be a fair solution for many, because it doesn't need to changing the code, releasing new version, and so on. Some people are happy with running bigger nodes. Unfortunately, you can imagine this is not sustainable, right? Like how large you can make it until you will run out of machines, or it will be super expensive to run. And essentially, this is not. You cannot infinitely scale up like this. We call it vertical scale up. So adding more memory to a machine
Hello, I guess we have a problem, so let's wait a little bit. By the way, what are we enjoying the conference? You know, the live, the internet, things like this always happen, right? So hopefully he'll be able to join as soon as possible and to talk more about how to approach software efficiently problems in 2023. After that, we're going to talk about the new generation of data store. And to finish, we will cover staff plus engineer. It's a new trend around tech career where we're able to cover several details, especially after a post senior engineer. So usually we talk about how can we stay a senior, and then the next step staff, principal, and finally distinguish. So let's wait for a couple of time. Okay, he's reconnecting. Let's wait a little bit. Okay, let's wait more 3-4 minutes, otherwise we're able to start the plan B. By the way, do you have any question? Please put your question here. It's a nice opportunity to answer your questions, to talk around some topics. By the way, what are you enjoying so far at this conference? Please let us know. And by the way, it's an amazing opportunity also to grow your networking. Please follow. Oh, he's back.
Oh, wow. Thanks. So sorry for that. I think that's actually
It's happened.
inefficiency
Don't
of the
worry.
software. That's what happened. Can you hear me well now?
Yes, I can.
Let's go. Let's continue. Sorry. Okay. So give me a sec. Okay, so I think we finished on using too much memory, and kind of like a second solution that was suggested by the community is to just put more memory to the problem, like ignore the problem and just pay for it. And I mentioned kind of like limitations. So one thing that I kind of didn't mention is that there is overhead, or like always like managing a large memory heaps is not like free. There is like much more effort by garbage collection and like mechanism in the operation system. So you want to avoid that, honestly. A third kind of suggestions by the community was to scale out. So instead of scale up, like adding more resources to the machine, we perhaps want to scale out. So maybe split the computation into pieces and stream it kind of stream it into multiple nodes, into multiple kind of machines, right? And again, that kind of like might be a good solution for some problems, but we can use smaller machines and more of them, but there is complexity, right? And there is coordination problem, which is an overhead, major overhead in the systems, and it's complex to build, it's complex to maintain. You have a network partitioning, you have like lots of Kapci kind of problems to it's not the solution for everything, right? And you still have to overpay a lot. You just split the costs into multiple machines, but at the end you pay the same or even more, right? So what else you can do? Like another suggestions from the community was to just switch from Thanos to something else, from the project to maybe Cortex timescale. Like there are other kind of solutions that kind of sort of do the same or like similar. perhaps, and those are like open source solutions, but perhaps they can also move to managed service, like totally forget about those problems with compactor and solve the same thing with just using different system, right? And of course, there are benefits, but there's also consequences. So, there's huge engineering cost to learn a new system, totally new system. You might kind of like find that some things are good, some things are better in this vendor, but actually like missing in their kind of solution feature set, something that was in Thanos. So, and maybe something is actually faster here than there. It's not obvious choice, and making this choice and jumping from different project, like it's not always the best suggestion. I mean, the best thing you can do to optimize and fix your efficiency problem, right? And all this was happening, in the compactor. This discussions was happening in a different, different kind of like what we should do. Whereas in the code was looking like this, right? We literally have like maybe very simple naive implementation that was causing the problem, right? And just creating this problem, maybe a memory leak. And it turns out that was the solution. Like we just had to sit down and kind of like, it was actually a contributor who just proposed a streaming implementation for all of this. And and it worked. And the funny fact is that we were so close on approving and merging a very, very, complex scalability kind of solution for the problem that required like some kind of changes to algorithm, right? And if not this contributor, we might accept this complexity much sooner to the project, which probably could block adoption and kind of like make a lot of troubles, right? So I just want you to realize that there are some easy solutions from now and from time to time. And like literally yesterday, I was like scrolling through Hacker News, and the first item was like, hey, how I made the program much faster by just one line of code. And for example, here we just escape. We kind of avoid escaping to heaps, so we kind of put some memory into stacks or like reuse some memory. So it's much kind of like more resilient. And sometimes if this piece of software is like a critical piece of software, then critical part of the software, it might yield like huge improvements to the overall system and might stop you from thinking of changing the project, which is super expensive, or vertically like increasing the machine or any other kind of improvements, right? So what I want to teach you here is that software efficiency enable things if you do it right? And something I really want to mention as kind of this closed box problem. So I don't have now kind of a lot of time because of this kind of like network problem to go through this, but roughly, there was this quote. Maybe you remember this quote: premature optimization is root of all evil. And this is where it was like so long ago, but it was still kind of repeated. And there was this mantra of like developers should not optimize the code until it's like super necessary, which in practice meant never. And this kind of created a lot of troubles, I think, in the community, right? And developers were really not educated, were not prioritizing optimization because of things like that. And I would argue that we enter the era where it's bigger risk that we are prematurely scale things and jump through projects than actually prematurely optimize the code. And I think this is why we have overspending nowadays in the cloud, especially in the cloud, where we just put some software and let it run. Things will scale, but suddenly you wake up in a recession, and you have to let people because there's so much kind of cost you incorporated through those services, and they're not obvious how you optimize them, right? And we unfortunately live in the era right now in the recession, and all companies reduce the cost. And I see that by travel cost reduction. I was like in KubeCon in Detroit and PromCon in Monachium. Less and less people are kind of coming to those events, any events really. There are freezes in terms of hiring and straight up layoffs. So every company is optimizing in some way. And I think, by the way, it's a good time to be an engineer who knows how to optimize systems in terms of cost. The demand is very high. And it's kind of like super important nowadays, right? Especially nowadays. we see kind of like Elon Musk also making some kind of cool stuff around specific stuff around optimizations. They, apparently, this kind of top priority on his list as well, to reduce cost of like infrastructure with some kind of maybe less random or more random ideas. And especially the idea of like on the bottom where, he kind of mentioned that finally maybe we can remove this, what device a tweet was written on, like, hey, I've written on iPhone or written on or whatever Android. And that's actually a cool optimization. You are removing feature which is not that useful sometimes in order to save money. And that's a cool optimization. It's just, there are so many optimizations to look on. And we sometimes prefer, this kind of scalability and project jumping versus maybe, code optimizations, which are kind of like maybe simpler. So there are 4 things I want to share, and I don't have a lot of time, but let's try. First thing is that there is such thing as optimization levels, and you can think that your system consists of many levels, systems, algorithms, implementation, including compilation and operating system and hardware. And you can apply optimizations on any of those, right? Not only on system, not only on algorithm, right? So system optimization is when you maybe tune configuration, maybe you scale out, scale up, maybe you change the project. This is kind of like very, sometimes big changes, sometimes it's very useful, but sometimes if you only look on those, it might be harmful. You could also rewrite in Rust as well. That's also like optimization on system level. And you can remove a feature. This is a sometimes fair optimization, right? Algorithm level is when you think about, algorithms and change algorithm without changing maybe implementation system. And this is where we think about, complexity, asymptotic complexity, like generally how my algorithm is kind of like working with the data, like in a kind of like, how the data complexity grows with the data growth. Now implementation, so I can have like a very solid algorithm, but implemented poorly. Implementation, we kind of discuss, the performance of it in terms of like real complexity, how exactly, things are taking, our memory or time based on the variables we have, based on input. So we don't always talk about that. I think we should talk about that more. We can represent the implementation, the actual solution in terms of numbers, very, very maybe easier than when we thought. And of course, we can change operating system or like configure it in a different way. That's our optimization on this layer and hardware and so on. But my point is that we used to focus in the closed box kind of area. I call it closed box because this is the moment where you're maybe afraid of touching your code. There are also other extremes where you are afraid of touching anything else, like you're afraid to maybe abandon your code and move to another system, move another thing. That's also kind of wrong. I call it like my baby code, like, maybe happens in some, for less experienced developers or maybe competitive programming. And I want to teach you that it should be a balance. Like you should have overview of all your options, like try to professionally, without emotions, think about all of them. And, but don't the scope algorithm and implementation, because I think it's the scope recently much more often. And you should kind of like apply a right mindset and tools to all of those levels. Speaking about mindset, like a second tip from me is optimization flow, like following a process, TFBO. So what it is? So TFBO is something I wrote in my book. It's essentially test, fix, benchmark, optimize. And it's essentially like a test-driven development. So, when you apply tests before your actual development and then you fix those tests, this is kind of like extended to benchmarks. So benchmark-driven optimizations. And it looks like this. You have loops, right? So you have first, you start on the left, you test things because we are following TDD, because you want to ensure that whatever your work, you have prepared, test suite for your work. It's just easier to iterate like this. Then if it's passing, there might be no implementation actually to to be done. Like no fix to be done if tests are passed. So maybe that's okay. So, but then if there are test fails, of course you are kind of have to fix it and then loop over. Once the tests are passed, we are going into this efficiency phase. So we perform benchmark. We start with the benchmark, like benchmark-driven optimization, because you don't want to kind of like work on optimizations if it's not needed. Maybe benchmark actually show that everything is fine. So why are you even like bothering? And if it's not fine, if the benchmark, if it's fine, then we just release. If it's not, we go into optimization phase where we have to find a bottleneck, like what's the most critical part, the most important part to optimize now. Then we try different optimizations, and you kind of follow the whole loop. Because if you skip testing, well, you are, for example, like maybe gaining some efficiency gains, like maybe your code is using less memory, but after all this work, you realize that you broke an important feature and functional kind of characteristic, and then you have to rewrite everything. So it's very important to maintain this process. I really suggest you to do this, and all the algorithm level and code level optimizations are much easier these days with this. A third one is goals, right? Like what is happening is that within this flow, at some point after you benchmark, you have to compare the result with something, or just see the result and, okay, is this okay or not? And that is very, very hard, right? Because, I see that my application is responding in half a second. Is it fast? Is it okay or not? I don't know, probably YOLO, right? This is not a correct goal. People try to, maybe find some goals in terms of like, reasonable amount of memory. But that's kind of also like if your program is using, if you're part of your program using like 200 megabytes of heap, is it good or not? The answer is it depends, right? If this part of code is used in something very important, it's probably too much. If it's using only kind of like from time to time, maybe that's fine. So you have to kind of find out the correct goals. It's not easy. It's kind of like people are procrastinating. Even I'm procrastinating on creating those goals because they're kind of like maybe set expectation for your failure or things like that. No, we should be more kind of brave here and really talk about real numbers, right? How much complexity we're aiming for, because this will be super important when you are designing a bigger system, which incorporates your part of the program, and you want to kind of calculate, your as a dependency, use your program as a dependency. Those numbers, so now you can rely and have a kind of complexity or like estimated efficiency of the whole system. It's super critical, and it tells you when to stop, and maybe you don't need to even start optimizations, right? If your benchmark is already fulfilling this requirement. Finally, the point is observability, right? I'm kind of was in observability for so many years, and I cannot live without that, right? Especially this TFBO, so test, fix, benchmark, optimize flow, require a lot of observability to make it like super effective. And there are lots of things. There are kind of, we talk about 4 signals, observability signals: metrics, logging, tracing, and profiling. I added some open source project you can just use, and I recommend them. They can be spin up in your system in minutes, and you have all the observability you need. It can be overwhelming on the scale. It can be expensive. So that's why my recommendation is to start with metrics when you want to check the performance of your like benchmark on assess performance or efficiency of your system, and then profiling when you want to find a bottleneck, right? So you find kind of what part of your code consume the most the biggest number of memory, or like was the slowest, right? So this is my recommendation. So to sum up, the main takeaway is to think about software optimizations as a whole. But also don't descope the coding and algorithm. Every code nowadays, or like most of the code, if you are following some good practices, is in open source. You can totally fix it, optimize, or at least like discuss optimizations. So don't be afraid of that. It's actually much simpler than jumping through projects, than complaining and being stressed, than maybe scaling things and ignoring the problem, right? So I really recommend you to look at this code. Don't be afraid of the touching the code. So utilize all levels. Sometimes code is not the right option. Maybe you should scale out. You should actually remove feature. That's fair. Those are fair options. Secondly, set the clear goals. Like, have that number you are following and either be happy or not. You can negotiate this number always, but don't just YOLO it and like be afraid to set this goal, because then it makes everybody's life much, much harder. Follow pragmatic process, like test, fix, benchmark, optimize. Have a loop. Make sure you don't skip those tests, unit tests. Don't skip those benchmarks. Those are important things. And finally, invest in observability, right? You don't need all the tools, but just maybe focus on the first, iteration of metrics and profiles. You can get them very cheaply on your, on your clusters within, again, minutes, with the links I provided. So really, really think about that. Okay, and that's all for this talk. Sorry for disruption. I hope you enjoy it. Thanks for joining me. There are some links to either ask me a question, or you can look at the book, or really anything. And see you in open source. Thank you.
Oh, great presentation, especially around premature optimization. It's happened all the time. And by the way, great book. I read other one, so I read after this conference. So everybody, please, it's a nice talk. And thank you. We're gonna have a Q&A session soon. But right now, let's go to the next session.
Thank you.
Thank you. Bye-bye. To cover the new generation of data store with Alexander.
Hi.
Hello, Alexander. How
Good
are
day,
you?
good day. I'm good, thank you.
Oh, so the stage is yours. So have a nice
Alright.
show.
So let's share screen.
Let's use my power.
All
Here you
right.
go.
Power accepted. All right. Thank you, Otavio. So, yeah, let's dive right in. So this session will be about the new generation of data stores, which is sort of a meta title. What I really want to talk about is kind of the shift happening in data stores, like moving more to the cloud and becoming cloud native, whatever that is. And we'll cover the next minutes basically with that. And it will be a lot about concepts of data stores in general, of data stores in the past, and also like why they are kind of moving into this direction right now. And if you have questions, feel free to put them in the chat. I'll try to take a look every now and then. But again, we have the Q&A later on, so I'll be definitely there as well. So that's the plan for today. I want to talk about the cloud native shift, why it's happening, what is happening, about the huge technical implementation that those new generation of data stores has basically been done, and that is splitting storage and compute from each other. What does it mean? How does it work? Where are the issues with this? And of course, like the impact that this kind of changes have on our everyday lives as developers, as people running companies, and also where there are the threats and problems are. So hi there, I'm Alex. I'm based in Germany, been working remote for almost a decade now, spent that decade pretty much at Elastic, and now recently switched to Firebolt, which is a distributed cloud data warehouse. And I'm a huge fan of databases and distributed systems in general. It's basically also why I do this talk. I've seen this shift happening over the last couple of years. And coming from Elasticsearch and from the core team, I'm also a huge JVM fan. So let's think about the cloud. Like, we've seen the shift happening over the last years, right? Everyone is deploying applications into whatever cloud provider you have, whatever your strategy is. And people started with migrating applications, like the classic lift and shift, as it's called, and getting the applications ready for whatever cloud environment, then running it there, and then kind of having the next steps of optimizing it, like adhering to that architecture, making it cheaper to run, cutting costs if possible. And often it was about the application, but it rarely was about the database, right? Or the data store that you use, be it SQL, NoSQL, it doesn't really matter. But you usually brought this data store with you, and then you just placed it somewhere. Sometimes you ran it yourself, sometimes by the cloud provider. But the usual strategy was like the database is the last thing you touch with your migration strategy. And then, of course, like the cloud providers want you to consume more cloud services over time. Of there, it sometimes helps you to save costs, but obviously it's also a vendor lock-in there. And the data stored in the cloud, you kind of have a couple of choices there. They're the big cloud providers. They usually offer you some kind of data store, be it a SQL database or their custom implementation. And the basic thing here is it's often minorly modified because it needs to adhere to the existing control plane of the cloud provider. You may have a version lock-in because there's like an older version available, not the one you would like to use with the newer features. And that might be an issue. Then you have database providers nowadays offering their data store as a service, like pretty much everyone is doing it. And again, you might have a version lock-in because it's not the version you would like to run, but it's much more unlikely, right? And the good thing is the database provider are kind of the biggest experts of the database. They're actually developing and running for you. So that's usually a good thing to pick. And of course, you usually still can host anything yourself, right? But it comes with the cost of the whole upgrade complexity, and also with the cost of the maintenance work going on. So there's more to it than just host it. It also means you're responsible for running it and monitoring it 24/7, which still might be a valid alternative out of different or several reasons to that. So when we go back a little bit into time and we take a look at the different data stores and the different types of data stores, like everything usually starts with a single system, right? This is the most simple thing you can have. And you had a single system handling all reads, handling all writes. You didn't require any coordination. It was easy to handle transactions, like making sure something is visible or not visible because it was all within the boundaries of a single system. And of course, you also had this classic single point of failure, right? If this system went down, needed to be upgraded, there was no service. And the scaling strategy here was always scale up, right? The usual system was you buy a beefier machine, you get more performance out of that. And that is how you scale the single system architecture from your data stores. Common example there is Postgres, right? You can go so much with Postgres. This is an insane system from my perspective. It's been there for 20 years. It's just up and running. It keeps improving all the time. So it's a really, really great system for this. And at some points, people thought, okay, what can we do to sustain more reads on our systems? And then people started to decouple reads and writes. So the first step was that you had basically some sort of a leader and follower architecture. The leader was the one system accepting writes, and then passed the information of what writes happened down to the followers, and the followers were the ones used to query for data. And that required some coordination, still not too much. Basically, you just needed to connect with the leader and tell them, like, look, this is the info I need. Of course, you need probably mechanisms to keep up if there were too many writes or if there was an outage, things like that. So there was some kind of coordination. You removed a single point of failure in terms of reading. And you also moved some complexity to the client because the client suddenly needs to know which systems to query, right? You have several endpoints and you would like to make sure you don't create any hot ones there. The scaling strategy now is twofold. Like you still have to scale up for writes, but you can scale out for reads. So that was a major game changer back in the days. And again, common example is Postgres or also MySQL, where you basically had this kind of architecture to make it easier to have many, many readers. So the next step in this kind of architecture was to distribute the data and to replicate it. So I used sharding to divide the data among several nodes and replication to have copies of them. And if you have copies of your data, just with the previous architecture, you have read scalability. You can read more data because it's just more often available. But once you start splitting data across a cluster and you have, for example, 10 nodes, you suddenly have the write throughput of 10 nodes. So that's the major difference here. There's not a single writing component. There's all parts within the cluster which can accept writes. And that gives you scalability in that dimension as well. There's usually no single point of failure because you enter with a fully distributed system. But of course, you now have all the fun of coordination, right? How do you deal with transactions across several nodes? How do you deal with outages? How do you make sure all the data is properly available in case one node goes down? So all of this comes at a price of a classic distributed system. And then you have the zero downtime upgrades because you can do things like rolling upgrades. You can run updates and upgrades of systems or underlying kernels, what have you, without the user actually noticing it. So this is one of the major advantages. And the scaling strategy for this kind of system architecture has always been scale out, right? If you have more data, if you have more nodes, people are just like, yeah, okay, you can scale out because you're using commodity hardware, right? This was kind of the strategy 10, 15 years ago for distributed systems. You just say, yeah, okay, it's easy to scale because everything, I don't need any specialized hardware for that. And that was a major thing in terms of distributed systems. It comes with a price, like the complexity, the coordination, the maintenance, the 3 a.m. on-call alerts where you have to make sure which part of the system is now not working as expected. So there's more work to it, obviously, but when it runs, it's a really good alternative. And one issue with this is that you have more machines to keep your data safe, which is good, but they are also more costly. But in many systems, you're also duplicating your writes, right? And like I take Elasticsearch as an example, because I'll get back to that later. If you write data once, it gets once written. But if you have an index with like 2 replicas, the same data gets written the same way 3 times. And that obviously has some sort of machine overhead or CPU overhead, IO overhead, which basically means you're replicating work that probably doesn't need to be replicated with today's architecture. And we will see later how Elasticsearch is actually tackling that. Reads and writes in this architecture are not decoupled. You basically solve this problem by adding more capacity to a system. But the moment you have a load shift, like more reads or more writes, each of them are impacted by this. And this, of course, is an issue, right? The common workaround in this is in many distributed systems that you have this tiering, that you have really beefy and fast nodes for your current read and write load. And if your data gets older, it's only read but not modified anymore. Then you move this to kind of a slower, not so beefy nodes like warm, cold, and frozen. At some point, your data probably ends up in an S3 bucket. So this is kind of part of this architecture. And then there was a new guest in the architecture, and that was a kind of slight change of things. And many people used streaming as a buffer. So when streaming platforms like Samza, Kafka became more popular, and I mean, before that, we had this kind of trends as well. I just remember the famous event bursts across companies. But like when streaming became popular, many users didn't use streaming capabilities, but just the buffering capabilities in there to make sure you had a fully decoupled write compared to the system, which is actually accepting it. And one of the things that brought this on top of the stability was basically the increased cycle time from the generation of an event to the storage. And that's a major difference, right? People suddenly were more okay with this kind of setup where they said, I don't need millisecond real-time indexing of my observability data, but it still needs to be there somewhat on time because I would like to alert on it. And so people understood the trade-offs of this kind of architecture. And of course, whenever you run another or add another system to your architecture, like the complexity of this architecture increases, but that's just the nature of it. So when you take all of this into account of the past, what is the goal when you nowadays would write a data store, no matter what the task of the store is? Like one of the things you always would like to do is decouple reads and writes, right? You have the independent scalability. You can like power down or scale them, add more or less of them depending on what you do, and that's a huge advantage. The other thing is like you really would like to write data only once, right? Like why wasting more CPU, more IO, or whatnot when you don't have to? So writing data once is an important part of a efficient system. And also you would like to share the storage among readers, right? Like if you write the data once and you would like to decouple reads and writes, the readers have to read this data. You would like to have less coordination. You can't have no coordination. I'll have a couple of slides at the end to show that. And the other part is you don't have these tiers anymore, like hot, warm, cold, and frozen. But you basically have tasks, right? You have an indexing task, you have a querying task, you have maybe a cleanup task that's doing a vacuum on a database or merging of segment-based data. So like tiers are not there anymore because the storage is basically the same everywhere. You can do things like cross-region replication if you have to, because you're probably just piggybacking on cloud infrastructure. And the major goal of all of this, at the end of the day, is cost reduction, right? It's staying competitive, staying in the market. And that brings us to the hyperscalers. Like the hyperscalers are the big cloud providers, and like they have been major advancements in the last 10 years, right? Like just think about a service like S3. S3 has been around for a really long time, but it has improved tremendously in that time, right? Like the semantics has changed. At some point, you can be sure on S3 that when the data is written, it's immediately visible to every other reader. And that's a major change that wasn't always like that. So because of the advancements of object storages, we can basically now think of them as a replacement for replication within any database application. And that's a major difference, right? These advancements that obviously were available to the hyperscalers way before they made it available for users have a major change in how applications work. And also price drops, right? We have constant price drops going on in terms of costs for storage, for CPU, and this still continues. Maybe there's a stop at some point, but right now it's still running, and you can see the prices keep dropping, and that makes it obviously more competitive to use these kind of storages. And also, like hyperscalers are the one like making the rules from my perspective, right? Like they have the absolutely biggest incentive to drive down the cost of a service, right? If you save money and run like a tenth of your instances in the hyperscaler world, this will end up with a lot of money. They also have the biggest incentive to scale down to zero, right? If a system is not doing any work, stop it completely. Don't waste any resources on it, right? Again, the hyperscalers are the ones who have the biggest incentive to do that. And they've always been drivers for this kind of changes. And like you can see that a lot of open source databases, they are created by former engineers at those hyperscalers with some years ahead or some years later. Because it has been implemented. Think of Kubernetes. Kubernetes is probably a very direct successor to an internal management system at Google, like Borg. So they are ahead and they make use of that. But at some point, like things flow out of the hyperscaler into the world, and then people implement it over there. And the same with scale to zero, right? This is nothing new. Like think of runtime environments where you can scale to zero. I think the most common known one is AWS Lambda. It now is 8 years old, right? It was presented in November 2014 in reInvent. So it has been there for a long time where it can run a piece of code, and after that, everything gets shut down. And for databases, it's a bit more complex, but AWS Aurora has also been released 4 years later. So it's been around for some time. And the incentive to scale to zero from a hyperscaler perspective is just there, right? And to me, they basically marketed this as pay-per-use, but it's just a drive-by effect of a major cost reduction for the hyperscaler, right? Like the whole pay-per-use thing, how it's marketed, you only pay for what you use, is a side effect that allows you now to finally calculate how much resources were used, and that wasn't possible before that. And if you take a look at the data store, I think it's kind of clear of what it needs to do on a high level to be able to scale to zero, right? You need to shut down an instance without losing data. It shouldn't take a lot of time. And also the startup needs to be really, really quick, right? You want to be in the single-digit seconds at most to start up a service again, probably even faster. And that implies that you split storage and compute because you can't store any data on the local storage of an EC2 instance or whatever. It needs to be stored somewhere else. Otherwise, a shutdown removes the data properly. Yeah, storage is just a shared thing. Again, there's like 20 different ways of sharing storage in most cloud providers. So you have to figure out which is the right one. And if you share storage, you have to make sure like your strategy of writing data is so that you can always read data, that access is basically free, or that the concurrent access is free. So that you have like, it doesn't matter if you have one reader or 100 as long as the data is available. And also you need to have good strategies for writing data so that you don't overwrite data with each other. But all of this can be solved, right? The one big thing here is that it's slower than local storage. And that's one thing to keep in mind when you have any networked or remote storage, and that is especially true for object-based storage. And that implies that you need to basically adhere to the rules of your object storage. And things like a full table scan where I just go through all of the data, like this is extremely inefficient and will also be extremely expensive. So you have to try to find ways of not doing that or even forbidding that in your system. And also you need to optimize for how your object storage is accessing data, right? You can't just read the data file from beginning to end, then it's in the file system cache, and then you can repeat it. This is not how an object storage works. You basically have to figure out, do I have the ability to only read a tenth of the data and only read what I'm really after, right? You have to split a file in ranges and only retrieve those ranges. So it's a very different thing compared to a local file that you can read. And the interesting part of this is that whenever you introduce an optimization that will not only need less CPU I/O, but also fetch less of your data, you will actually lower the bill, because reading data from an object storage will cost money. So everything you do around smarter query plans immediately translates into money. And yeah, there's still this holy gray goal of assigning exact costs to queries and index. But so far, like most of the cloud providers will say, so many operations cost so many money, and it's kind of an average number. But imagine that it's really hard if you execute the same query twice, and first the data is loaded from object storage, and the next time it's loaded from a local cache. Like, how do you build this, right? So it's really hard to give a good prediction on costs, and unless there's a good prediction, users will be very, very about accepting the cost estimate. So talking about compute, the other side, when you execute queries and you need to do computations, or when you index data, so you can basically split readers and writers. We already had that. You can shut them down, but you will always end up with a distributed system, right? This is the one thing you need to be aware of. It's been really, really hard to have a stateless system where you split indexing and querying. You couldn't even do it in a SQL database if you need to support ACID-based transactions in many, many ways. And also, things like cleanup can be another compute instance. We already talked about that. Another big thing is that the local storage, so if you use an EC2 instance for compute in a database, like the local storage in there will always be able to act as a cache, right? You have still a really fast SSD in there in many cases, so make sure you fill up the SSD with cache data so you don't have to connect to the object storage. And if you choose a bigger compute, then the SSD usually will also be bigger, so you always have a bigger cache. So you need to figure out what actually sped your queries up in that stage. That's an important point to keep in mind. It's the same as with AWS Lambda, where based on the number of memory, your CPU gets faster as well. And yeah, one of the trade-offs here with these newer data stores is usually that the latency is a little bit higher, because you don't have this really, really fast file system access. That's one problem on the reading side of things, but also in writing, right? Imagine you try to write like 100,000 of documents or rows or whatever you have per second, then you have to make sure that the write-ahead log also gets written, that it also gets persisted, and that this write-ahead log is either also fast on the object storage, or that you maybe also write this on local nodes, but then you still have the danger of losing data. So it's a trade-off that you basically have to do, how safe you would like your data to be. Does everything need to be in the object storage before you return to the client and said that you acknowledge the write? Of course, this is way more batch friendlier, like the object storages are just better on dealing with bigger data. And it's not suitable for millisecond latency, right? If you have a real-time alerting system, it's a different thing, or a trading engine, than when you're indexing logs that you would like to search on. And yeah, we have the increased latency as an acceptable trade-off. Like, there's a wonderful blog post about Husky, which is the event storage engine from Datadog, and they completely rewrote it. And they said that they were happily trading in a few hundred milliseconds in the median latency when they query the system, but completely eliminating tail latencies like P95, P99 max latencies, like just making sure everything is at the same speed and is more plannable than having a fast storage that has this crazy outliers at the end. And that's an interesting statement. And you just have to decide with your whole data store, is this an acceptable trade-off or not? And yeah, this is just a list of data stores, and I don't want to talk about single stores here, like any complete solution, but based on the categorization, you see like that this whole trend of going cloud native, splitting storage and compute it's across all categories, right? We have cloud data warehouses in there, distributed SQL systems, analytics, an extension for Postgres, log analytics and search. So like it's really all across the board. And that's where you can see that this kind of development has basically kicked in a lot for all of the data stores, because the savings or the cost reductions are just so massive. And just to keep in mind that like we have these systems here, which are all relatively new in terms of when they did the switch to splitting storage and compute. But Google BigQuery is doing something like that, and it's been around like 10 years, right? So the big cloud companies, Redshift, I mean, Snowflake is way newer there, and they use the existing infrastructure. But like the first two, they've been around for a long time, and there's nothing new about it. They were able to basically leverage their infrastructure, and they saw pretty early that the cost reduction is so big that it makes sense to even build own products around that. And yeah, coming back to Elasticsearch from the beginning, Elasticsearch is one of those sharding and replication systems right now, right? Like it's a really fast general purpose search engine, but like data needs to be local on SSDs. There's features like searchable snapshots, so you can search data on S3. But the core idea for now is everything is on the SSD. You have this duplication of writes because you have copies of your shards somewhere. But even Elasticsearch has decided to separate compute from storage. There's a blog post from a couple of weeks ago where they kind of lay out their plans how to do that. And the reason for this is also that other companies who were probably Elasticsearch users, I'm not sure about in both cases, that they basically wrote their own search engines which were adapted to their infrastructure, right? Like just to Kafka, to Zookeeper, to S3, and like NRT search only runs against S3 and using Kubernetes on top of my head. And like the part here is that these engines saved a lot of money because they are so specialized. And for a system like Elasticsearch that is very generic and should be used for a lot of use cases, it's much harder to go there, right? Like the whole step of retrofitting is really, really tough. So if you have an existing data store and you're like, oh yeah, make sure it's like I make it cloud native, like that's a really massive undertaking and that will take a lot of time, right? And even the blog post here states that the proof of concept was just multi-month and experimental phase. So like taking your data store and like splitting storage and compute, it's not easy, right? And this is also why we rather see probably new data stores and extensions to existing ones than like data stores completely moving over to that, because it's such a massive project to sort of change your internal architecture. And yeah, that still brings us back to the question, why are even companies doing it for their existing systems? And it's very obvious that you would like to stay competitive in pricing compared to the hyperscalers. And we still have this data explosion going on, right? I expect in like 2 to 3 years' time that like storing and querying petabytes will be a rather normal thing to do, not only for like really rare ad tech use cases, but really for many, many users. And this means everyone still has to reduce resource consumption. And you get a few more features on top of that. If you don't delete your data, you can kind of branch your data from any point in time. That's a feature that, for example, Neon, that Postgres extension to split storage and compute has, and it's super interesting to see that you say at some point in time, you just say, I want to branch my data here and maybe move it over to my pre-production system or whatever, and take a look at the data. And that's an interesting feature that wasn't really possible before. And of course, there are companies who would like to have a differentiator and who use this for their software as a service offering. And that brings us to the downsides of this trend. And one of them are the hyperscalers again, right? Because they are a threat to open source from the recent developments in the years. And that will not be a stop for databases as well, right? The basic problem is that hyperscalers like offer existing open source projects as software as a service without contributing back. Like this is usually what people complain about. Like from a law perspective, this is perfectly fine. It's correct. But of course, there's often outrage because like a big company like that should be able to contribute back. And this is where things get complex because many of those open source projects are backed by venture capital, and then you have sort of a conflict of interest, and people are just talking about the license. And the reactions to this in the last years were pretty unique, or not unique, but homogeneous from the big companies, right? MongoDB did a relicensing, Elastic did one, Confluent did one, Graylog, Grafana, Redis. They all kind of moved to a license which is has still open code. It's not open source by its purest definition, but the source is open. And it basically states, do whatever you want, but you're not allowed to run the software as a service without paying us. There's a couple of other licenses, like from Cockroach or Couchbase, where the code moves to open source after 3 years, but until then it's not, and 3 years are an eternity in IT. But the basic idea is the same, right? Like if you run this as a service, you need to pay us. And in case of Elasticsearch, this led to a fork called OpenSearch with 2 distinct communities, with 2 distinct product developments going on. So that's kind of an issue that I think we will face more often in the future, potentially. And there's an interesting blog post if you want to know more. I'll publish the slides later. And you will see a shift here, right? And I think the hyperscalers are the reason for this shift. Like the monetization of OSS moves more to software as a service, because that's very investor driven. We have open source versus open code going on here. And like I think we will probably see less open source because of that, right? Because companies are less willing to like just put everything on the Apache license on GitHub or things like that. So or you have like crippled products where the control plane is missing, and that's the important piece, and the rest is open source, right? And that also means more black box systems, and the compatibility guarantees change as well, right? Back then you said like, I have this open source system, like this is the license, go take a look. And nowadays the guarantees are more like, yeah, but the dialect is SQL compatible, the wire protocol is Postgres compatible. That's what a lot of companies are doing. And you can just use the existing drivers to access our system. And that's another way of not forking a product. You just have the sort of compatibility layer from an application perspective. And like the one thing from a developer perspective also is like development becomes more complex. You're not free to choose where you run your software, right? Because this new generation of data stores, they probably only run on AWS, GCP, and Azure. But this is a threat for DigitalOcean, Scaleway, Vultr, OVH, like all of the smaller cloud providers, because they are not part of like being in the test matrix anymore, because data stores that are used are actually not running there. And also the other part is like these systems don't run locally, right? They are cloud-only service. And this means testing locally doesn't work. Fast feedback is like not so fast anymore because you have to connect to that system. Offline development doesn't work, which usually is not much of a problem, except for train rides in Germany, probably. But I think that's one of the issues to keep in mind with. If you have pre-production systems, you also need additional storages for that. But hopefully no one has pre-production systems nowadays too much. But the main thing here is, to me, like CI runs suddenly have a cost attached to them. And you get incentivized in the wrong way because you try to do less CI runs to save costs, which probably is not what you want because your product quality goes down. And that's an important thing to keep in mind, that, this is an issue that you need to think about, right? Is there a way of like not or paying less or having a data store with less stability and less performance for all my test runs that costs me less money, or I'm willing to pay the same amount for every developer, the production system, and each of my CI runs? And that's a trick question. And like not a lot of the providers of software as a service have a really good answer to that, right? And that's something you should probably think about as well when you're planning the costs of a service. It's not just the service that may be cheaper, but the development costs need to be factored in as well. Debugging is another issue. I don't think that's too much of a problem. But there's like, it's just much more of a black box, but that's what every software as a service is. It's really hard to guess where bottlenecks are. Like, is it the remote storage? Is it the burst of the network that happened? Some cloud providers have some sort of burst rules that you can have faster network access for a short amount of time, but then it goes down again. And all of these kind of things you suddenly need to know when running those systems, which is fine on the one hand, because you're running them anyway, but it's always something to keep in mind. And when we take a look at the architecture, like, again, everything looks simple on these fancy architecture diagrams, which is something that usually hide the real world problems, right? Because, like, take a look at this. We have our data store that has a writer. It's storing in the object storage. It's fantastic. And of course, we have our reader that reads the data from there. We can probably scale our reader so we can serve more requests per second, minute, whatever. And we can scale our writers, but that's only half of the truth, right? The complexity are the errors, actually, and maybe you need some sort of coordination. So let's take a look at a couple of use cases that you usually would like to cover with a data store. Like, there's the append-only use case. I think this is probably the most common one for logs, where you just get log files or log data in and you write it and you just append everything one after the other. And the question is, like, when is a write done is something that the writer needs to communicate to the readers, right? When can the readers read a file or a resource until it's done? And yes, there are ways to do that. But if you write multiple files, you still have to keep in mind that probably moving data is not atomic. So you have to keep the order. And unless a certain file is there, the reader doesn't read it. You could also think of notifying the readers. So they talk to each other, but then we have the coordination issue going on. And still, it would probably make sense to do so. Updates and deletes are kind of the next thing to do. So usually you don't have in-place updates, right? Once you have written files, you basically append documents and mark the existing ones as deleted. That's how you most often do updates, because you never know if the new data fits into the old one. So that's why you rarely do in-place updates, and sometimes they're also expensive in the file format that you write. So again, you have to notify readers of new data, because the one thing you really don't want to do is delivering out stale or wrong data. And this also means if you use your local SSDs as a local cache, that needs to be invalidated as well, or like make sure the old data and the mark as deleted data gets delivered to those. So like, there's many things where you just have to make sure that there is coordination, and maybe you can solve a fair share of things by how you structure and write the data in your object storage, but maybe the components also have to talk to each other or with a coordinator. Yeah, the same for like a cleanup and a vacuum process. Like, if you want to remove data that you don't need anymore because it's too old, or data that is marked as deleted, or you want to compact data to sort of bigger segments because they support better compression. There's many reasons why you would like to do something like a cleanup and vacuum. How do you figure out it's in use, right? And on a file system, you have this notion of inodes. Like, if a process opens a file, there's a counter in the file system that like keeps the number of openings of that file in mind. And data is only removed if the count is actually 0. So a file is just kept open, even if you delete it with RM. And that's a semantic you don't really have on object storages. So keep in mind that this needs communication as well. And you may need some sort of coordinator that gets notified, that notifies others about what to query, that triggers merging and vacuuming, because this coordinator has kind of a state overview of what can be written or not. And then you need to think about, like, what do I do when the coordinator crashes, right? And then we are back to like our cliche distributed system problems. Where do I store this information? How do I make sure like crashes don't affect this? And you see, like, the complexity is basically back at another stage, and that's really important to keep in mind. Yeah, of course, you can always embed a coordinator into another role. You could also have like one system which consists of reader, writer, vacuumer, coordinator, and just run everything in one system and then spread them as needed. It's just something to keep in mind when dealing with these systems. All right, let's go to our summary. I think despite all of this, the whole trend of having cloud-only data stores will continue. So there's no breaks on this, right? Like, the cost savings are so massive compared to many on-premise data stores that like there's still like a major area of research and development going on, and that we will see further spin-outs from developers from the hyperscalers, which will show new systems with regards to what they are capable of and how they store data. Yeah, we will see petabytes as a commodity in the future. So especially with the cloud data stores and especially with the storage costs going down, I think that's a question of time. The whole issue around resource consumption for CI and development is kind of an unsolved problem. How you can create this as a compelling offer from a data store perspective, not even from a user perspective. But you need to be able to quickly spin up instances, use them, spin them down again, and make sure like you have some sort of cost control for CI and development from my perspective. And that's something that not many systems really care for because they have this one live instance and that's it. And yeah, I think offline development in general will sort of cease to exist. You see that the cloud IDEs are on the rise, and this is also the reason why the cloud data stores will not really care for what is about to happen on-premise hardware. All right, so if you have questions, I saw there's a fair bit of chat. I will go through that in the next couple of minutes once I'm done. Before we continue, there's maybe two resources that are super interesting. The first one are the database talks from Carnegie Mellon University from Andy Pavlo. There's the course introducing into databases and concepts. It's fantastic, but there's also so-called vaccination talks going on where each developer of any of the data stores out there presents how they basically made their data store fast, and it's like full of information, so take a look. And there's an introductory book, Understanding Distributed Systems, which is also really, really good. And this is a pretty known one. All right, I also created a blog post of this talk. Again, I will share the slides later. But with that, thanks a lot for listening and enjoy the rest of the conference. If you have further questions, I think we will have the Q&A in about half an hour. Thank you. Maybe it's me, but I can't hear you.
Okay. Sometimes I forget the mute button. That's why I hate technology.
It's only 3 years into the pandemic. Don't worry about it.
But anyway, it was an amazing presentation. Thank you, Alexander. And it was a great vision, especially around cloud. And again, if you have any questions, please huddle for 40 minutes because we're going to have a Q&A session coming soon. Okay? See you soon, the Q&A, by the way.
All right. Thank you.
Okay. Let's go to our last session. Right now, let's talk about career. Of course, we are in Architect Summit. And of course, to be an architect, you need to think about our career, how to increase ourselves and the skills that we need. I know there are a huge amount of architecture definition, but the whole point is we need to mix between a technical perspective and also the communication perspective to make one. So can you hear me now? So hopefully yes. Please say me again if you're able to hear me. Right now I'm sharing my screen. So let's wait a little bit to check if everything's okay. Give once, give it twice. Yeah, okay, now everybody's able to hear me and see me. Let's talk about staff engineer. So how are we able to handle beyond a senior engineer? But first, let me introduce myself. My name is Otavio Santana. I am software engineer and architect, mostly in the open source world. I work as distinguished engineer at Zup Innovation. Zup Innovation is a Brazilian company who has the goal to help you to get more productivity and making tools around developer experience, and also to provide support, especially around technology. I usually think about the philosophy to write history-based software. That's why I decided to have several open source projects, such as Apache and Eclipse projects, writing some specification. For example, I'm part of executive member of JCP since Java 8. And because of that, I received several awards. But today is not to talk about me, right? Today to talk about the career, and especially the technical career. And when we talk about career, we have several generations around it. I guess if you have more than 10 years of experience like me, you saw the first generation of the tech career path where we start as early career engineer and then go to the mid-level senior, and there is another way. There is no another way. You must go to become a manager. Therefore, uh, you might be a good or a bad manager, it doesn't matter, especially because there's not another way. Hey Otavio, I want to keep as I want to keep coding. Doesn't matter. You should go through the management path. It was a loss-loss situation where sometimes the company lost the best engineer in the company and got the average manager instead. So everybody lost the opportunity, the career, and the productivity that a good engineer might do. With the time, we're able to see how important technology is around our world. We were able to see the technology as strategic resource to everybody. Right now, it's impossible to see the world if without software. Everything is around software. We saw several companies who said, "Okay, my company does not make software." To 2001 by Forbes that said every company is a software company. And then we moved to every company is a data company. To finally, during the pandemic situation, we saw that every business is a software business. Right now, it's impossible to run any kind of business opportunities if without software, right? So software is important. We need to also check out the developer experience market because right now we have several tools, several languages, several database, several cloud vendors, and when we have a huge amount of tools, sometimes make it even more complex. And welcome to the paradox where we have several tools that are supposed to make our life easier. However, it makes it even harder to us to choose the right tool to the right moment to the right time. As we saw in the previous presentation around efficiency, the cloud is supposed to make our life easier and cheaper, but sometimes it's not the real world, right? Again, the developer experience become a market. So we have a lot of choice. And you become the paradox of complexity. You might can relate that with the polyglot systems. The analogy that I have on my mind right now is Netflix. I love Netflix. Sometimes at night I love to watch something at Netflix, but usually I spend more time choosing what I need to watch than watch the movie. Sometimes I spend 1 hour to choose the movie or the series, and I fall asleep 3 minutes after choose that movie and start watching that. So because I have a lot of choice, I spend more time choosing than exactly watching or choose the right technology. And in the past, like 5 years ago, the real world was a simple output in the console of any kind of language. Right now, the hello world is a microservice integrated with Kafka, with blockchain in the cloud, using Kubernetes, and a lot of stuff around that. So a hello world become complex, especially to the early career people. Why? Because it's hard to choose the right tool to the right moment, especially when we don't have experience to do it. And of course, we as engineer, we as an architect, we love to do technology stuff. We are tech people, right? However, it doesn't make sense that we write our code doing LinkedIn driven design, or resume driven design. We need to have the right balance between technology with opportunity, because that make our company health. It get us the opportunity to do more innovation process. So again, the right balance is important and it matters to us a lot. Technology with opportunity make us product and business. It doesn't matter area. Remember what I said previously. Every business right now is a software business. So we need to have integration between my e-commerce with the payment system or so on. The right balance matters. And that scenario was born a new concept that we call staff plus engineer. The whole idea around staff plus engineer is to take advantage of more engineers who got more experience, is able also to talk and to have a nice skill communication, who will be able to do architecture, will be able to architecturing the whole organization or the whole company. It became famous because this book here, The Staff Engineer, Leadership Beyond the Management Track by Reelsen, where this new career, where we're able to call Y Career 2.0 or just staff engineer, this career has more alignment with the management path. This engineer is more a technical leader. Therefore, he's able to code, to do architecturing, to do design. However, he needs to be more strategic resource. Hey Otavio, but I love to code, but I don't like people. It's happened. Don't worry. And remember, senior is an end. Thus, if you want to finish your career and retire as an end, as a senior, it's fine as well. The whole point here is, as a staff engineer, you are able to still coding. However, you have more alignment with the management path. You become a technical leader, so you need to increase your communication skill as well. And if you want to know more, of course, please read this book, Staff Engineer, Leadership Beyond the Management Track by Reelsen. Why do we have this name? Staff Plus. Basically because it's the path, okay? As we saw, we have the early, mid-level, and senior. Then we're able to go beyond that as engineer, where I have a kind of relationship with the management path career. I have the staff engineer who is beyond the senior, then a principal, and finally distinguished. Okay, that's why we call staff plus, because it's beyond staff. Okay, as you can see here, we have the relationship between the technical area with the management area, where I have the staff. This looks like a head of technology or a senior manager, then a principal engineer who has more alignment with the director, and finally distinguished, where it has more alignment with the vice president. Of course, there's no law, it's not mandatory to follow these rules. Some companies might have a different nomenclature to these rules as well. For example, there are companies who have a fellow engineer. The point is the alignment between the technical area and also the management area. The idea is to not have a post-senior career only to look like a more expensive senior. So we usually had in the past, you using the expert number 1, expert 2, or expert 3. That sometimes looks like a more expensive senior 1 and more expensive senior 2 and a more expensive senior 3. And eventually, those career is not able to be more strategic. So it's just a guy who codes. But if you go to several books, you're able to see the strategic resource like DDD, where we have the strategic DDD or philosophy of software design, where we have the strategic code design that is beyond the code. Okay. Okay, Otavio, you mentioned the career path. You mentioned around it might vary between companies, but how about the impact? I want to become a staff. How the impact that I should do to become a staff, product, or a decision engineer, a principal engineer? I got this from Manfred article. I was able to check the article. It's amazing, beyond the book, of course, where you're able to see the impact between any career level. So staff engineer looks like more an architect who is able to still coding a lot and look more strategic the resource, doing architecture, define the roadmap with the management path and so on. A principal engineer will impact more the product design or the whole area of the director, therefore helping and mentoring staff engineer and helping in the architecture and so on. And finally, the distinguished engineer who might impact the whole business or the whole organization or the whole company itself. So staff, principal, and distinguished. If you want to know more, of course, read the Manfred article around individual contributor guide for developers. And of course, who is a staff engineer? What can I do or what I cannot do? Usually, a staff engineer has no team. He is an expert, and he helps mentoring and guiding people or another engineers to achieve more quality in the code, more quality on the technique, and so on. The main goal of a staff engineer is the impact, especially strategy and result. Be more proactive, care around the whole organization, the whole code and architecture. Of course, avoid waste of resource, like you saw. Avoid resource. He will be able to implement the FinOps structure to oversee the product, the company, and the architecture itself. Remember, the impact matters when you want to go to staff plus engineer career path. We usually think about career to be like a model, to be unique, like a management path. However, in the staff engineer, we don't have a unique path. We have archetypes. We have different specializations. For example, you might be a principal engineer who knows a lot around mobile, and I'm be the person who knows a lot around operation and DevOps culture or CRE. Or there are people who knows a lot around Java and Go. So it's okay that the company has different path to different staff engineer style. It's okay. Indeed, it's important to have several specialization in the organization in the staff engineer chair. Okay. First, let's go to the archetypes. There are more than 4. However, I'm gonna use the book to use samples around archetypes. The first one is the tech lead, who is a person who spend more time guiding a particular team. So he spend more time mentoring, doing stand-up, help everybody to increase their quality in the software, the technique, and so on. He is a sample of the calendar, the weekly calendar of the tech lead archetype. As you can see, this person has several stand-up meetings, like a daily or something like that, and several one-on-one to mentoring people, interviewing people to come in and do the onboarding process. And of course, this person must have time to code. Remember, a technical leader, this person must be a technical person. And of course, the right balance, lunch and childcare and so on. The point here is this person spent a lot of time mentoring people, engaging people, doing one-on-one to people, and of course, they need to do code. I just said previously. Then I have a different profile or archetype who goes in the opposite area. So the tech lead spend more time with people, engaging people, and the solver, of course, spend more time coding. But it does not mean that she won't spend time in mentoring people. As you can see here, it's a small sample from the book where I able to see they spend a lot of time doing deep code, deep design coding, you writing coding, and so on. However, does have one-to-one to mentoring people. So it spend a lot of time coding, but still a technical leader. So they have several team, at least one weekly team meeting, one-on-one meetings, and so on. Okay. And of course, interviewing people, doing the onboarding process, and so on. Again, tech lead, who will spend more time with the engineer team, doing the technical advice and doing the mentoring stuff. Then the solver, who will spend more time coding than with another colleagues. However, it should have few meetings, and do mentoring. The next one is the architect archetype, who is able to do the direction on the critical area of the whole organization. It's usually related to principal and distinguished engineer. This again is a sample by from the Will Larson book, where you're able to see several one-on-one meetings, the proposal of the architecture and the review of this architecture, the team meetings, the organization meetings, and of course, the mentoring step-by-step moment. So it's a mix of architecture, code, mentoring. However, it spend more time doing architecturing stuff. The last one that I will cover today, you be the right hand. This one here is the executive attention. This person will be closer to the OKR of the organization. It will be close to KPI of the organization. Again, it's a sample by right hand weekly calendar, where we're able to see several one-on-one meetings as well to mentoring perhaps another step plus engineers or senior engineers. This person might have several C-level meetings or organization meetings to be the bridge between the C-level and the engineer team to guide and the point what matters to us and matters to the whole organization as well. So this person might be a bridge between the engineer team and the whole organization itself. And you are able, if you wish, you're able to combine these archetypes. For example, I consider myself a little bit of right hand with Arctet and finally Solver. So you're able to create your own archetype. Just have attention on the organization needs, okay, and what you want to do as well. So it needs to be a win-win situation, of course. As I said previously, the specialization is okay that we have several people with several specializations and the staff plus engineers chair. So as you can see, you might have Android engineers, Java engineers, Kotlin engineer, Go engineer, Kubernetes, and so on. Besides, we have the idea of the T-shaped skill. It's okay. The whole computer science is a huge amount of stuff. It's impossible to just one person know everything. The key of the T-shaped skill is not about what you know, but about what you don't know. Why? Because you are able to do more communication to fill up your gap around what you don't know. For example, I don't know a lot of stuff around SRE. I'm not a Kubernetes expert. However, I know who is able to help me on that situation inside my organization. The idea is to fill up your gaps, your technical gaps with network. And again, on computer science, I strongly believe it's impossible to one person know the whole knowledge around computer science. You are able to know broadly a lot of stuff and be an expert in some topics and fill up your broad knowledge with network. I said the difference between staff plus engineers. I mentioned the archetypes. I used the archetypes from Will Larson book. As I mentioned before, it's okay if you don't feel 100% in one archetype. You're able to combine to create your own archetype, but check what the company needs. And I said around the specialization. It's impossible to one person know everything. However, thus staff engineers has several similarities. For example, they work on what matters to the organizations. They usually write in strategy inside the organization. They is the person who will handle with technical quality inside the organization. They will be the people who will be more aligned with the authority inside the organization. And of course, closer to the executives and the C-level organization itself. Mainly because, I guess, everybody talk about Arctet. And the whole challenge here is because everybody has your own definition around architecture. If you go through different books, you might see different definition around architecture as well. So thus here are my favorite books around software architecture. Please take a look. Fundamentals of Software Architecture, the hard part. There is a third one here by Neil Ford around the metrics around architecture as well. But the whole key point is around, it doesn't matter your definition. The point here is architecture is strategic to your organization. And why? Especially because the main goal to be a senior engineer or a staff engineer is to fight the complexity around the system, to make easier to everybody is able to get inside the organization. I know there are several definitions around complexity. I will use my first one by a philosophy of software design. That is, complexity is anything related to the structure of a software system that makes it hard to understand and modify the system. We usually relate scalability with number of applications. And sometimes we forgot people. Sometimes people, company or organization scale the number of people inside, and how we able to grow up number of engineers if without break, if without lost the culture, if without lost the quality of the code or architecture, to make sure that everybody goes to the right direction. With simplicity, of course. As I mentioned, scalability is beyond the buzzword. Scalability, by definition, is to handle a growing amount. I know everybody wants to go to growing the number of database instance, the growing of application instance. However, scalability is beyond that. It's to avoid a single point of failure. It's to growing the culture, the organization growing up, to make sure that everybody's going to the right methodology, and of course, the quality of the code. It does not make sense to rewrite the whole system every 3 years because it's become a legacy. It's become impossible to understand what's going on there. So, scalability, handle growing amount of whatever, it doesn't matter. To start, we have a nice advice to make sure your architecture is scaling. You're able to use the architecture by conversations or the advice process using architecture. Okay, Otavio, but how can I do it? With only 4 steps, you are able to do it. You're able to go through a scalability in your architecture. For example, you're able to apply the C4 model. The C4 model is the architecture's map of your organization. In the Google Maps, we have the country, the state, the city, and your house. So you're able to do the zoom in and zoom out around the map to see where you are, and the integration around your city, state, or province, country, continent, and so on. With C4 model, you are able to do exactly something in your architecture. You're able to see the context, to see the container, to see the component, and lastly, the code. The tech radar is one way to see the technologies that your organization are using or they are studying for. You might be familiar with the mistake there where some people decided to use a new technology to try an interview. He left, and right now we have a system where nobody is able to touch because the unique person who knows how to use it left the organization. And we usually find out that when this person left, when there is an issue on production. Please let's avoid that using some tech radar methodology. So see what's going on inside the organization. Avoid mistake, model, visualize the number of technology that you're using, the ones that you need to study a little bit more, the ones that are mature inside the organization, and of course, the ones that are deprecated inside the organization. ADR, or architecture decision record. Avoid the same mistake twice, 3 times, 4 times. Oh, Otavio, it's impossible to happen. No, unfortunately, it's happened more often than we like. Why? Because it's real world. People left the organization. People get in. And if you don't write the knowledge, you're going to lose the knowledge of your system when the people left the organization. It's not good, right? Please write the decision record on your organization. And the last one is the communication. Of course, we need to have a good communication. Sometimes we need to decrease the number of meetings. Meetings are important, especially to the people connection. However, remember, if you have a lot of meetings every single day, you're not able to do coding. Your team is not able to do coding as well. So clear communication, use asynchronous communication, write documentation, write decisions, and doing that, we're able to be more scalable inside your architecture. Okay, let's move on to, I want to become a staff engineer. How can I, each skills do I need to have? The first one is the one that we usually don't like to, but real. Upscaling the fundamentals of software architecture. You might have a new framework every single day. However, the solid principle is still there. The Cohen's law is still there. The normalization process is still there. The cap theorem is still there. Be pragmatic. Understand the why. Why should I use that? Why should I use that instead of another technology? Of course, achieve simplicity, avoiding over-engineer. It's natural to early engineer to put a lot of technology because they want to use it on production as much as possible. And sometimes we need to say, no, let's use the simpler one, the simpler, and go ahead. Unfortunately, the answer, it depends, is replicated when you become staff engineer, because we need to find out the context to take the best decisions, to handle the trade-off, to raise your hand to do the right questions, to do a better design, to achieve the goal of the business and the organization, to have a long-term code support. The communication. Yes, we need to leave a code a little bit. And we need to have the storytelling. Why? Because we need to have a communication with one way to the director or C-level, and the same information need to go to the engineer team with a different approach. Targets means different communication style. Being custom-centric, we need to see beyond the code. The goal is to achieve success, to be a salesperson. Everybody in the organization is a salesperson. Why? Because or they are selling or they are helping to sell. Okay? Customer-centric is important. Of course, we have several challenges between being a management person or a technical, especially because it needs more maturity. It's a brand new career path. Sometimes there is a fight to know who needs to do that decision around the manager and the technical. The meetings, each meetings, should I go or should I go? Code, and of course, be executive, being closer to the decision. Challenge between ourselves, the communication might be different. Lead the team as a technical person, give space, give opportunities to people get in, to do communications, to take more challenge task. And sometimes we need to code less to guide more. Hopefully, I give you a brief idea around what is a staff engineer and how to achieve that. As next step, I recommend you, if you want to go beyond, become a staff engineer, do architecture, stuff, and so on. Read the book, understand the archetype, find yourself on those archetypes, read more reference, of course. You are able to do it alone. However, with a mentor, you're able to do it faster. Check in your company if there is this opportunity for you, and eventually the company does not have this kind of career path, you're able to switch in between company. It's happened. It's a real world, right? Hopefully you enjoyed this presentation. If you want to know more, I write a lot about staff engineer at my LinkedIn, at my Twitter, and right now I have my YouTube channel. So that's all for today. And I guess I finish on the time to start our Q&A session. So let put people in. Okay, let's start. Let me check the questions. By the way, it's a nice opportunity to put your question right now. So let's check the banner here. Give once, give twice, and let's start. The first question is to Vlak. Is anything going to change in mobile application development in Web3 era? What kind of transmissions there will be in the software architecture of mobile application development in Web3 from Web2?
So first of all, I'm not a mobile application developer or architect. I've never done any mobile application, so it's very hard to assess that. I think we will have during the day more mobile-focused people. But I think that it's for mobile itself, it's not going to change that much because the way I describe the architecture for Web3 applications, as we get to more complex problems and solutions, you need some kind of API or some kind of abstraction on top of blockchain, and that is what you will call from your mobile application. What will change is the way you authenticate requests, we authenticate actions, and that's where the wallet will come in. So depending on what kind of wallet you use, whether it's a hardware wallet, mobile wallet, browser wallet, it will change on how you interact with the mobile application potentially. But from the perspective of the mobile development itself, I don't think that there is much to change.
Okay, let's move to the next questions. What minimum criteria that should I ever build the technology in Web2 prior to switching to Web3?
That's a good question because mostly people, when we start talking about blockchain and NFTs and smart contract, they're like, but I can't do everything like that without blockchain. I can just store stuff in my database or in object storage, and it's going to work the same. Yes, that's what we have now. But the idea is that we will move to a different world where you will actually own the data and you will actually own the identity that is some kind of digital identity. You will own your actions online and not give it to some third parties. And that's what blockchain is there for. It's that distributed, decentralized database where if you are recorded there as an entity, as a wallet, or as a person, and something is attached to it, it's yours. And if you decide to say, no, it's not mine anymore, or you decide to sell it or use it in a way, it's up to you, and it's not up to the owner of the platform, usually, depending on how the platform is implemented, obviously. But that's the goal. So I think the decision whether to use Web2 or Web3 is whether you want to give people true ownership of some assets that you are building. The easiest example is gaming. If you have assets in a game and you want to give people ability to trade them publicly, to own them, to put them as a profile picture, whatever, and have that ownership, and you want to build in Web3. If you don't care about that, then build in Web2 and don't care about blockchain. If you want to give people something as a digital ticket and you want to make sure that it's not that there can't be any fraud, that people can't copy it and use it multiple times and resell it without you controlling that or you getting cut of that, then you need to use Web3 and you need to use NFTs for that. If you don't care, if you just want to make it simple, then use Web2, and it's perfectly fine. It's perfectly acceptable. These things are not mutually exclusive.
Okay, let's go to the next question. How you convince the company management team to achieve code refactoring for optimization instead of scaling infrastructure? Each probably achieves results faster on the system product scope.
Yeah, I think I can help with this. So, generally, the best way to convince management is to provide data, right? So it's really hard to gather maybe those data around, like how easy it is to get to a certain kind of cost factor optimizations on your solution. But generally, like if you can find a bottlenecks, if you are expert in, like, you have developers in your organization which are owning the code, and you provide the tooling and the right processes, like I explained, and then there is a clear bottleneck that can be removed, and you literally can kind of calculate that this will potentially yield 10 millions of kind of like operational costs per year. Then this is kind of like easier to motivate your management versus, for example, paying this 10 millions and satisfying the customer needs, because efficiency and cost of the solution is one thing, and the demand and fulfilling the demand of like traffic is another thing, and those things are actually correlated for sure. So you could optimize your code and fulfill this demand by optimizing your code, or you can scale out. You should not convince your management. You should rather have a clear overview. Everybody should have a clear overview of what are the options, because you might be wrong. This refactoring actually might be not the best option, right? So thanks of you trying to gather data, because maybe you would like to fix something in the code because you see something very easy to change, is great. Provide this data, compare the data with like how hard and how much it would cost to scale things, and also also make sure you factor in the complexity of the distributed systems, of course. And perhaps you would be convinced that it's better to kind of scale out. So what's really important is to try to provide some data, estimate, like napkin math or anything like that, to truly motivate yourself as well, if that's the right decision. That's what it takes to be a staff engineer as well, as Otavio mentioned, right? So to have like this data driven, and like, I like to code those things out, I would like to optimize my code, but perhaps for a business it's not the best solution. So the data helps to uncover those unknowns as well.
Okay, let's go to the next question. Do I lose any functionality or capability after migration to the hyperscale service tier?
Yeah, I think that one's for me. That solely depends on what you migrate to, right? Like in the context of data stores, like whenever you see a hosted data store, it for sure has some kind of different functionality than the one that you run locally. And that is because it has to integrate with the infrastructure of the cloud provider, right? They basically bend the data store's capabilities so it fits their infrastructure. And sometimes it's documented, sometimes it's not documented because you're never going to meet this. But I think that's the most important time. And before you do such a switch, this is exactly what you have to figure out with extensive testing, right? Like change all your tests to run all your integration tests with any database interaction, like right forward to the cloud provider, and see what happens, see what breaks, see where you have to fix things. Maybe you figure out things to speed things up anyway in this process. So I think that would be my approach to that. Like don't flip a switch and say everything works now, but like have an extensive testing. There's also the notion of so-called shadow indexing or shadow querying, where you write your data into your original data store and to your second one, and you also run the queries and you compare the results. Are they the same with the same data, right? If they are not the same, there's probably some difference that you need to figure out before flipping the live switch. And you can do this sort of shadow run for weeks or months until you say, now I'm finally sure enough to flip the switch and move over to my cloud service. And like the preparation, I think, is absolutely important before you do any of that. You can't just, like data stores, even if they claim compatibility, you can never just move over. That's not how it works from my experience.
Okay, have a lot of questions. Hopefully able to finish it in 10 minutes. By the way, if you could short a little bit shorter to make sure that everybody will receive your answer. Let's move on to the next one. Full stack web developer, 8 years trying to get into cloud engineering. Did CNCF Cloud Engineer Bootcamp pass CQA, CQAD, and advice on how to get a role in this space?
Apply. You have with these. I've been basically a cloud engineer for a while at Red Hat, and I have never went through CNCF Cloud Engineering Bootcamp or passed any of these certifications. So you're probably much more educated than I was when I was doing cloud engineering at Red Hat. So probably just apply to some places, connect with people on LinkedIn, and do it. There is not much else you will learn over time, and everyone expects that.
Yeah, it makes sense. Like essentially try to don't be afraid of like talking to people and even applying for roles that you feel you are not maybe you have experience for, because the market is changing. Despite those layoffs, like still companies demand kind of like engineers. So just try. Don't be afraid and just try. And even if you fail interview, always ask for feedback. Why and why you, or maybe even they would not put you to interview. You will learn why, and perhaps you don't have anything unique. Perhaps maybe you are you didn't stand out in the process. Then really try to fix this problem and try to, for example, maybe do some open source work, maybe blog post, maybe just do something unique stuff, and to make it easier for you. But it can take time. Don't worry.
Which type of application are best suited for containerization, like Kubernetes? Oh, it's a tough one.
Bartek,
I mean,
this is yours.
everything can be containerized. I'm not sure to whom this question is for, but generally, ideally, from my perspective, of course, the more stateless your application is, I mean, it's easier. Like that was the kind of like first idea of using Kubernetes. But nowadays, the support for stateful like databases, we run databases really on Kubernetes. There are batch jobs and the kind of like rich APIs and characteristic and this declarative kind of specifications makes it very useful to even put those different kind of applications. Even serverless, you can have Knative, you can have OpenFaaS, you can even have serverless inside on top of your Kubernetes as well. So I don't think there is any limitation, but the more stateful application is, it's generally more difficult, not only Kubernetes, like everywhere. So take that in mind. That's more my perspective.
I can add to it, but I don't need to. I think this was perfectly described.
Yeah, that's a tough one to answer in a short time. But
it was mute. Sorry. How to identify the perfect moment when to move from self-hosted database to the cloud in startup context?
Yeah, I think like it's hard to keep that one short, but let's try for the sake. So I think the first question is always, you probably have like your or your self-hosted implementation because of cost reasons, right? That's how startups start, right? You have your DigitalOcean instance, whatever, for a couple of dollars a month. Then that needs to be scaled out. And I think first you have to hit a problem, right? You just don't do it for fun the moment you do the migration, but like, do you hit a performance problem? Has the person responsible for the database left the company? Like there needs to be an event triggering change. I think that's a first and foremost important thing. And like the moment you run into scalability issues, it probably means that even on the cloud providers, you will run into this, or you have to buy a really beefy instance. So like do the math first, like how expensive this is, and also incur personnel costs, right? It's expensive to pay people for maintaining a database and wake up at 3 a.m. in the morning. They're going to be mad the next morning and for sure not work. So the whole part of incidents is something you have to take into account. And from my perspective, like if I was to start up a new company, I would probably run a platform as a service, like, I don't know, like the successful successors from Heroku, like Fly.io, whatever, put the service anywhere and stay away from that, right? Your business is not your app, but like what you produce, what you write code. And like databases, like the business of the database companies, but not yours. It's just a data store. So I don't really want to deal with any of that if possible, even if that's more expensive. As long as I'm small, you need to focus on what makes the company strong and try to get rid of everything with a reasonable price. So that's what I would always strive for.
Okay. I really like to hear more about Web3 for products other than in the DeFi domain.
There is a follow-up, yeah. I have always had it explained from democratization of data perspective and can understand that from the DeFi perspective, but struggle to find analogous use cases in other domains. And that's a very valid question because DeFi is very straightforward. We are moving away from traditional finance, and we are moving away to something that is completely transparent, auditable, and permissionless and accessible to anyone. What are the other places? So I've already mentioned Lens protocol, which is a social graph on top of a blockchain. I think that's very interesting because right now their promise is that right now, if you are on Twitter and you have your followers, then if you decide to move to a different platform, TikTok, Facebook, whatever, then you have to build a new audience there. You can't take your followers with you. The idea of open blockchain-based social graph is that if the application that you are currently on doesn't suit you, so maybe their algorithm for sorting new posts or their way of monetizing things is weird or you don't like it, then you can just go anywhere else, but your social graph goes with you. And as long as other people know that you have moved the platform, they can just jump on and they will automatically follow you and all the other people. So that's one idea. Second idea is all these something to earn projects like Move to Earn and stuff like that. Move to Earn is kind of stupid. You walk and then there is a Ponzi scheme that gives you some rewards, right? Fine. But potentially in the future, there are this Web3 idea of like building something, building some profile, building some reputation that is always there and is unique and things like that, and you own it, can lead to something like a work marketplace where you actually can have provable history of you doing something. So we are thinking of something like resumes on blockchain, right? So you can provably show that you have worked on this project for this company for this time, and it's not like you put something on LinkedIn. I've seen many fake profiles there, and those people are like, oh yeah, look, I worked on all these things, and then you look at their GitHub and they have some forked repos where they didn't do any changes or they changed README and said I developed this thing, and it's complete nonsense. So that's another one. And then everything around NFTs, I can talk hours about that, but like tickets, memberships, subscriptions, all these things make a lot of sense when you plug in the NFTs. And I don't mean I don't mean the pictures, I don't mean the music NFTs and these things, but just that object in the database, because it's unique, provable, owned by someone, can be traded, can be moved around, and that's where it makes a lot of sense, because then you don't have to care whether your ticket with the QR code was sold 3 times by the scammer, or whether the membership to some club is fake, that someone is like reselling to you behind the in the alley somewhere, right? It's all on chain, and it makes a lot of sense. One thing, sorry, Otavio, last comment. One thing I would like to see is a car ownership database on blockchain, where you have your car on blockchain and you see, when I'm buying a car, I see the mileage, the repairs, everything that happened to the car recorded somewhere publicly, so that I don't have to really like fish for potential. Was it in a crash? Is it stolen? And all these things. Like, why can't we have it on some immutable database, right? So those are the things that I think we are heading to with blockchain and Web3.
Any hints how to convince the management to work on metrics and optimizations? If you are in a startup where you should be very careful with the results, resource, feature-based optimizations.
Yeah. So, well, to convince like somebody to kind of like invest more into some metrics and kind of some observability solution, this is kind of easy, because like you cannot do any decision around optimization without that data, without like some kind of like, at least monitoring. Even more, you cannot even have a service that you want to be reliable without any metrics. So this is like must have, and which is super nice that I can kind of like, I suggest that you kind of reuse your monitoring platform for even optimization kind of numbers, because, or like your performance efficiency numbers. So you don't need to have any extra kind of product. You can start just from that. So gather metrics about your resource consumptions, about latencies, which are very important for SLOs and reliability, so service level objectives. But it also helps with optimization. So that's kind of first step that ideally you have, not only for optimizations but for reliability, right? And from there you can measure your efficiency and see if there is anything that you'd like to improve, and start small. Start maybe have some 1 week sprint for like just changes of generally optimizing maybe the virtual machine sizes you have or anything really, and see that latency dropped, or maybe resource kind of consumption dropped on your metrics. And by those small dopamine hits, we're like, oh, I actually saved $1,000 per month or year. You kind of convince slowly that maybe we should invest in this space. So small step and have observability would be my first bets.
What is the best strategy to implement an interface to analyze the data?
Yeah, I think I have to invest some imagination into what the data is in this context. So I think the assumption probably here is that the data is more about figuring out when to switch, or when to switch to a cloud store, or is the data more about what the usability of this data is? It's a tricky question. So I'm not 100% sure. I think like implementing an interface here is usually like how to talk to a data store. And there's usually two approaches here. One is kind of hiding the data store implementation to have a generic interface to access the data. And the other strategy usually is make use of a data store and also its specialties and its like core functions that probably allow for different kind of speed or whatnot. And that's a very good question from a development perspective. And I would say you have to decide if you have more than one data store, or if you do a switch, you usually go with a generic implementation. If you have this one data store that you use for all of your data, make sure you adapt your application to all the strengths and weaknesses of that, be it that you need to implement some sort of connection pooling on top of that, or have certain queries that you can only do without a generic interface on top of that.
The final questions and then the final thoughts, of course, is the question around software development at Red Hat. Each one follows. So it's a waterfall, cascade, or other concept instead of what memory arrangement is the best to support software development, like brief, first, or others.
Okay, it sounds like there are two questions in it. So first of all, in Red Hat, we have freedom. Every kind of, almost every team has a freedom to choose software development kind of process. I personally use, or like my team use Kanban, and another part of my team is using Scrum with 3-week sprints. So anyway, but you can choose, and that's kind of like this, ownership of this process to the team. I think this really makes sense. In terms of memorization kind of patterns, it really depends on your algorithm. Like the best way, what you could do is to find your access patterns, like check, what feels best, and then try to figure out and play with different algorithms. If you really don't have a clue from like theoretical perspective, try to implement both algorithms and really compare with the benchmark. That's the best way to kind of like tell the difference, right? So there's nothing like the best scenario. You really have to adjust for your specific requirements. That's why, one more thing, that's why very often, if you use like a standard library, even in Golang or any kind of like library, any kind of language, usually the library is like very generic. It means that most likely to be slower for your needs if you would, versus implementing from scratch, which is sometimes worth. So you have to kind of, and this is because when you do things generic for everybody, it is hard to make it like perfect for like specialize your use case. So generally my optimizations, last time I did them, like last month or something, was about like recreating like the standard library. So perhaps, those algorithms that are generally better for everyone, for most of the people, that might be not the case for you. Again, comparing and doing benchmarks and data, assessments based on your metrics and tooling is the best way to learn.
Oh, it's awesome. Thank you, everybody. It was an amazing Q&A. Hopefully see you around and see you as soon as possible in any conference physically. But before I finish, any final thoughts before we go?
Stay curious and always learn new technologies, whether that's around blockchain or storage or hyperscaling stuff. Doesn't really matter. As long as you keep learning, then you can do what Otavio was talking about and scale your career, right?
Yeah, thank you for organizing as well. And yeah, I'll be watching the space for sure to learning from other people. Thanks a lot.
Yeah, I think it's all been said. Like, I like the idea here of gathering people and make sure it's not super technology focused. It's really about like concepts and if you have the idea of concepts, you will have a good career in IT, right? Like the implementation details are just details, but go with the concepts and you will always be able to learn any technology.
And that's all for today. Thank you. Bye. And oops, we're gonna have a break of 5 minutes. Stay tuned. And see you in 10 minutes, I guess, with more presentations.
All right. I hope everyone is enjoying the conference and everyone's having a good time. And we wanted to say thank you once again to CodeSync for joining us as partners and sponsors, and also for sending amazing speakers. Thank you, Emil. Thank you, Adam, for joining us, and thank you for the presentations. And if you want to actually move towards the more healthy code base, definitely check out CodeSync Software Engineering Intelligence tool, and it will actually help you and will guide you towards a healthier code base where you can spend more time innovating and basically working on the ideas in the project, and meanwhile reducing the stress and the business risks in the dev process. Right now, they are running a free trial. You can check out their tool via the link in the chat, register for it, and also you will need it to attend the workshop. So basically, give it a try, set it up, and we will see you on the 17th of November for the workshop. And I nearly forgot about the iPhone giveaway. To partake in this raffle, you simply need to fill in the form that you will see right now in the chat. So just type in your email, and we will have a giveaway at the end of the third block today. The form is in the chat. Good luck.
I'm Adam Thornhill, a software architect with degrees in engineering and psychology, and I'd like to welcome you to an exclusive workshop on November 17. In this workshop, I'm going to show you how you can pick up a codebase of any size and scale, and within minutes, identify all the technical depth in that codebase. As if that wasn't enough, I'm also going to show you how you can prioritize that technical depth in a way that makes sense to both the business and the engineering side. And of course, we're going to look into opportunities to visualize code bases too. Too good to be true? On November 17, we make it a reality. Hope to see you there.
Hey there, I'm Melinda, connecting from Vienna, Austria. I work as a consultant at Oracle. And today I have the pleasure to moderate this next block of speakers with topics including refactoring, Kubernetes, event streaming, and application resilience. And as a first speaker, we have Emil Aasa.
Hello.
Welcome. I'm already a huge fan of Adam Thornhill's, who's giving this free workshop this Thursday. So I'm looking forward to hear from you more about technical depth and tackling it, right?
Yes, that's right.
Okay. You're all set? Stage
all right. Thank you. So I'm Emil, and I work as a software engineer at CodeScene. And judging by the amount of commercials that I just saw when I was waiting in the speaker lobby, I think you might have an idea of what we're doing. But CodeScene is a software engineering intelligence tool that tries to sort of figure out a lot of interesting things about your software and your software development. And it uses a sort of a behavioral-centric tool. So what I'm going to talk about today, or my talk, is focused on, first of all, the sort of domain of refactoring, which is the context. And then I also want to walk you through the workflow that we used to develop one of our first proper machine learning models that is a sort of standalone, fully controlled and managed machine learning service. And my hope is that from this talk, you'll take away a sense of that it's not that hard to do, actually. It sounds a lot worse than it is. And there's a lot of people selling tools around machine learning now that I don't think it really captures what machine learning is in essence. And I think it's easy to undervalue your software engineering skills when it comes to machine learning. So we're going to walk through this pretty simplified workflow of creating machine learning models. Start with discussing the problem statement, and here I'll talk about how we at CodeScene figured out that this was something we thought would be a good fit for machine learning. And then we'll talk about gathering some data, the actual modeling a little bit, and then deployment and afterwards. So that's sort of the story arc. It's going to be half after action, build report, and half a sort of presentation of refactoring as a concept. All right, so refactoring as an idea is, I think the textbook definition is something along the way, something like restructuring software without restructuring source code without changing its behavior. So it's a way to reduce complexity in our heads. And some people talk about refactoring as a compression activity. So it's you do the same thing, but it takes up less space in your head. And it's one of the only ways that we have of managing existing technical complexity in a software project. Pretty much all the things that you can do to still have the software, keep the software, but make it simpler, could be construed as refactoring. So, so it is an interesting area, an interesting subject. It's a pretty hard, I think. So what makes refactoring hard is there's a lot of context around refactoring. So for example, if we're just comparing one piece of code to another piece of code, we can say that the one on the left is simpler than the one on the right, but it's lacking a lot of context. So we don't know the business constraints. We don't know the team dynamics. So let's say you have someone that really, they really like this new language feature, and the other guy in the team, he really dislikes it. That social context is not captured when we're just sort of trying to objectively compare stuff. There is a few ways that people have tried to break this down and help with it. So there's books written about refactoring, and Martin Fowler has this well-known refactoring book. He talks a little bit about sort of identifying the issues, which is you can talk about code smells or code health issues, and then about the refactorings that are the sort of recipes to fix it. And here I picked an example of what a refactoring could look like. So to the left, we have this for loop with a bunch of if statements inside of it, this is Java code. And on the right, we have the same functionality expressed in a streams API, also Java. So here you could say that, well, some people think the code on the right looks better. It's more like a declarative pipeline, sort of a chain of filters, and you can almost read it like, I want to get the people that are over 18 but under 65, and they need to have a name that starts with B. All right, so that can be pretty good. Other people prefer actually the for loops, maybe not this extreme, but they think, that it's a little bit better to have it explicit. And this is a part of the social context of refactoring that can be a little bit hard to capture in standard tools. And another thing is the business context, of course. So you could go ahead and convert all these for loops into streams calls, but would that actually make a difference as an activity to spend a couple of days doing in your code base? But maybe not. So it's a tricky proposition. So when we were thinking about this problem and how we could help, we realized that we have a part of CodeSyn is that it goes through all your sort of source files and tries to score them and give them a code health score. So you start with a bunch of diffs, a bunch of changes to the source code, and CodeSyn rates them and spits out a score. So we had this initial idea that maybe we could flip this algorithm the other way. So we start with the scores, and then we flip out, we spit out all the solutions instead and present them as diffs. So this is an example of what CodeScene doesn't like. So if you have this sort of nested if statements here, and you have this visual bump in the source code, this is something that makes it trickier to understand and read the code. And this is just mentioning that we have the social context, so we know which team is responsible for which part of the code, which files, and stuff like that. So we thought that, okay, maybe this is a clue. We also do this change frequency filtering, which makes sure that it's only the most relevant files that sort of get recommended for changes. So here's a way to express one of these refactorings. And if you look there on the left side, it's basically the information you get from git diff on a file. Here we have the commit message, and then we have the red parts is the stuff that was removed, and the green parts is the stuff that was added in this git diff. So this is one way to express what a refactoring is and what this sort of semantic compression would mean. So you remove this if statement and you replace it with this try macro instead. So you don't have to return the e-fault every time. So our thought was, yeah, maybe we could produce a ton of these because we have access to sort of unlimited data, and we have control that is in open source software projects, and we have control over the program that actually creates the data. And here's a slide that shows the sort of where CodeScene would show up in your normal workflow as a quality gate that says, yeah, you have to improve this thing, but how should you improve it? So this is where our first idea was, this is where we will present the refactoring recommendations. So I think this is a good problem because a couple of reasons, and this is sort of a takeaway slide for your problem. When you're trying to make a problem statement that you can evaluate and see if it's a good fit for machine learning. So it needs to be hard enough that it's not trivial to solve by just writing a function in your preferred language. That's the first criteria, I think, because then you should do that instead and profit immediately, skip the steps. And we have access to good data. So there's a path that is navigable to having a lot of good data. And good in this case is, for me, what makes this data set good is that it's real world data. It's not synthetic. It's not measured in some weird way and found in all the data set. So we have control over the measurement, and we have control over the origin. And we have access to a lot of it, which is a prerequisite. So the first sort of a box here is a check. I write it down here, but I'll get into that later. And the most important thing I think here is if it's solvable with simpler means, then just do that instead. There's nothing magical with these functions. They're just difficult. All right, so now I'm sitting here with a decent problem statement. I think we have a good idea for what we can do to create something. And the next step is the data gathering. And here it's a little bit tricky depending on your problem. So in our case, we didn't really need any more data than a bunch of Git repositories with decent histories that we felt were representative. So for us, it's a pretty simple proposition, but this can be hard if you need to actually get data from the real world by measuring stuff like that. There's this word that's thrown around, or concept, which is called data provenance. A data provenance is just a fancier name for write down something about where your data came from and how it was created. And this can be really important down the line when you need to retrain the model, or you're finding something that doesn't really work as you expected. You want to be able to sort of figure out why. And I put here in the bullet points a couple of the columns that you could put in your database that tracks training data. This is basically, just a heads up that add some metadata early, even if you think you might not need it. It's going to be a good thing to have down the line if everything goes to plan and you get this successful project. Here is a quote from Adam Savage that I really like. And I think this is pretty key when you're doing this sort of data-driven experimentation, is just write everything down somehow. And there is a really good facilities now for writing stuff down in computational notebooks. So I would recommend some variant of that. And writing it down also means saving stuff in databases, saving stuff in even like CSV files is better than nothing. But yeah, this is key, because you're going to end up in a situation where if you're a confident software engineer, you're going to feel less confident with the data science side or the ML specific side. And then it's really good to have everything written down. And the reverse is also true. If you're a great data scientist, then these like stuff that is around operation or testing or deployment or how much load the service will take, everything like that, it's better to have a written paper trail somehow. And I think a computational notebook is a really good idea. The first major issue that I ran into when I was creating this awesome data set is, all right, I got this data and it looks pretty good, and I can personally label a couple of hundred of these examples, which are these Git diffs. But when I want to scale this a little bit and have a little bit more data, then people are not too keen to do this, because this is the dark side of supervised machine learning, is that labeling is really, really boring. So fortunately, we had an experienced person with labeling data, our data scientist Enis, who we hired on, who created this wonderful tool with keyboard shortcuts and everything, which sped up the process.
I'm afraid we lost our speaker. Okay, there you are. All good. Back to you.
Thanks. So apparently, if you right click and click on the back button, then it doesn't really help the presentation. All right, so labeling sucks, but we got this really good tool from one of my colleagues. And I think this is a good idea overall. Find out those parts of the machine learning workflow that really isn't fun, and tried to build some tools around them. This was a great addition to our labeling process. So yeah, write it down, computational notebook, record the provenance somehow, and make it really easy to label. And recording the provenance can be as simple as adding that to your SQL schema. And I think you should keep it as simple as possible. All right, so let's push into modeling. So this is the area where I was the least confident myself. So I consider myself a decent developer and not a good data scientist or mathematician. But I had some statistics background, and that's good. And here, Adam Savage again. So a couple of things that I want to point out is that there are really good tools. So when you're starting out with modeling, right now we're looking at an exploratory data analysis tool, which is called SweetVis. And this is a pretty simple tool to use, actually. If you know a little bit of statistics or you don't mind reading it a bit, you could get a decent idea about the signal in your data. So even if you're not a super advanced data scientist, these libraries exist now that are very good at finding correlations and stuff like that in data. So I recommend like Googling the exploratory data analysis space if you're in this situation, and just keep writing stuff down. So this is ideal for having in a computational notebook, and then you can have your freshly hired data scientist come and look at your work and maybe do it better than you could. Another thing here that we're looking at is a programmatic expression of testing different models. So what I wanted to sort of illustrate with this slide is that don't underestimate your programming skills and how useful they can be. So this little code snippet pretty much tests these regression and classifier models in the top in a programmatic way, and you get these results out. And this is something that you can do. You can create these benchmarks, and you can use them in the whole life cycle of the project. So when you're iterating on something, you're trying different models, or when you hire a data scientist team to your company, they can jump in and start using this right away. So leave some programming artifacts behind, and I think your software engineering skills are more valuable than you might think in the ML space. Here's a unit test that uses these statistical expression here, which is an area under curve score. And this is just an example that you can express these sort of more complicated mathematical things, even in simple, straightforward programming ways. So this is a unit test for controlling the accuracy of your model. So this, you could run this between generations of different models, for example, to make sure that you're not getting worse in the accuracy department. And also another point is it's okay to help your model. You don't have to do everything in machine learning just because it's cool. You can do a lot of things in the pre-processing if you have access to the system that creates the data, as in my case. Then we can do these simple things to make sure that we're keeping sane. We're not going crazy. So one of the things that I did early was I made sure that all my commits had an improvement according to CodeScene. I made sure that all the diffs had additions, which was CodeScene really liked it when you just deleted everything. But that maybe isn't as helpful as a teaching tool, and so on. So model check. you don't have to make the perfect model. You can just make a decent model. And these EDA tools are great. And I will answer all the questions in the end of the presentation, so I can keep my time here. Yeah, use your programming skills, for God's sake, because you're probably great at that. And then we come to deployment. So here it's also a sense of when you start reading about stuff, like this might actually answer that question. This is the feature snapshot of AWS SageMaker. And it has so many functions and features that I don't really understand, even as someone who ostensibly has works on a product that does machine learning. I don't get this basically at all. Maybe it's good if you have a really huge product, but it can be easy to just have a lot of waste, because a machine learning model doesn't have to be that much harder than just a regular function. So this is another way to run a machine learning model. If you didn't like the SageMaker version, you could also run it as a Python script and take standard in as the info, and then you have a prediction function. Then you return your results. So yeah, the simple tools, they actually work, and they can make it easier to make progress in the beginning. So staying away from the huge cloud offerings can make it easier, depending on your skill set and what you're comfortable with. And for operations, I actually think that heuristic functions, like normal programming language functions, aren't that easy to operate either. You still need a lot of stuff like looking at response time and having good observability. And this is exactly the same thing for machine learning functions. So you don't know what the input is going to be in your normal functions either. So keep track of that. One special mention is sort of this out of bounds values, which you get in ML models. So make sure you track them as well, because you get values that are outside the training data, and then you get crazy results sometimes. So that is almost the only thing that has hurt me so far. Yeah, and then to wrap this up, how do you profit from the machine learning? Well, I think gathering feedback from the users somehow. This is really nice if you can do it in an implicit way. So you just pick up their actions in the UI or something and see if they get help. Or explicit also works, can be a bit hard. Try to think about the next data set. So if you can tweak something in your program to make it easier to get the next fully labeled great data set, that's a really good move, if that's possible. And eventually, if you've done that a few times, you might end up with something that is something like a data engine, which is pretty much where you aggressively try to find these valuable data sets in your system and try to make more models out of them. And that will make you like an appropriately sized framework for your team and your organization. Yeah, that's it.
Thank you so much, Emil. I'm not sure if this question was answered by you now, because I understand you don't have time for the Q&A session, right?
Oh, yeah.
Comment.
Yeah, right. So the question was, using a cloud-based labeling tool was not an option. For us, we thought that the labeling that we needed to do was to determine if this was a useful or helpful way to describe a refactoring. And for that, we wanted experienced software developers answering that question. And the closest ones that I had available were my teammates. So unfortunately, they had to do a lot of labeling. But yeah, that will vary dramatically depending on what if you're finding traffic lights or doing something else, then it's fine.
Okay. So thank you again for your time. We already have the next speaker waiting. Let me add him.
Oh, that's me.
Hello, Viktor. You're actually a rock star, aren't you? I mean, you are hosting channels and you're having your blogs. You're published author, of course, on DevOps and Kubernetes, all specialized. And you're going to tell us today what we don't know about Kubernetes, is it?
Yeah, I mean, depends. Maybe you do, maybe you don't. I think you don't, but let's see.
Do you have your presentation ready?
Yeah, I already shared my screen, so just there we go. Here's my presentation. Let me put this away. Here, there we go. Right. So let's talk about what is Kubernetes. Now, it might sound like a silly thing, but I promise you that it's not really, because there's a lot of misunderstanding or only partial understanding of what Kubernetes is, and understanding what it truly is or where it's going will most likely help you make decisions of the future direction where you're going. So, without further ado, actually, this is me. My name is Viktor. Quick introduction. I work for Upbound, with a company behind Crossplane. You will see Crossplane among other things later. What else? Yes, I have a Twitter account. I'm not sure whether by the end of this session Twitter will still exist. You never know how it goes these days. I belong to a couple of groups, doesn't matter. I have some books. I have a podcast, which you should listen to, and YouTube channel. Go and do something, subscribe. Whatever people do on YouTube, do it there. Anyways, let's talk about Kubernetes. That was enough of an introduction, right? Now, if I go to the official documentation or people's blogs, or I ask, this is kind of, especially if I ask people, what is Kubernetes? I typically get a couple of variations of more or less the same answer. Very often people tell me, hey, that Kubernetes is a container orchestrator. Or if you want to use more layman terms, Kubernetes is a thingy that runs my containers across multiple servers, right? It manages my containers. My applications are packaged as container images, and then I give those images to Kubernetes and a few other pieces of information. It runs them, and that's absolutely brilliant because we all love containers and all that stuff, right? Another commonly used explanation is that Kubernetes is a cluster operating system, meaning that it's a operating system that manages a fleet of servers, or what we call a cluster instead of individual servers. And just as the previous description, this one is in a way correct. All those that I'm mentioning here are correct, but yet they do not really describe Kubernetes well enough. Some people will say that it's a control plane. I believe that's closer to the right description. We'll get there later. And I will claim today that Kubernetes is something else. It's not only about containers. It's not only a control plane. It is not only a way to run containers, and it's not only a cluster operating system. So before I explain what I believe, actually not explain, I will show you different examples of Kubernetes usage. And through those examples, I will try to explain what it is. But let me just briefly go through architecture. I will actually go through this very, very fast because I want to focus on other stuff. But very briefly, Kubernetes consists of two parts: control plane, worker node. Think of control plane as the brain that decides what should be happening on worker nodes. Even though that's not necessarily correct, I've seen Kubernetes clusters without worker nodes, without running containers, without running anything in a cluster. So it could be only control plane. We have some, but in typical setting, in the most common setting, it does. We have some external resources. There are multiple control planes to make them fault tolerant, to prevent split brain problems, and so on and so forth. some worker nodes, and external resources. There can be many. There almost always are many, and that can be storage. It could be external load balancer, and so on and so forth. Now, when we talk with Kubernetes, when we communicate with Kubernetes, we always talk to the API. And through that API, most of the time, we don't tell Kubernetes what to do. We tell it what is the state of something that we want to have, which might not seem like a huge difference, but it is a massive difference, right? So we declare the desired state of something, and then let control plane Kubernetes figure out how to accomplish the desired state. We have a scheduler that is scheduling stuff, figuring out where something should be running and when it should be running, and so on and so forth. Controller manager, which is extremely important, probably the most important beyond the API thing in Kubernetes. And that manages controllers. Now that sounds silly. I will get to controllers later. We have a key value store, typically etcd. It could be others. That's the database that keeps the state of the cluster. And on worker nodes, that's where our containers are running. We have kubelet. Kubelet manages containers, really. kubeproxy, that is managing communication between those containers. Container runtime, which in the past was Docker. Now it could be Containerd or many other solutions. We have containers. Everybody knows that. Containers are packaged in pods, meaning that you cannot run container directly in Kubernetes. You need to run it as a pod. And pod is a collection of one or more containers and a few other things. And we have controllers. Now this part, let me highlight this. Here we go. This part is actually potentially the most important thing, right? Controllers are managing some type of resources, right? And by default, when you just have vanilla Kubernetes, there is a number of baked-in controllers like, hey, I'm managing pods. I'm managing deployments. I'm managing replica sets. But you will see later, actually, controllers are much, much more than that. They're probably the most important thing in Kubernetes today. And we have resources. That's how we define the state. When we communicate to API, we define, I want to have this, whatever that is. And then controllers are subscribed to the API. They listen for changes in the state of those resources. And if the state is the type of the resource is the type of the resource that the controller should manage, controller does something with it, or it does nothing, right? So we have different types of resources and controllers managing those resources. Sometimes controllers in charge of one resource type, sometimes of many. Now, all that is kind of pretty boring. So let me jump straight into a practical part of this something, because I want to demonstrate what Kubernetes is by showing you things, not slides. Slides are boring, right? So let me put this away. Let me show you my terminal. No pretty colors today. I will do everything from terminal. If you like web UI, stuff like that, you can do the same thing. So let's start with the most basic example, right? People say Kubernetes is about managing applications packaged in containers. Let's see one example of something like that. I'm going to say, hey, there is a namespace production. Kubernetes is split into different namespaces. That's how we divide stuff. And I'm going to apply something defined in this directory. And I created deployment and a service. I did not really tell Kubernetes to create it. Kubernetes figured out that those two things do not exist, and it created them. And if I say kubectl namespace production get all, you can see that here is the service that was created. Here is a deployment. Now, behind the scenes, the purpose, the reason for existence of deployment is to create a replica set, and replica set creates pods. Deployment is how we define something, an application. That's a higher level definition. Replica set, for each version of the deployment, there is a separate replica set whose job is to scale our applications horizontally. And replica set created, since I said that I want 3 replicas, created 3 pods with 1 container in each of those. Now, this is basic. Everybody, whoever touched Kubernetes, did create those two types of resources. Most of the people know what it is. And if I would draw it in a diagram, it would look like this. I told Kubernetes through the API I want a deployment, and then the controller in charge of the deployment said, oh, okay, so you want to define this and that. I should create a replica set that will scale your application to 3 pods, and applications are containers in those pods. So far so good. Now, if I want to upgrade my application, I could do something like this, silly demo deployment, and say, hey, how about I change the tag of the image from 105 to, let's say, 107, right? I'm changing the desired state by saying I want a different image, which contains different release of my application. I save this. I apply it again. Kubernetes figured out that there is no change to the service, but there is change to the deployment. And if I list the resources just as before, let's do watch just in case. Watch, there we go. You can see that the old release that was scaled through this replica set now is scaled to 0, right? And the new release was created as a new replica set. It has 3 pods, and there are 3 pods of my application. You can see by the age that this is a new release. This is running for less than a minute now. Now, this is still very basic. Everybody knows that. What they essentially did was tell Kubernetes that I want to change the deployment. It created a new replica set, and then it started doing the dance and saying, hey, I'm not going to replace your application all of a sudden because that would result in a downtime. I'm going to create one replica of the new release. I'm going to shut down one of the replicas of the old release. I'm going to continue increasing the new release, decreasing the old, doing what we call rolling updates, until eventually all the replicas of your application running that new release, and there was no downtime, and we can live all happily ever after. Now, if you look at what I did so far, then my first definition that's saying that Kubernetes is designed or meant to run containers on a group of servers is absolutely true. We have those constructs, but the ultimate goal was to manage applications packaged as container images and running as containers. So far, the definition from the very beginning is absolutely true. But let's spice it up a bit. Let's see what will happen if I deploy a second application. kubectl namespace space production. I want to apply whatever is defined in a different directory, DOT. Now, this time I have few additional things defined. I have deployment just as before. I have service, but I also have something called ingress. I have persistent volume claim. So what happened is that, actually, let me list the things. Let me show you something. kubectl / namespace production get ingresses. And you can see here that I got ingress. Now, if you're not familiar with ingress, what ingress does is it enables incoming traffic entering the cluster to be forwarded to appropriate application, right? It enables external access to our applications. Now, the curious thing about ingress is that it also creates an external load balancer, right? So if I now have the second application, this is application B, they're talking to each other through services, that's cool, but I created something called ingress. Now, ingress, where is it? Ingress, when it was created, Kubernetes said, okay, so if you want to enable external communication to your application, I should create an external load balancer, right? And that external load balancer could be, if you're running in AWS, ELB, or equivalent in Google Cloud and Azure, it is creating a piece of infrastructure or a service. Now, the curious thing about that, actually, before I say about curious thing, if I here list persistent volumes, you can see that I got a persistent volume, which means that not only that my Kubernetes cluster created something outside of the cluster itself, which is external load balancer, but also I requested a persistent volume, meaning that Kubernetes went to the API of my provider, requested external drives, right, storage, and attached it to my pods. And through those two examples, which are the simplest possible, you can see that Kubernetes is not doing only stuff within itself, within the cluster that it is managing, but it is communicating with APIs of some providers and managing, in this case, infrastructure or services that are completely outside of the cluster itself, right? So it is almost certainly not only about containers, because in this simplest possible example, my Kubernetes cluster is managing both external services and infrastructure, as well as containers running inside of that cluster itself. So the concept what Kubernetes does, even in this simplest example, already breaks, because it is managing stuff inside and outside the cluster itself, and not only containers. Now you might say, hey, yes, but it's still all about containers somehow, because that external load balancer was created for the purpose of redirecting traffic to my application running as a container. And that external drive is attached to containers of my application. So it's maybe not exclusively about running applications as a containers, but all that external infrastructure and services are still somehow directly related with those containers. If that's what you would say, I would say fair enough. But how about this? How about, I don't have a demo apart from this, but how about if I go and say, hey, Kubernetes, I want not a container, not some resource that will create a container. I want a virtual machine. And then Kubernetes cluster will take that input, take that desired state, and create virtual machines on top of the servers that constitute my cluster, right? And we can do that with quite a few tools. The commonly used one would be KubeVirt, that extends Kubernetes API to enable us management of virtual machines. Nothing to do with containers, right? So if I can use Kubernetes, and I do, to manage external infrastructure and containers and virtual machines, it's definitely not only about containers. All of a sudden, my Kubernetes cluster is in charge of managing quite a few other things. But it's still somehow about things happening inside my cluster or external services and infrastructure directly related with the resources in my cluster. But we can go further, right? And we do. We can do something like this. Let me just, let's say that I go back to the Kubernetes API and say, hey, I want a virtual machine, but you know what? I do not want a virtual machine running in the cluster, Kubernetes cluster itself. I want a virtual machine of my provider. It could be EC2 instance, for example, or DigitalOcean or something else. But I want you to manage those things, because Kubernetes is exceptionally good at managing resources. That's why we call it very often a control plane. So I can go to my cluster and say, give me a virtual machine. And today I will use Crossplane for that, just as I would have used KubeVirt for virtual machines inside of the cluster. And I can do something like this. I can say, hey, how about if you apply this? Now you might be asking, what is this? I will explain. I'm going to say, hey, I extended Kubernetes API, and I extended it by installing Crossplane, by installing some providers, and now I would like to have something called instance. And API of that resource is EC2 AWS, so I obviously want EC2 instance in AWS. Here are some parameters, some arguments I want to provide, like this is the image of the VM, this is the region, and so on and so forth. Now, since this is AWS, I need virtual VPC as well, and I need subnet, right? All those things are resources in AWS, nothing to do with my cluster. But I will take, instead of me doing it from one way or another, I want to leverage the opportunity to communicate with Kubernetes API, request the desired state, and let it handle the stuff instead of me doing it. So I can say, hey, I want to apply that YAML, the one that I just showed, and there we go, right? Now, what happened is that I went to the cluster, I said, I want a VM, just as before, but this time, not a VM inside of the cluster, I want a VM somewhere else, in AWS. And the result is, let me show you the result. And this is one of the nice things about having an API. I can query anything. I can say, hey, give me all the VPCs and instances and subnets that you're managing for me right now. And you can see that they're there, right? The subnet was created in AWS, VPC was created, and those two are requirements for me to run a VM, EC2 VM in AWS or anywhere else, right? You can see that it is not yet ready. It takes a couple of minutes to create a virtual machine in AWS. It will be done soon. But what essentially happened is that when I requested from a cluster that I want to have virtual machines somewhere else in AWS, Kubernetes itself did all the operations, the heavy lifting. It went to the API of that provider, in this case AWS, and said, hey, let me see, what do you have right now? Do you have a virtual machine with those parameters, with that name? No. How about you create that virtual machine and then tell me the status, and then I'm going to monitor the status, maybe upgrade, orchestrate, do all the things that need to be done, right? And the result is that I will have soon a virtual machine in AWS. Nothing to do with containers, nothing to do with anything running inside my cluster. I'm now switching to using Kubernetes as a control plane, as something that helps me manage my resources, no matter whether they're running inside the same cluster or somewhere else. Now you might say, hey, that's a very simple example, and I would say to that, yes, that's a very simple example. Let me show you a better one. Where are we? Here. Let's say that I want a database, right? Now I could have requested a database running inside of that cluster. I can do that easily. I could use MongoDB operator or Postgres operator, or I can do something like this. No, that's the wrong command. Crossplane examples Postgres. I can say, hey, I want to create something called SQL claim. Now, this is very different from before, because before I was interacting directly with some AWS resources. I need VPC, I need subnet, I need an instance, EC2 instance. But in this case, I'm using something called SQL claim. Now, what is important about this resource is that this is not part of Crossplane. This is not part of any other tool. This is something I created. And I created it by extending Kubernetes. We use something called compositions. But essentially, I extended Kubernetes using Crossplane to say, hey, it's too complicated to create a database by yourself because you need to do a bunch of things. You need a lot of things to manage databases, especially in AWS. I'm going to create a new resource type, new resource definition. I'm going to create an operator. And whenever somebody says, I want SQL claim, a developer in my company, and tells me what type of SQL database he wants, like in this case, AWS and Postgres, and give me a couple of parameters, whatever we agreed that other people in my company would be comfortable with. And finally, I'm saying, when you do create a database, you should continue managing that database. You should do all the good things you need to do. And I need to be able to use the database. So please, 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 create a Kubernetes secret with authentication to that database. So the logic is still the same, right? kubectl, namespace, let's say production. I want to apply whatever is defined in cross-plane examples, PostgreSQL, right? And if I say kubectl, namespace, production, get me the status of what you just created, those things that are completely custom, extended by me, ops, SRE, whatever I am. And I can say, show me what's going on. And you can see that we have completely custom-made resource extension. And I can see the status. It is not yet ready because it takes like 5 minutes, give or take, to create all the resources in AWS for database. So what happened is that I said, I want a database, but I'm not going to tell you all the details about the database because Viktor created extended Kubernetes with new resource definition called the SQL claim. Behind the scenes, things will happen. I will show you what will happen. But what matters is that cluster went to yet another API, still AWS, but it could be Azure, it could be anything else, and requested creation and management of all the resources related with that database. Now, how about I make it even more complicated and say, hey, I would like a fully operational, production-ready Kubernetes cluster outside of the cluster that I'm using to manage my resources. I want a new Kubernetes cluster, right? I can use Kubernetes for that as well. I can use Kubernetes to create Kubernetes. And I can do that. Let's say that if I stick now with AWS, I can show yet another example. AWS CKS, there we go, right? Again, ops in my company created extended Kubernetes with something called SQL claim. I provide a couple of labels to say where do I want that cluster. I created a couple of parameters. I want to have secret with authentication to that cluster so that I can connect to it, and that's about it. And if I do kubectl namespace production, I want to apply whatever is defined in cross-plane examples, AWS CKS, there we go, it's created. And we can see the status of that cluster as well. It is not yet, nothing is happening. Soon it will start creating all the resources. Now, so what I said is, hey, I want a cluster. Kubernetes itself went to the API of my provider, in this case AWS, but it could be anything else, and started creating all the pieces, all the building blocks required to create a cluster. And trust me, there are many. I need to run an EKS cluster, I need EKS and node group, subnets, VPCs, internet gateway, and so on and so forth. Now, behind the scenes, what happened is that there are certain hierarchy in Kubernetes that you create a resource. That resource might create sub-resources, children resources, and so on and so forth. And if I say, give me all the managed resources right now, you can see that even though I created a couple of things only, behind the scenes, this Kubernetes cluster created some security groups and subnets and VPCs and internet gateways and route tables and so on and so forth. Now, I'm not now going into depth what is how KubeVirt works, how Knative works, how Crossplane works, and so on and so forth. This is not a tutorial. Rather, it goes back to the initial question that I'm trying to answer. And that question was, what is Kubernetes? With everything I did so far, I created containers with my application. I created external resources like load balancer and this external disks, volumes. I created virtual machines in my cluster, not only containers, and I manage resources that have nothing to do with the cluster itself, like database, or virtual machine outside the servers of my cluster or even Kubernetes cluster itself. So it's definitely, certainly not only about containers. Now, so if I go back to the official definition, it says a container orchestrator in charge of operating a fleet of containerized applications. Absolutely not true. Actually, this is absolutely true, 100% true, but this is only a tiny fraction of what Kubernetes does. It's just one out of many, many, many implementations, or one out of many, many, many controllers that are managing resources in Kubernetes, containers themselves. So what really Kubernetes is, and I hate when anybody gives me this phrase, is it depends. What Kubernetes does depends on which controllers you have in your clusters. And those controllers can manage one type of resource or another type of resource. It can manage something inside that cluster, something outside. It can manage anything as long as you install it inside of your Kubernetes cluster. So Kubernetes itself might manage controller containers. Everybody knows that. It can manage containers and infrastructure. It can manage only infrastructure. It could be virtual machines, or it can be something completely different. I've seen an example, a silly example, where people created a controller that orders Domino pizzas, right? It all depends on controller. And think of controller as being codified version of a human operator that knows how to manage something, whatever that something is. So it is not only about containers, it is about controllers, it is about extensible API, and it is about the control loop, the ability of all those controllers to continuously monitor the state of some resource, wherever that resource is, whatever that resource is, and make sure that it is always in a specific state. So the closest, from those initial explanations I gave, the closest one that would explain Kubernetes would be that Kubernetes is a control plane for whichever resources we might need to manage. It's not only about containers. That's the end of my talk. I don't know whether I have questions now. This is company where I work about cross-plane open source projects, part of CNCF. I showed you a couple of other projects as well today. Check it out. Listen to the podcast. Watch my YouTube videos. And now I'm not sure what comes next. Do I have some time for questions, or that comes later?
I mean, Viktor, you're always welcome for the session later. So I don't see any current questions. Many thanks for breaking it down into those demos. I think it always makes it much more understandable. And I'm sure you'll join us later for the session for the real hard questions, right? Great.
Okay.
So I do see our next speaker already waiting. Let me just add him. Hi, Rolf.
Hello, how are you doing?
Good, wonderful. Great to have you. You're a cloud advocate at Geekle.
Yes.
And you're going to tell us about Microsoft Azure Chaos Studio, is it?
It is, yeah, it is.
Are you good to go?
I'm ready when all people are ready to listen to my story. So, thank you so much for joining my session today, Embracing the Chaos. Today I will talk you through Microsoft Azure Chaos Studio and how it helps to improve application resilience using this Microsoft service. First, let me introduce myself. My name is Rolf Schutten. I do work as a cloud advocate at Geekle in the Netherlands, and I'm also a Microsoft Azure MVP and Microsoft Certified Trainer. I've been working in the IT industry for quite a while, but only in recent years as an architect. So I've always had roles with a strong background within project and service delivery management, which you will see through my presentation today. And please feel free to connect with me on my socials, which are in this slide at the moment. Everything that's being covered within this session is also on my blog. So if you want to do this and familiarize yourself with Azure Chaos Studio, please go to my blog. and feel free to follow the step-by-step guide on how to improve resilience or application resilience with Azure Chaos Studio. So today I'm going to talk about Azure Chaos Studio and chaos engineering. And I like to start with some theory and the history, or beginnings, if you will, of chaos engineering. And then I would like to tell you a little more about Azure Chaos Studio, the Microsoft Azure Chaos Engineering service that is still in public preview today. And obviously after this comes the fun part, the live demonstration in which I intentionally introduce errors in our solutions in Azure. So looking at what is a resilient solution, let's start at the beginning and go through the actual reason we need resilient solutions. We all have to deal with service levels in our profession, right? And back in the days when I was a service manager, the service levels were extremely important to me in conversations with customers. The business part mainly has to do with a certain degree of business criticality. And organizations know that failure can lead to loss of profits or the stopping of critical processes. So one of an obvious example is a nursing home that cannot view patient data during a medically critical situation, which we obviously don't want. That should never happen because of the impact and consequences. Hence, these solutions must guarantee a certain availability and resilience level. And our businesses, health and safety do rely on applications and systems that, I'm sorry to break the fun, but they will fail eventually. And on this slide, you see several availability levels translated into the amount of unplanned downtime per year. So to meet the agreed availability levels, we must design the resilience of solutions in such a way that we can meet them. And the moment we step away from the paper truth and also look at the solution architecture and technology, it quickly becomes more complex. Because when we delve deeper into the meaning of availability levels, we have to consider that availability levels of the underlying components actually weaken the total solution. And this is especially true as complexity of application and infrastructure landscapes keep increasing. And to give a real life example of that complexity and that impact of underlying components is, let's suppose you purchase a virtual machine in Azure with an availability level of 99%. This means that we consent to a possible downtime of 3 days and 15 hours a year, which I showed in the previous slide. And if we would decide to make it a clustered solution existing of 2 virtual machines, for, let's say, to realize a high availability solution, we can get those levels up to an availability level of 99.99%. And we would then consent to a possible downtime of 52 minutes instead of 3 days and 15 hours. However, there is a catch, which has a strong influence on availability levels, actually, because you need something like a load balancer to realize that high availability solution. And that load balancer has its own availability level. And in the case of, let's stay with Azure, because, well, I do a lot of stuff in Azure. In the case of an Azure load balancer, the standard SKU has an availability level of 99.99% as well. So as a result, we do not achieve 99.99 availability, but 99.99 multiplied by the 99.99 of the load balancer, which results actually in 99.98 availability. And in this case, we consent to 1 hour and 45 minutes of downtime rather than the earlier 52 minutes. So that doesn't seem like much, but we're talking about doubling the amount of possible downtime. And the more components we add with our own service levels, the more impact it has on the resilience and reliability of the total solution. Networks, firewalls, databases, compute, they all individually affect the whole and contribute to the service levels of the total solution. And looking at testing, it is therefore not logical to test all the individual components separately from each other. The components within the total solution jointly determine the resilience and reliability as a chain. And this applies to both the applications and the infrastructure. Traditional testing methodologies have been around since the inception of software development, and they're mainly based on a pre-organized phasing of the software testing lifecycle. They consist of a little bit biased, but of a one-way process from software debugging to integration testing to host configuration, the underlying infrastructure, and so on. And this is often followed by functional testing with a new release of software supplemented with possible user acceptance tests. And the various tests are often spread over different teams and specialists. And this does not benefit the speed and agility of software development, but it also does not guarantee the reliability and the robustness of the total solution. So my statement is that traditional testing is just not enough anymore. And we must realize that breakdowns are inevitable. And instead of leaving breakdowns to chance, we are driven to consider built-in resilience nowadays, relying on the availability level of infrastructure components. A system or application must be designed as thin as possible to be just as resilient as the underlying infrastructure. Failures are inherent to complex systems and will cause downtime unless tested for. And this is exactly where chaos engineering steps in. Chaos engineering disciplines developers to build confidence in systems and break systems on purpose, but only so weaknesses can be found and fixed before they break when the least expected. Similar to pen testing, chaos engineering aims to detect weaknesses so they can be fixed. Its goal is not to cause damage, but to prevent this in production scenarios. And actually, Netflix was the first in 2011 to recognize that development models needed a change. Their intent was to move from a development model that assumed no breakdowns to a model where breakdowns were considered to be inevitable and driving developers to consider built-in resilience to be an obligation rather than an option. And to support this, Netflix developed Chaos Monkey the same year and released it in 2012. And in that same year, the concept of chaos engineering was officially born. Now, chaos engineering are thoughtful, planned experiments designed to reveal weaknesses in our systems. And yes, chaos engineering is basically breaking your systems on purpose, but with surgical precision, only so that the weaknesses can be found and fixed before they break when the least expected. And this can be done by breaking your systems on the application level, causing host failures, simulating resource attacks, for example, on the CPU or memory, performing network attacks, dependencies and latency testing, or even regional attacks to actually test out your high availability scenarios. So let's take a look at the general process of chaos engineering. The steady state, which is on the slide on the left top, is the normal behavior of your system. It is important to know the value range of a healthy state of your solution. And next to it is the hypothesis, which are what-if scenarios, like what if, in our previous example, the load balancer breaks, or what if one of the virtual machines stops. And designing experiments are about picking a hypothesis and scope the experiment, identify your metrics, and of course, notify your organization. Design your experiment as close to the production because you have to make sure that you want an emergency stop, but you also want to learn from it as close as to production. And you should minimize the blast radius as you don't want to create a catastrophic incident. Verify and learn obviously means running the experiment, for example, through a canary deployment. And learn on topics like time to detect, time for notification, escalation, self-healing kicking in, recovery time, etc. And last but not least, you fix and improve your solution so you prevent it will ever happen again, or for at least in production. And a deployment model that works very well with chaos experiments is a canary deployment model, in which you make a new version available to a subset of users as shown on the image on this slide. And in this way, you limit the blast radius, and you can always guide your users back to the previous version. And you must coordinate all these topics with the business, because the last thing you want is to be disruptive to production. After all, chaos engineering is there to prevent it and not to cause it. So have a meeting with the business owners, discuss the possibilities and impossibilities, agree on that you will periodically hold a retrospective with each other to continuously improve that process. And it is very important to never blame anyone during this process, but rather hold a growth mindset, because chaos experiments is not the cause of the problems, but it's there to reveal them. And to support chaos engineering, Microsoft announced Azure Chaos Studio on the 2nd of November in 2021 during Microsoft Ignite. So that's more than a year ago. It's still in public preview, meaning that Microsoft is still actually developing on the solution and is not giving any service level guarantees on the solution. And it is Microsoft's service to improve application resilience and disruptions. So Microsoft Azure Chaos Studio is a fully managed service, which doesn't require you to do any management or maintenance, and is deeply integrated into Azure with all things that we like the Azure Resource Manager, leveraging ARM templates, Azure Policy, role-based access control, etc. And Azure Chaos Studio comes with an expanding fault library. Faults are either agent-based or service direct, depending on the target type. So with these service direct providers, you are able to directly execute experiments to Azure resources. For example, Azure Key faults or Cosmos databases, network security groups, etc. And specifically for Azure Kubernetes Service, or AKS, if you will, Microsoft decided to leverage Chaos Mesh. And for the people that don't know what Chaos Mesh is, it's an open source chaos engineering platform specifically for Kubernetes. It does require you to install Chaos Mesh on your Kubernetes cluster, allowing you to run chaos experiments like causing pod failures, container issues, and network faults like delays, duplications, loss, corruption, etc. And just to give you an impression of what they actually have within their fault library, they have an extensive article on the it's learn.microsoft.com nowadays. It was docs.microsoft.com, but they have an extensive fault and action library with all kind of, well, let's say chaos tasks and actions you can perform. So the earlier mentioned Chaos Mesh pod faults, they have an extended article about how do you run these and what is needed. So you see here, the target type is an Azure Kubernetes Service Chaos Mesh, going more onto something that is relying on the agent base, which is an agent running within a virtual machine. You see that it is a Microsoft agent target type. And a sample of the JSON file is already given in this article, so you can run them or deploy them using ARM templates or any other provider like Terraform providers for Azure API. So they're still expanding this library, and I have a good hope for that they will keep doing that. And you can run these faults in sequence or in parallel. You can add time delays. You can group target resources across regions. And as I said, Microsoft promised to keep adding new faults that align to the failures users want to replicate in Azure, and beyond even, because I have been very keen on learning more about also leveraging Azure Chaos Studio towards other cloud providers. And it seems like running the Chaos Studio agent within virtual machines, you can expand it towards like on-premise environments or other clouds. Also, it provides controlled chaos where you can easily stop an experiment and roll back to the point where the fault is no longer being injected, to avoid having more impact to an environment than originally intended. And I did promise you to run some experiments, so I would like to invite you to run some experiments within Azure. And for today's session, I have actually prepared 2 experiments. The first experiment is causing a pod failure within our Kubernetes cluster. And I'll show you how you can get started by introducing faults within your AKS cluster with Azure Chaos Studio. If there's time left, I will show you how to kill a process within a virtual machine with the agent-based service. I will try to go through the whole process of onboarding, specifically for Azure Chaos Studio, and creating the experiment and executing it. And once again, if you want to get started with this yourself, after this presentation, you can find an extensive article on my blog that explains step by step what I'm showing you today. And there are also links to a GitHub repository with all the resources and the demo setup for running these experiments. Actually, within the setup I'm showing you today. So RM templates are available to deploy your demo environment. So let's go to my Azure portal. So what I'm going to do today is I have a Kubernetes cluster running the well-known Azure voting app. And as I showed you earlier, we do have a steady state here. The steady state is that I have an application running as intended, just working exactly as how I want it. And when refreshing the browser, I still get back to this app. And this app is actually, well, this is something Viktor showed you earlier. So I'm using the default namespace. Sorry, Viktor. Hope I don't disappoint you. It's running on a front end and on a back end. So I actually have two pods here, one for the front end and one for the back end. And it's publishing it through the load balancer on an external IP, which we saw here. And what I want to do today is install Chaos Mesh into this cluster. I will do that within a new namespace because I want to isolate Chaos Mesh being able to run. Because when I'm introducing pod faults, I don't want to disrupt the Chaos Mesh capability. So I have to isolate it within a different namespace. And then I will onboard and show you how you create experiment and run it. So let's get started by creating the actual namespace. But namespace chaos testing. And I'm using Helm to install Chaos Mesh. And everything that I'm showing on the screen right now is also within the earlier mentioned step-by-step guide, but it's also on the documentation site of Chaos Mesh and on learn.microsoft.com. So I'm not doing anything special here. You can all read it after this session. So I'm now installing Chaos Mesh within the namespace Chaos testing, and I'm setting the Chaos daemon runtime. So what this statement actually does is it's configuring its daemon runtime and socket path. If you want to know more about it, I do refer you to the documentation site of Microsoft because there's an extensive article on how these things work. So let's install this. Might take a few seconds to actually get it installed. And there it is. So let's check it created its pods within the chaos testing namespace. And it did. So these are not ready yet. You see that the ready state is still on 0.1. It's still creating its containers. And it deployed some controllers, which obviously Viktor in the previous session talked about what it does and what they don't. It's also creating a dashboard and the daemons. We will not get into those specifically, and we will not use the dashboard as Azure Chaos Studio will be the dashboard for us today. But I do want them to be up before going any further. Well, we don't need the dashboard, so I can go further. Something very important, and I will probably repeat this later in the session, but what's very important when running experiments with Azure Chaos Studio is identity and access management. We do need to give all the resources that are actually running these experiments, they do need the permission to run it. So when I'm looking at this Kubernetes cluster, there is actually an extensive article about what supported resource types there are and what role assignments they need. And for us, specifically for Azure Kubernetes Service Chaos Mesh, we do need the Azure Kubernetes Service Cluster Admin role assigned so that we can actually run the experiments. And I will do that on a resource group level, just because it's easy. But you can do that on whatever level you want. You can do it on the Azure Kubernetes cluster. You can do it on the subscription level. And I will actually show you how this works. Let's first go to Azure Chaos Studio, because I have to add it to Azure Chaos Studio as a target, and I haven't done so yet. So here you see all the resources that are eligible to be a target for our Azure Chaos Studio experiments. I'll drill this down for a little bit, and what I'm actually going to do is name filter. We want this Chaos Mesh demo AKS cluster to be a target. And if it would be a virtual machine, we could also deploy the agent, which is working as an extension on a virtual machine, but we're using the Service Direct, as I mentioned earlier. And it should deploy pretty fast. Let me refresh that a little bit. Still being created. There it is. So back to Azure Chaos Studio. We now see that Chaos Mesh, it is enabled for the Service Direct target. And what we can do now is we can manage actions that are actually approved to run on this cluster. So you see a lot of Chaos Mesh capabilities already being enabled. We're only doing the pod chaos, but I'll just leave this as default. But you can actually also filter these out if you want. I do have prepared the experiment already. So when you click on create, it brings you into the default details of creating an Azure resource, and then it brings you to the experiment designer. I will show you it through the one I've already created, but the view is actually the same when you create a new one. So let's edit this one. And this is actually the experiment designer. So I'm only running one step within one branch. This is actually where you can put in extra delays or multiple actions at once, or you can build a sequence. And you run it by performing an action. And in the case of Azure Chaos Mesh, for Chaos Mesh, you have to give in the JSON spec. And there are some things you need to know before working with Chaos Mesh with Azure Chaos Studio, because it's also in the article. The JSON spec that you have to give in is a JSON formatted syntax of the pod chaos kind in our example, and you can use the YAML to JSON converter, which is this one. I will come back to that in just a minute. But you only have to include the YAML under the JSON spec property. So don't include metadata, kind, etc. And when you go to the Chaos Mesh website, chaosmesh.org, you can see here types of chaos experiments, Kubernetes. We're going to simulate the pod fault. And actually here is the YAML file that is being used for running this experiment. So when I run this through the YAML to JSON converter, and it already told us that only beneath the spec we need for our action. So I delete this out. Then actually this is the whole JSON spec that we need. And I minimized it, and it's now on a label selector. And as you can see within my example, I used a namespace selector. All these capabilities and configuration items are known within the documentation website of Chaos Mesh. So if you want, for example, run it on multiple namespaces or on pods even, or just using the label selector, you can really customize this to any, well, source you like. Next, you choose the target resource. Well, we just enabled it on the AKS Chaos Mesh demo, which is running the Azure Voting app. And let's just save this one. And I told you that this experiment needs its capabilities to run it on the cluster. So what I will do is I will run a command to get its principal ID and give it the proper permissions, which is the Azure Kubernetes Service Cluster Admin role on the AKS cluster. So here I will, I've just copied this from my other screen. So you see here the name of the chaos experiment, and I just want its ID. Let me copy this in. Copy. And I want to give it a role assignment. Last. For the role. Here. Oh. Here, Kubernetes. Service cluster. Onto the resource group, as I mentioned earlier, just because it's convenient for me. Chaos Mesh Demo 001, which is actually the resource group where my Azure Kubernetes cluster is running on. And it did its magic. So now we're able to run this experiment and just show you again that everything is working properly. These are running, they have a running state. And the hypothesis is that when I run this experiment, they will break, right? Because in the example that Viktor gave you in the previous session, he did had multiple pods. So it would be fault tolerant for any compute or networking faults. And it would be self-healing, as you could say. I expect it to break, actually. So going to this experiment, let's start. And it would go through a few phases. So it will be pre-processing, and then it will say waiting to start. And then it will go into a running state. And when it's in a running state, we can actually expect it on the background that it would run for 10 minutes as we just configured it. So let's go into the details of this one. And it's actually starting now already. Going back to the Azure Voting app, let's refresh this, continue, and it cannot be reached. And it's actually expected behavior, right? So when I want to get kubectl again, showing all the information of my pods, you actually see that they do say it's running, but it had a restart for some seconds ago. And what it does is, because I said it has to run for 600 seconds, it's continuously performing its faults injection within this service. So it's not a one-time deal, right? It's not a one-time action. It's continuously causing chaos within the cluster. So let's just stop it. You can also keep it running for like 10 minutes, but I don't think we have the time for this session to do that. So let's wait till it's cancelled fully and see if it has the capability to restore itself to its previous state. So now it's cancelled. And if my demo works correctly, it should now work again. Always nice to see a demo work as intended. So that's for the Kubernetes part, right? So I do know now that in the terms of verify and learn, that when one pod is experiencing an error or a fault, my whole solution will fall down. So to fix it and to learn from it and to actually make this more production ready, I do have some work to do there. Now let's take a look at the capabilities for Azure Virtual Machine Manager. I have 2 virtual machines running on Linux, running Apache 2, just a simple website. So this is a black background with a white text. And when I refresh it, it will probably go. Let me show it. So I have the black one listening to port 80 from the load balancer, and 223 direct to this machine, and 224 to one with a white background and black text. And what we're going to do is actually introduce a fault in one of those. So going back again to these target machines, and let's say chaos demo. Chaos. These 2 machines, let's onboard them because they're not enabled yet. And here we will use, it's a funny thing, the agent based. Let me check in these virtual machines if I've already deployed them. I think so. Because it's grayed out, it shouldn't be grayed out. Ah, yes, I've already installed the Chaos agent on these machines, so that's why it's grayed out. But normally, when you first getting things done for virtual machines, you can actually deploy the Chaos agent through this experience running agent based. I now see that it's already enabled. So let's manage the actions here as well. Make sure that killing a process is enabled, which is not. So I'm happy to see that I still have to enable this. Kill process, because we're going to kill the Apache 2 process. And the same goes here, right? So when we're using the Microsoft agent, we need to give it the reader role. And I'm just going to make sure that that has been done within the resource group where these machines live. And here you see the Azure Chaos Studio experiment -Chaos Studio -kill Apache 2 has the reader role on this resource group. So once again, if one of your experiments is failing, it has probably to do with giving it the permissions on this level, or that it doesn't have the permissions to run the fault. Going back to Azure Chaos Studio. So what I'm doing here is the same experience within the experiment, but this time it's a little bit different experience because we're running it on the agent. So I do the kill process fault for 10 minutes, and the process name is Apache 2. And for target resource, I'm only going to do virtual machine number 1. So that should be the one with the black background. Now on 2, let's say, keep refreshing till it becomes black. Now we can do it on a port level directly as well. So let's get this one running. Same experience, pre-processing, waiting to start, and then it will start, and it will keep running until you cancel it or when the 10 minutes have been fulfilled. Waiting to start. And it's running. So when I keep refreshing this page, it would never go back to the black background one. Going directly to it, I think it's still caching and be reached. So when I'm going towards that machine, and just for the fun of it, I do want to show you that. Desktop. Let's go into that machine. I know this is not the proper way to do things, however, for demo purposes only. Clear this out. So this is actually machine 1. And when I look at the Apache 2 status, you actually see that it's failed. So it's actually doing what I wanted to do. For a matter of fact, I do know that when we stop this service, it will not self-heal out of the box. So something I learned by introducing these Azure Chaos Studio experiments and faults is that you need some mechanism for Apache 2 to restore itself to back to the state. So a system control restart in this case would suffice. But also we do know that if a customer has a multi-instancy solution like this one, it just goes to machine number 2 and it keeps working, right? So besides Azure Chaos Studio, there are many other chaos engineering tools available, both open source products as well as from reputable companies. And I won't go through them all one by one, but they each have their own characteristics, and it is advised to select one based on your requirements before you adopt the tool and start with building and running your chaos experiments. I do think that for the Azure native software engineers, most of you will have Azure Chaos Studio as the preferred choice. However, it is still in public preview, so that might be a deal breaker. But the thing is, specific requirements can lead to other chaos engineering tools just based on specific characteristics. And ultimately, the tool that you will be using is just a resource to reach your goal faster and easier, which is in this case achieve greater resilience. And I do have to say on a side note, QB Doom is probably the only valid and supervised approved reason to play Doom during your job. So that's a very interesting one. And well, Chaos Monkey, you can almost never go wrong with Chaos Monkey. However, it does limit control over blast radius and execution because the attacks are essentially always randomized. But it is the founder of chaos engineering tools, right? And I'm already coming to the end of my session. So let's summarize what I've covered in this session. Service levels of subcomponents have an impact on the resilience and availability of the total solution. So a 99.99 availability guarantee for a virtual machine does not mean that the entire solution is 99.99% available. And as a developer or IT pro, it's up to you to do your homework and do your math. Following DevOps methods, we're all responsible for the quality of the products and services we build. And the same goes for resilience. So building resilience is an obligation, not an option. In chaos engineering, if you organize it properly, makes the weaknesses in solution visible so they can be remedied before running it into production. And when a chaos experiment reveals weakness, it's worth celebrating. It's worth celebrating rather than blaming anyone. And there's a difference between chaos engineering and intentionally disrupting production systems, because nobody wants a developer or IT pro to take a hard look at the systems during peak times. And chaos engineering requires coordination with business operations. So devising deployment models such as canary deployments, taking care of intervention scenarios, minimizing the blast radius, all have to do something with the chaos engineering process. And chaos engineering is not only for the business, but it's with the business. And it requires its planning and collaboration doing so. So align the process and the work method and implement a continuous improvement and retrospective process with the business. And with Azure Chaos Studio, Microsoft has offered us an Azure native chaos engineering service, equipped with almost everything we expect from an Azure service. So its integration with Azure role-based access control and RM templates makes it a promising service for developers and IT pros already working with the Azure BIOS system. And although it's still in public preview, we can expect more developments in this service from Microsoft. And lastly, a fool with a tool is still a fool. So find your tools for the goal you have and to get there as quickly and efficiently as possible. There are many tools out there, and they all have their own characteristics. So if Azure Chaos Studio fits your requirements less than another tool, then you should use the tool that matches your requirements the most and helps you achieve your goals in the best way. So it all starts with getting a clear view on what you actually need. And that is where my session ends, actually. So thank you so much for joining.
Thank you so much, Rolf. Brilliant demoing again. Very valuable. Feels like having a sneak peek here. Do you have any advice, and allow me to ask a beginner's question here, on when you build your hypothesis, which I understand is the basis, not to miss out on anything to be successful in building the interface project?
Yeah, it's actually like you have the functional and the technical requirements, right? So when you talk with your customer, which can be an internal customer or external customer, but when you talk with your customer, they do need an application or a solution for a specific need, whether it be a manufacturing company or it be someone in healthcare. And you will just brainwave on some what-if scenarios. So in the example I gave for a nursing home, what if I need my data for a medical critical situation? And probably the nursing home owner, business owner will say, you should never come into the situation where you can't go to your patient's data. Okay, that means something for high availability, right? So you will bring in what-if scenarios and hypotheses for running experiments that will, it's like red and blue teaming. So the red team will actually try to break it, to prove that the solution isn't built properly. But then again, all for the sake of improving the total resilience of your solution.
Excellent. I don't see any other questions at the moment. So for everyone, as a reminder, please make use of the Q&A panel. We will pick them up and have you later in the Q&A session, Rolf.
Yes, see you there.
Many thanks.
Thank you.
And bringing in now next speaker, Piotr Zaniewski. Hi.
Hi, great to be here.
Yeah, great to have you. You're also at Upbound and you're a senior platform engineer. And you're going to tell us which architecture to choose for Kubernetes.
Absolutely. Thank you.
Oh, okay.
All right, let me share my screen. All right, that should be the right screen. Let me know if you can see it. All right, so I'm super excited to be here. And as you mentioned, I will be talking about Kubernetes and specifically how to reduce complexity of working with Kubernetes and how to reduce toil using the right architecture. So a little bit about me. I currently work at Upbound as a platform engineer. I'm passionate about cloud native technologies, obviously Kubernetes, and specifically in relation to cloud and infrastructure. You can reach me on Twitter for as long as Twitter is still operational, but I'm also prepared for any eventuality, and I already have my Mastodon account. So you can find me there on a Mastodon node. If you're interested to connect, I would be happy to hear from you. All right, so we all know that innovation is a key. So we really want to move blazingly fast, to quote Rust. And once famously, Mark Zuckerberg said that if you don't move fast, you're basically gonna left behind. And this is all true and correct, but there's a little caveat here. As long as you're moving fast, responsibly, and you can predict what you're doing, and you have to actually have a nice and sound architecture, everything is great. If you don't, well, bad things can happen, right? So having an architecture along the way is a critical part, especially nowadays. And why nowadays? Because systems nowadays tend to be way more complicated and way more complex. Currently, I would say that with a mature system, production-ready system that does non-trivial things, there is no single person or often even a single team that can, fully reason about the system. So the complexity grows, right? So how does Kubernetes complexity look like? Well, Kubernetes is de facto standard in container orchestration, and not only. If you listen to Viktor's talk, he explained what are also other superpowers of Kubernetes. But focusing on the Kubernetes primitives or Kubernetes resource model, you can start by creating simple YAML, but if you really want to be production ready, you will quickly end up needing to create security settings, map environment variables, PVCs, resource quotas, and so on and so forth. So as a developer, you probably are more interested in, hey, I want to deploy my image, my web app, my API, and I just want it to work, right? And you don't want it to be bogged down by all those complex Kubernetes settings. So another example of Kubernetes complexity is, it's all its primitives, right? So I marked here with a star all the primitives that typically developers would care about, so config maps, deployments, and so on and so forth. But there's obviously more, and those primitives are usually taken care of by ops team, or if you're unlucky and if you have to do this as a developer, where it's a huge burden and additional cognitive load for you to take care of. This comes without CRDs, custom resource definition, that Kubernetes uses to express additional APIs of multiple products that you would have to install, projects you would have to install in your cluster. So this complexity will exponentially grow. So how do we address this complexity? How do we solve it? And my idea here is that architecture should focus on reducing toil and simplifying everything for developers. Nowadays, we have a very famous, I would say, famous movement of shifting left, which means moving the operational burden, so to speak, to developers. But to do this shift left correctly, we don't really want to just dump everything on developers and say, hey, have fun, right? It's not going to work. So when we architect solutions, especially in the cloud native space, and especially with Kubernetes in mind, I believe strongly that architecture should focus also, or maybe even more so, on the organizational aspects and things like platforms, self-service, rather than only focusing on the technological aspects of how do you slice and dice your microservices and stuff like that. So there are 4 pillars that I believe are critical for a successful architecture to be put in place. First of all, I am working for a platform team, so I'm obviously biased, but I strongly believe that internal developer platforms are becoming mainstream, and this is something that is going to be even more pronounced and prevailing in the future. So having a platform team in place, consuming platform level services and shared infrastructure is a critical buffer to help developers not be overloaded and let them focus on software, so kind of reduce their cognitive load. The concept of self-service is very important. So obviously, we don't want to wait a lot for Jira tickets or any other means that somebody has to maybe write a Slack message, an email, or something else, and there's kind of endless cycles of back and forth until something is done. So self-service is important, but self-service whereas it provides very low friction or reduces friction, it should really be secure. And that kind of goes to another point. We should focus on innovating, as the famous saying from the beginning went, that you really have to move fast, but this innovation has to have a secure guardrails, and it needs to be standardized. So there are standards, as in HTML standard, HTTP, or there are also de facto standards, as in various products and projects. So providing those standards for developers, and through the standards, making sure that we limit the choices and limit the actions that can be taken against the system, which is a good thing. You can innovate in a secure way when you just have a specific golden path that you have to take. And this leads to simplified development. So developers can fully deliver on the premise of you build it, you run it, but then they can also shift left in a very safe way when platform level services are available, and they can take advantage of those things and manage infrastructure as well as their services via proxy APIs that I will be focusing on in the demo part. So real briefly, before we jump to the demo, the resources I'm showing you are obviously free and available. This presentation is in slides.com. I think Geekle will share all the links later. I will go through an interactive scenario on Killer Coda, and there's also an accompanying blog on Medium that you can go through. All right, so let's jump to a demo. So in this demo, we are going to focus on reducing friction and toil by using cross-plane Kubernetes provider. If you're not familiar with cross-plane, don't worry. I'm not going to go too deep into it. Cross-plane is a framework to build control planes. What does it mean? It essentially means that we can take the Kubernetes superpower of creating control loops and observing external infrastructure in this case, or internal Kubernetes resources. And based on these control loops, we can create APIs that we hand off to developers and thus hide complexity from them. So here I have a little graphics explaining what crossplane is. We're not going to go through all of it as promised. This is all freely available. You can essentially see that developers are dealing with a single crossplane resource called claim. If you know Kubernetes a little bit, and if you remember about PV and PVCs within Kubernetes, so persistent volume and persistent volume claims, you can think a little bit about claim and the other parts of crossplane machinery in the same way. So crossplane is relatively complicated inside, but the abstraction that it provides is very simple. So developers will only deal with the claim part. So let's see what we are going to do today. We'll try to understand how crossplane can help by providing a unified API to developers and hiding complexity, but not obscuring it. So hiding it in an automated and correct way. We will see some basic building blocks of this architecture in action, and we're going to go through a kind of real life scenario of doing it. All right, so let's see if our cluster is up and ready. We're going to get pods. So what I'm doing here, I'm just clicking on commands rather than typing them, which saves us some time. We have all the pods running, 1.25 Kubernetes, a pretty fresh version. And I have also Octant. Octant is a visualizing software for Kubernetes cluster. We're going to use it to see what's happening during the demo. Let me know if this is enough, or maybe make it bigger. Okay, so let's start. So we want to simplify Kubernetes. In this scenario, again, it's a very simplistic scenario. We have developers that want to tell us in a simple way, I want to deploy a web app. But from the company perspective, we want to make sure that this is done in accordance to company best practices. So things like ingress, horizontal pod autoscaler, appropriate settings on resource limits and quotas must be enforced. But developers don't really care about it. They just want to give us an image, maybe some port or some basic information as an API, and then the machinery of Crossplane will actually make it happen. So what I'm going to do first, I'll just show the demo, and later in the later part, we're going to actually talk a little bit about how those things happen and what is Crossplane superpower that empowers this architecture. So what I'm doing now is I'm applying Crossplane files, basically YAML files that define what API developers will interact with. And I'm also applying another file that defines what will happen when the developer will create our claim. So this was successfully applied. Another file was also successfully applied. And let's see. So we can show that there is a definition of our claim, apps.acmeplatform.com. We can also see that we have some compositions, and the composition is something that decides what's going to happen if I create this simple claim. We want to see what's going to happen. All right, so let's create a new namespace. We are creating a namespace for a DevOps team that will consume this API and create all the Kubernetes resources using it. So I want to swap to Octant real quick and show you that there's nothing running in this namespace currently. So we have just default Kubernetes resources in this namespace and nothing else. Right, so when I apply this file, as you can see, it's a relatively simple file. Let me make it a little bit bigger so everybody can see. We have this app claim file. This is something that I, as a platform person, defined for my developers. We have some selectors and labels, but more importantly, we have a namespace and we have an image. And those parameters from this section are the only fields that my developers care about. Nothing else that you will later see resulting Kubernetes resources. There are something that just is completely obfuscated from them. Now I want to just mention one more thing here. We are using Kubernetes provider to show the architecture where we're exposing API at one hand and then developers consume them. But Crossplane is way more than that. You could imagine here that based off of this claim, maybe my developers would like to also create an S3 bucket in AWS, or maybe they want to create a K3S cluster in Civo. So using different providers, I can of course make this arbitrarily complex behind the scenes and still maintain a very simple API for my developers. All right, so let's apply this file. Now we're going to wait for the image to be pulled, and hopefully Docker is not going to slap us with the rate limiting. Fingers crossed. Once this is pulled and we see the resource, we can actually see what happened. So here are the managed resources that were created just based on this simple file. And swapping quickly to Octant, you can see that this namespace that was previously empty now starts filling up with various Kubernetes resources. So we have deployment, we have pods, we have replica set, obviously, horizontal pod autoscaler. We don't have ingress because this Kyrkoda environment does not have ingress controller configured. But otherwise, our application starts is being created on the cluster. Right, so this is great. Let's see if it actually works. I'm going to port forward to a pod, to a port of the pod and container running in my pod and see if we can see our web app. Fingers crossed. There we go. Very aggressive green, but there is a demo web app running. So now, if my developers are interested in upgrading an image, let's say, of this web app, again, they can use another YAML file that looked very similar, just has a different image inside. In production, we would obviously use GitOps, or much more sophisticated tooling to allow for this image to be upgraded. But for the demo purposes, we just apply the same file with different image. And we're going to wait a little bit for the image pool. And let's see if our page changed. All right. It's still green, but if I refresh it, it's still green. It will be blue at some point. You just need to wait a little bit. So while this refreshes behind the scenes, I want to, so this is like the basic flow. And I think the key takeaway from here is that at one hand, we exposed a simple API, versionable API to our developers. And at the other hand, we created a relatively complex, in this case, simple, but it could be complex, setup on Kubernetes. So every time developer creates this simple file, we will see all those resources being created or managed. So one last time, let's give it a try. Oh, it's just slow, but I'm sure it will refresh at some point. All right, let's port forward one more time. And let's check it now. Hey, there you go. So we just updated the image and everything worked the same. So all the services in Kubernetes are as they were before. All right, before we delete the app and go through to the last part of the demo, I want to show you something cool, what Crossplane can do. So let me hide this for a moment, clear the screen, and you can see, we can hope that I'm not going to click Control W, which will close the window. Well, let's see if I remember how to do new window. All right. So what I'm going to do now, I'm going to show all the resources that are currently deployed to DevOps team namespace. So we're going to watch for them. kubectl get all namespace DevOps team. And you can see here we have this service. So as you might know, if I have a deployment, if I delete a pod, Kubernetes itself will recreate this pod. And this behavior is innate to a deployment resource. This behavior is not the same for all other resources. So if I delete a service, it's gone. But because we told Crossplane to watch for our resources, I want to make an experiment and see if I delete this service. So delete SVC, namespace DevOps, and it was Acme platform. So look here, the service should disappear. And it's gone. But if everything works well, Crossplane is observing, monitoring my all infrastructure. And again, in this case, it's just a simple Kubernetes resources. But imagine that you have cloud resources and other stuff deployed. And after a next reconciliation loop ticks, Crossplane should bring this service back. So it might take a couple seconds, minutes, depending on the reconciliation tick, but this should definitely work. So let me move the screen a little bit here, and you can wait. Oh, there we go. And service popped back up. So if anyone has access to cluster and kills the service by accident, then we will have the service restored right back up. Okay. I'm gonna kill Tmax server. And so what's the secret sauce? What's the superpower here? Why we were able to transform this simple API into those various complex Kubernetes resources? This was possible thanks to Crossplane compositions. And composition is kind of what it sounds. I am able to compose various resources together. And again, I want to emphasize that this don't have to be just Kubernetes resources. It can be literally anything. I could, for example, create an S3 bucket. I could also have, maybe OPA policy that looks at those resources. Since it's all Kubernetes, the possibilities here are endless. So what composition does, it composes together a set of managed resources based on this claim. So if you look at the composition itself, I cut some details out of the file. But remember, we saw that there is a deployment. So we have this deployment still here. And this deployment YAML would have, various fields that we didn't specify as developers. So this deployment would have, liveness probe, it would have resource limits and quotas and so on. So this deployment is being created as a response to our simple API. The same happens with the service, the same happens with other resources. And you can see here sections that's called patches. So what is patch? You can think about patching as kind of like a templating or variables if you come from programming language. So what this patch does, it takes a field from a claim and it takes its value and it changes the value on the target resource that we are rendering. So in this case, I am taking a spec ID value and I am changing it to metadata name. So thanks to this, I can kind of stamp various resources for different namespaces, different teams, and I can expose different values or different variables depending on what my development teams are interested in. So you could imagine having maybe composition for production cluster or having composition that additionally renders a S3 bucket or stuff like that. Again, here's possibilities are endless here. All right, so you can look at this and familiarize yourself with it, obviously in the Kubernetes docs, but let's quickly summarize what we learned today. So the key power of Crossplane is really the ability to create abstractions and expose those abstractions via API, and then developers can consume the API and then have the infrastructure or other items created. We have fulfilled the promise of self-service, since developers can just create a simple YAML file and they can do this themselves. They don't need to ask platform team or anyone else for permission. As long as they have access to the file, they can do this. We have significantly increased automation in our architecture. Now everything kind of happens based off of the YAML setting that we created. And we introduce standardization via Kubernetes resource model and API. So now everybody that is familiar with Kubernetes can follow the same Kubernetes model, which is spec and status, and those can update files, create new ones, and we have the same API and the same way of dealing with things. So our architecture so far successfully enabled our developers to fulfill the premise of you build it, you run it, and enabled them to shift left without putting too much additional overhead on the teams, on the development teams. Right, so you can try all those providers and additional components from Crossplane yourself. I'm going to briefly show you the Upbound Marketplace, which has been recently released. And you can see here we have providers. I can browse providers. So we have AWS, we have provider Azure, GCP. We have also provider Kubernetes, Helm. So you kind of can start having a feeling how you can compose those providers and expose really complicated infrastructures kind of that are your company infrastructure. What is also interesting here, we have configurations, and this is something that I've used to show you the demo. Configuration is like an opinionated set of APIs. So I could distribute my configuration that I showed you with this demo, and you could use it today to create the same service, horizontal pod autoscaler, and other Kubernetes resources. There's a way of packaging those elements and distributing them in various ways. So highly encourage you to browse the marketplace, see what you can build yourself with Crossplane, and you also take advantage of existing configurations. So I want to just give a shout out to Viktor for creating the dot applications. Those are super awesome, more advanced than my demo, and actually you can use them already to do something cool. All right. There's a few other resources that you might want to check. We have a lot of blogs. on abound.io. I also have my own blogs that you might want to read about Kubernetes and this architecture style. And obviously, we are hiring. If you're really interested in this kind of architecture and or platform engineering, let me know, or just you can go to our job openings and check them out. All right. With this, I think I'm also a little bit earlier on the schedule, but that's all I wanted to show you today. Maybe we can open for questions.
Yes, actually, I would like to suggest that because I see there are a lot of questions addressed to Viktor, but maybe you can take one of those ahead. So I have one here. Could you maybe list any pros and cons using Kubernetes for resources deployment versus Terraform?
Absolutely. So there are quite a few. So one of the things that come in mind is that when you use Terraform, you have to give developers access to the infrastructure. So somebody has to have access when they deploy, right? So credentials for cloud providers or whatever Terraform provider is being used have to be available for developers. Whereas with Crossplane, we have a notion of provider config, which actually is something that platform team deploys. So credentials are always hosted on the cluster or in Vault, and developers only select appropriate infrastructure by a mix of labels and provider config names. So that's one important benefit. Another one that I like personally a lot is because you have the API that you can provide to your developers, and this API is standardized on Kubernetes resource model, you can use all the CNCF ecosystem tools and projects with your setup of Crossplane. So I mentioned briefly that you could, for example, use OPA or Kyverno or Datry or other tools to create policies for your YAML files that you deploy with Crossplane. And they will work out of the box. You don't need anything special to create those policies. So you can integrate, OPA, let's say, with your Crossplane installation. And the third thing I want to mention is kind of like the real difference is in fact that you create APIs. So Crossplane, like in its Crossplane philosophy, you have the idea of creating APIs that you expose to developers, and through compositions, you render various different states of your infrastructure. So this is something that also strongly differentiates the two products.
Excellent. And I have one more before we let you go. Would you have a strategy to transition from serverless to Kubernetes cluster?
Right. So if you already have serverless, it depends a little bit on the architecture style that you're targeting. So serverless is perfectly suited for event-driven architecture where you have small payloads and you have to basically react for event-driven events that might not happen continuously. They're just like every now and then you have an event. So that's like a perfect scenario for serverless architecture. If you want to migrate, and you obviously you thought about it, you're ready for migrating, there are kind of two approaches I would recommend. So you might try first Knative, which is serverless on Kubernetes. It kind of brings you closer to Kubernetes world, and you can start mix and match. As you assumed maybe incorrectly that you might have your serverless somewhere in cloud provider, then Knative is like a middle step of trying to recreate your functions directly on Kubernetes. And then I would say what is very important to do is to think about your containerization, because serverless typically are extremely split. So very small functions, they might belong to similar domain, but you have a lot of them. So then, as you do the exercise of like domain-driven design and you go through to your microservices, you see how you split them, then you can think about, okay, maybe I want to pull some of them into one container. And then, just basically create a container. Once you have a container and you're happy with the way you split your microservices and happy with the API surface, you are good to go. Just stack the container in a manifest, use Crossplane to create your Kubernetes resources, and you're good to go.
Excellent. Many thanks. Okay, so then I think we'll have an announcement now before we introduce our next speaker. Talk to you later, Piotr. Thank you.
Thank you, everyone.
See you.
All right. Good time. I hope everyone is enjoying the presentations and the summit. And this is just a quick reminder about the workshop on 17th of November. And CodeScene and Geekle welcomes you to the free hands-on workshop with Adam Thornhill. He is the founder and the CTO of the CodeScene, and he's one of the speakers during the conference. And at the workshop, Adam will mix together theory and practical exercises. So basically, you will learn how to prioritize technical debt and examine code health and the code health issues in your code. And if you want to get the most out of the workshop, make sure to implement CodeScene for the practical part. They have a free trial, and you can sign up for this free trial via link in the chat. And also, we will have a link to the workshop in the chat. So if you want to share it with your friends, definitely. It's a great workshop, worth sharing. Here is the link. And I nearly forgot about the iPhone giveaway. To partake in this raffle, you simply need to fill in the form that you will see right now in the chat. So just type in your email, and we will have a giveaway at the end of the third block today. The form is in the chat. Good luck.
Hi everyone, my name is Lilia, and I would like to make a quick announcement about next conference for a few days. It will be a Data Science Global Summit, and I would like to see everyone on this event. It will be great 3 days virtual conference, and you can meet best speakers from best companies like Google, Microsoft, Adobe, and others. You could share your networking and share your knowledge with others. So let's join us. And now you can see a promo code for full access tickets. Please register. Let me know your minds, your proposition, and hope that we will meet there. See you.
So everyone, we're ahead of time. We'll have a short break because our next speaker is only due in 15 minutes. So hope to see you then. Thank you. Hello, everyone. So we're back, and I can already introduce you to our next speakers. This time around, we have a duo, two architects from EPAM, Mark Makary and Safak Kapci. So let me try and add you. Hello, Mark.
Hello, hello.
Hi.
Can you guys hear me well?
I can hear you well. I'm just waiting for your colleague, Safak, and I see that you have already your presentation on. And you're going to tell us, you're going to introduce us to event streaming, isn't it?
Correct. Event streaming and the ecosystem surrounding event streaming and why it's really coming to picture right now and the hype around it too.
Excellent. Looking forward. Stage is yours. Go ahead.
Great. Thank you very much. Really grateful for the opportunity. Thank you very much for everyone joining the session today, and thank you for our host for having us. Thank you for the great efforts that you are doing to enrich and grow the community. My name is Mark Makary, and I'm leading the fast data service offering within the EPAM data practice, and joined today by my colleague Safak, who is also a solution architect within the same group. So our group is focusing on building real-time solution based on event-driven architecture and event streaming. And we really get involved in different use cases across different industries on daily basis based on that. And I'm really happy to be here and share our experience with you today. So what's happening with event-driven architecture? Why is the hype and why it started to become in focus in so many things today in our IT and enterprise ecosystem? And a lot of people that are asking, is it just another cycle of ESB or so? And if it's here to stay, and why people is actually talking about it as a cycle. And to understand this, let's take it a little bit back in time and see that why people are asking about that. So I think maybe 2007 or so or 6, around this era, we started to see ESBs and middleware, message-oriented middlewares that coming to picture and coming to life. There was a lot of recognized event-driven architecture benefits. If you're having decoupling between services and consumers and services, there is really a lot of benefits in there. However, during this time that we focus more around strong consistency, we were looking into governance and consolidation and things like that. And that led to a little bit of a slow time to market effect. And actually, during this time that we started to have a lot of demands on the competition side, economic drivers that were changing to have instead faster time to market. So that bottleneck stuff that didn't help much with this. And it's always easy if you don't have more on the traffic, more on the volume, of requests coming in, or the users that consuming services from your system. Once you start having more and you need to scale, that's when we start running into real computer science problems to solve. The same thing that happened with the ESB, and people thought this is really too much of a bottleneck, so decided to move to the next thing. And then came REST APIs with microservices. Of course, we got rid of SOAP and things like that. And people with pizza boxes and agility and containerization and introduction to cloud. And actually all this led also with the mobile apps and all the traffic that coming from there. So we went all the way to microservice architecture, and then the whole thing around the ASB and the MOM died. However, when we went there, we started increasing again the number of services that we are using. There is a lot of dependency and cascading effect between the services. And that also scaled to a certain point, but then after that, we started to have problems with it and on the resilience and scalability side. And that also didn't work very well for us. At that point, there was a lot of movement within the industry looking into why we don't go back to decoupling again to EDA, but this time that we would have something different to fix all the problems that we had. So we looked into things that were we looking into separating the state from the events. So why don't we just record the events and build the states outside of the messaging system? Let's move the services outside messaging and build ecosystem around it instead. And event streaming, was born. We looked into eventual consistency versus strong consistency. Would give us more on the high availability and the scalability side. And if we really would like to have durability, let's have persistence, district persistence around the Hadoop ecosystem. And there that to give us durability and time travel, if you say, to be able to replay events and things like that. And that really helped a lot and helped us with the performance and the scalability improvement that they were looking for. So event streaming was a new world of event-driven architecture, and a new era also started in here. So having said that, we look at this and, okay, so a lot of people also asked now that, okay, we solved a lot of problems when it comes to EDA with event streaming. You can provide resilience through replication. You can provide performance through concurrency and parallel processing, through partitioning, and you can scale horizontally and vertically and everything. And all what you need to do in this environment is just go and create producers and consumers. And now we are speaking also on the career track, so a lot would ask, so what is it really in there? Why even you have a lot of people get involved in the architecture and engineering side in that space. Basically because it is not really that simple. So as you can see, event streaming now is becoming a cornerstone of the modern application architecture era and design patterns. So we have reactive microservices with reactive manifestos coming in at the same time. For instance, they are driving to build responsive, resilient, elastic, and cloud-friendly systems. And they do this through messaging. So they have decoupling in 4 different areas. They have decoupling on time, so you don't have that cascading dependency they have with the services. You can improve the performance in there with fire and forget. You can have isolation and decoupling on space, so you don't need to know where the service is. You just drop the message and you have a separation between the services and consumers and services in there. You don't care where the service is deployed. You have isolation in the state, so you have eventual consistency versus strong consistency, and also the fourth factor, which is very important one on the resilience side. You have decoupling on the failure. So the cascading failure that with the REST and stuff like that is not happening anymore. Also, at the same time that you have the Mac architecture, which also people wouldn't notice that, but it's quite related to reactive. So you have reactive microservices in there that as part of it on the API aspect, if you think about events and commands as APIs, and cloud native, definitely need the flexibility, elasticity also in there. That was the decoupling and the isolation. And even with the headless that they remind us was hexagonal architecture and other design patterns within reactive architecture, like domain-driven design, which is very important to this. The state of the entities really changed based on the messaging system, and there's encapsulation that's happening in there. Things like event sourcing and command query responsibility segregation design pattern at the same time depend on reactive. So a lot of synergies in there that on the modern application architecture. and at the core of it, again, that you have event streaming, a new era of event-driven architecture. So what's happening on the analytics side? So on the analytics side, that you also see a lot of school thought that then comes in there and talk about that moving from ELT. So what's the story with to streaming ETL? So what's the story in there? So traditionally also, or historically, that we for the analytics aspects, we usually go and prepare data for analytics using ETL. So we extract, transform, and then load. So with, again, volume and more to do on the data side, and data coming from everywhere, even like user sessions and for know your customer or things like that. So this data coming in real time and putting offload in the system, and it's difficult to use a point-to-point batch and integration in there within this scope. So people thought about it and said, well, instead of doing the batch ETL, let's go for ELT instead. So we are going to extract the data, load them into data lake, for instance, and then the consumer of this data, that they will do the transformation. They will clean it and do everything that they need in there to be able to have access to to this good data. But then after doing this, they start to figure out, oh, so there is a problem. Data science is spending most of their time actually cleaning this data in the data lake, and this model also is not working very well. That's where Kappa architecture that you see in there, that we would have event streaming at the heart of it, with ETL streaming coming in and saying, well, let's try to clean the data closer to the source. Let's try to have lower total cost of ownership and try to reduce the cost on our systems by replacing the point-to-point integration with event streaming and event-driven architecture. It comes also with scalability, comes also with agility in terms of the time to market. And the most important thing of all, that we need the data more and more in a timely fashion, which is the real-time aspects that we talk about when it comes to event streaming. So having said that if you look at the simplified picture, it's really completely different than what we see right now. And there was this whole ecosystem that built around event streaming. So in terms of architecture and engineering, we do a lot of things on the producer side. When we bring in the data, it's not just the connectors or change data capture or IoT stuff, a lot of things that we do on edge computing, the web apps that we're bringing in, the APIs that we build to bring the data in, cloud and hybrid cloud models that we are seeing right now. And someone would think about it that it's just bringing in data, but this is not really the case. You bring in the data with consistency, you have to handle error and recovery and failures, order management, duplication with idempotency, delivery guarantees, all the stuff that you have to manage, even if it's included in the event streaming platform. And as you can see, that the ecosystem is built on the operational side, built on the eco side, that my colleague Safak is going to talk about the data products and the data mesh, but also at the same time just give you a bit of flavor in here. So his data product is data sets with specific business value that you can use in there to provide value for the business around information, reports in a timely fashion that where they need it. And as we mentioned, we can clean the data, curate it, and closer to the source to be able to provide good data in a timely fashion for the lines of business. And for these data products, you do a lot of things in different forms. You can have structured streamings, can have the data in a good quality and good metadata in the data lake with good governance. You can have machine learning in real time along with time series. You can have APIs encapsulating your data as a service. And of course, you have your traditional dashboards and real-time analytics. On the operational side, that we have the microservices, the workflow, the API smart routing. So when you get specific event, you check into the data in it. And if you find the match, you would call specific APIs the integration with the ERPs of the world and the real-time alerts. So as you can see now, because we are on the career track, we cover a lot of space when it comes to event streaming and the ecosystem surrounding it. So luckily, there is a lot to do in there. So how is this related to the data mesh? So on the data mesh, you have the concept that being able to have a distributed system, there's no bottlenecks anymore, a single point of failure. It's based on domain-driven architecture and domain ownership. You have the data products that we are going to talk about it in a little bit. You have the federated governance, and you have the ability to go and do a lot of self-services, self-service work in there. So the ecosystem that you can see in here give you the ability to do all of this. And my colleague Safak in here is going to pick it up and run it from there for the next part. So Safak, I'm going to hand it over to you.
Thank you so much. It was great presentation so far, Mark. I hope I can continue doing it.
Absolutely.
Okay, so I would like to start by what data mesh is not, because right now we have a lot of rumors, hypes, and everything. So data mesh is not a data lake, right? This is the most important part. And it's not a centralized data mesh. Data mesh is not definitely not a magical solution for your all problems. So do not expect that it will solve everything for you. Also, it's not feasible for small data sets or small organizations. And the best part is data mesh is not suggesting any technology. So basically you are free to do. It's totally up to you, but you need to choose something, useful. So what is data mesh then? Data mesh has 4 important pillars. The first one is domain ownership. The second one is data as a product. The third one is really hard to achieve, but it's quite important. Self-serve data platform. And definitely from my point of view, the hardest one is the federated governance, because it requires a lot of definitions and organizational changes. So as you can see from those 4 pillars, data mesh is about organization, how we are organizing your company, how we are organizing your teams, and so on. This approach has been designed to reduce the workload on the central data teams. As you know, in modern companies, we have usually a central data warehousing team, central data team, and they are trying to handle everything. So this is what we are trying to change with data mesh architecture. The main purpose is to create a faster way to market, but there is also one benefit. Since data mesh is oriented on a data product, it means that it avoids you to become a data swamp in your organization. So data mesh without domain-driven design, it's impossible to achieve. As you can see from 4 pillars, one of them is domain ownership. So definitely you need to have a domain-driven design within your organization. If you do not have it, and if you would like to go with the data mesh approach, first you need to start changing to domain-driven design, because you need to have bounded context and ubiquitous language. So data as a product. This is quite strange definition. Everyone has an idea when I say data is a product, right? Data products. But actually, when we start digging in with other people, I discovered that everyone has totally different idea and different definitions. According to Zhamak Dehghani, the founder of the idea, data products should have those attributes. On some point, it's totally up to your definitions, but the data product should be discoverable, addressable, or understandable, right? Those are simple. Trustworthy and trustful, natively accessible, interoperable, variable, and secure. So basically, when I tell you those attributes, you decided to think, right now you are thinking, okay, so discoverable means that we can put it somewhere, XYZ location, and anyone can read from it. But some other person might think that, no, discoverable means that we would like to have API endpoint and we would like to just request it. So basically, you need to spend some time on those attributes before you are saying that my dataset is a data product. And one of the most interesting questions, for example, an Excel sheet, could it be a data product? Answer is yes, if your Excel sheet provides all those attributes, or at least some of them. So in some organizations, we are just going with Excel sheets as a data product, and it's working perfectly fine because they have this ownership. So data product types. We have three main types: source aligned, aggregated, and consumer aligned. The names are very self-explanatory, so I'm not going to dig in there, but just be aware of that. Those three definitions will take at least a couple of hours to define what does it mean for your organization. So far we have talked about data products and domain-driven design. But right now, we need to talk about the self-service platform and federated governance, other two important pillars. So federated governance means that you need to have some kind of policies, but they shouldn't be so strict, because your domain will have the ownership of this data product at the end of the day, right? Yet, you should enforce some policies, like PII data cannot be shared without any confidential warning or something like that. You should have those policies from the up. Yet domains should have total freedom how they are going to proceed, what they are going to do, and so on. And also you need to set an enabling team. This is quite important if you are in the very beginning of your data mesh journey, because when you are implementing a new technology, new approach, first, you need to consult, you need to have examples, and you need to know best practices. Especially when you are creating a new domain from scratch, it requires huge amount of effort, the developer effort, and organizational effort. You need to have those definitions upfront before your developers start working on it. So, self-service platform. Actually, this is just an enabler. So basically, it provides you capability to create your own data products with the given freedom to domains, right? Let's assume that I am a domain developer and I would like to create a new data product. What should I do? Who should I consult? So basically, in this case, data platform team will be your North Star, let's say, because they will provide those abilities such as cataloging, monitoring, policy automation, and so on. Basically, federated governance team will decide policies, and data platform team will implement these policies as an automation to whole data products. Yet, domain developers will have total freedom to decide what to do if any restricting policies are there. Okay, I would like to talk about data product canvas because this will create a lot of confusion in time within your organization, especially if you are new in the data mesh domain. So basically, we discussed that to call a data set as a data product, you should have some attributes, right? And this will be decided by you, by your team, by your federated governance team. Then you need to put it there as a documentation. Okay, guys, this data product will have those definitions, will have those attributes, and so on. Then you need to think about possible consumers. It is important. When we are talking event streaming, we usually don't care about who might be our consumers, right? But when you are creating a data product, you also need to think about your consumers. Who might be your possible consumer, not specifically, but just in general, because it will give you the hints that how you can create a new data product, when you should create, how you should create it, and so on. The classification, of course, is it confidential or not, or PII data, HIPAA data, whatever. You need to also specify the domain, because you will refer this document, and this document should be something, continuously updating document. It shouldn't be like, I put it there, it will be there forever. No. I forgot to talk about one thing. I would like to go back to data products attributes. Variable. one of my data mesh implementations, we literally spent like a full month to understand those attributes and what does it mean, because some of keywords are very blurry, right? For example, variable, what does it mean? How does it work? So basically, you can say that, okay, if no one has accessed the data product for last 3 months, you can delete it, right? Because we don't want to have a data swamp. But some other end user might say, no, I'm just gathering reports only once in a year, so I need to have those data products at least for full year. So basically, it is up to your negotiation with your clients, internal clients, and that's how you should put it into those documents. You should literally define those attributes one by one. So let's talk about a sample implementation, something very simple and very easy. So let's assume that we would like to create a data mesh. As you can see, we can create 3 domains in here: marketing, procurement, and management. And we are putting Kafka as a message broker. So basically, it will be heart of our implementation. And we assume that we are getting data from 3 different locations: users, orders, and purchases. So basically, everything should come in real life, and we should be able to process this data within our domains. So basically, we have source-aligned data products on the upper part, and we should produce some meaningful aggregations within domains. We can publish it back to Kafka for other users as well, or we can just keep it in our domain. And this will be domain developers and domain owners' decision. It won't be decision of the data platform team. Data platform team is only responsible in this example, schema registry and the Kafka part, message broker. So why we need to put a schema registry? If you remember original data mesh architecture, there is no direct refer to any cataloging or any central location. Yet in business world, we need to have some data cataloging, but this data cataloging shouldn't be like something static, should be easy to update, should be, living thing. That's why in this example, schema registry will serve us perfect. Okay, let's go to the demo site. And as you remember, we will be talking about the Confluent. So we decided to go with self-service, the self-service data platform, right? And this self-service data platform should allow us to create our own data products. I have full admin access in this one, so regular developers won't see those details yet. We are here and we can manage whole clusters of environment for our organization. Let's assume that we have several clusters. Those can be connected or may not. It's totally up to us. And I would like to go with the 3rd one. So this is my demo cluster. And as you can see, I am able to see some of those metrics. So it means that we have already achieved one of the, sorry, sometimes it takes time. Yes, thank you so much. If you remember our data mesh architecture slide, we were talking about the monitoring, access management, and cataloging. So when I create the Confluent environment, I already achieved most critical items in this architecture. So the next one is to create something as a domain developer, to create some new data products, right? It is quite important for me. So let's go to connectors and let's try to create a new data set for our needs. So let's see what we have in here. Please bear with me, live demos are always and it always requires doing some live coding. So let's create a new data set. I will create a new connector. Confluent has huge amount of connectors, but I will just go with automated data generator right now. So I would like to add a new topic, stock purchases. Right now I am playing the role of domain developer. Purchases _1. I would like to go with one partition. There is no policy on the partition, so I can define whatever I want, but if it is federated by federal governance team, the minimum partition count might be like 6 or something like that. In my example, I do not have anything. So let's create this topic, and I would like to have global access. It doesn't matter. Let's click continue, and I will be choosing stock trades in here, and I would like to go with JSON schema registry option. So I am just creating a new data source. I can name it, and let's create it. That's it, basically. So I have created a new data source for my domain. So it is up to me to share it with other teams, or I will maybe keep it for my team only. I'm just creating a new aggregated data product, and I would like to keep it internally in my team. So, but also I would like to see what is going on my streams. So I am not admin, I'm just domain developer, and I would like to see all streams, who is doing what. So one topic, 2 applications. In this one, we have a connector producing the data. And let's check the other. Both, 3 of them are same right now. And even better, I am just a business owner. I have no idea about how to code, or I am not a developer. I can just go with stream designer. I can create a new pipeline for me. Let's say that aggregation, something. Create a new pipeline, and I would like to start from the connector, so start building it. I will put a new connector, something, data gen, or we can even go with Postgres CDC source, but in this one I will just go with data generator again. So I'm creating a new data generator without any coding knowledge. Topic underscore. It is really important to put some naming standards when you are creating a data mesh, because it might get messy very fast, and this is the usual problem we see in implementations. So let's say I would like to go with, again, another global access, and I would like to go with, let's say, click scheme data and JSON. So let's go ahead. I am just creating it. Okay, thank you. So basically the names, and then I just click create. I didn't do anything with the coding, but it just created me a connector and a topic, and then I can put it into some sync location, so data. It will ask for extra information. Okay, let's try. Topic, AD, continue, generate API key, continue. Yes, it will ask some. So basically we need to choose other sync. And let's think about, for example, Postgres. Still it will ask credentials. Flat file. Okay, so you got the point. Basically, you can choose huge amount of HTTPC. Maybe.
So
yeah, please.
Yeah, we have covered I guess a few things in here that, as you can see, Safak, that actually the way that he demonstrated this, he showed a lot of things that on the self-service side, so to be able to do a lot of things in there on your own, exploring the data products that you have. You think about it as if it's an APIs. You have the ability to discover them from the names You can use, as you can see, that he's running QSQL to be able to run streaming and figure out stuff around the windwing that he has in there. And also, if you look for the schema and the registry stuff, this is more also on the federated governance. You can have metadata across clusters and so forth.
Exactly. Thank you. As you can see right now, we are running SQL queries on top of those topics, and we can even join those two streams into one and create new aggregated data products. And I do not need to wait in central data team. As long as I know the schema, which I know because we have schema registry here, and in this schema registry, I am able to see whole information, whole metadata information about this topic and this data products. I can come here, read it, and I can create my SQL queries, or I can do some simpler stuff on this stream design. So basically, with this platform, we have covered almost everything from the data platform team. We have covered some roles from the domain developer, and for federated governance, we covered the security policy. And as you can see, we need to have some best practices around it to give a good direction for the domain developers. And that's all.
Thank you very much, Safak. This is awesome. So back to Melinda.
Thank you, guys. Again, brilliant demoing. Didn't want to stop you there. We do have some questions coming in, but I would like to save it for the session we will have. Maybe just a quick question from my side, like what are the main objectives, considerations of an organization to decide if data mesh events streaming is the right thing to go for?
Mark?
Absolutely, it's a very good question. So Safak mentioned there that if you have a small organization with no volume problems or variety of producers or ingestion and consumers, this is not really a concern. However, when you look at this kind of architecture that we have in there, it's a flexible architecture. Flexible architecture is a future-friendly architecture. And we went through a period where we have very harsh economic drivers. We had the pandemic. We have a lot of lessons that we learned in there that if we cannot react quickly to the market forces, to the competition, it's a problem. So the rigid architecture that we had in the past is not going to work for us anymore. We need to look into flexibility on data ingestion, flexibility on data processing on pipelines, flexibility on storage, the way that we create data products. If you don't have this flexibility and agility, then it's going to be a problem. It's not going to be future friendly.
Okay, got it. Anything to add, Safak?
A lot of things about the data mesh topic, but the main consideration is if you have if you are not big organization, but let's say that bigger than a small organization, and you have multiple skill sets within your development teams, it is good idea to have domain-driven design and data mesh implementation.
Okay. Right, I will bring now all the other speakers on stage. I see them coming back. Let me just add them from Upbound. Viktor and Piotr are here. And I see Rolf waiting. Everybody good so far?
Yeah.
What was your favorite session today? Who wants to start? Rolf, maybe?
Yeah, sure. I think it went well, right? Let the audience decide on that, but it was fun to do again.
Okay, and I do see so many questions coming in for you already. Viktor, you're the one who's getting most of them, but I think this might be a question for anyone working with containers. So let me project. What are pros and cons choosing to implement serverless infrastructure? or setup based on resource costs for Kubernetes cluster?
Yeah, so I tend to make first distinction whether somebody wants to use software as a service SaaS or self-manage something, right? If you can use SaaS, you can afford SaaS, go with SaaS, always, right? Don't do it yourself. Now, if you are doing it yourself, if you're self-managing, I cannot imagine a better base platform for serverless than Kubernetes, but when it's self-managed, right? Simply because like the question was about resource cost, right? Kubernetes is, among other things, designed to be effective in that regard, right? It scales up, it scales down. Your serverless applications will go up and down from 0 replicas to something, from something to something else, and your cluster will scale with that. So assuming that you set it up correctly, which is a big assumption because it's not easy, then actually I cannot imagine a more cost-effective way to self-manage serverless than in Kubernetes. I'm going to try to be short so that I don't know, somebody else might have a completely different opinion. Maybe somebody here wants thinks that mainframe is a better option. Who knows?
Piotr, any idea here?
Right. So I want to say I completely agree with Viktor. It was well spoken. I just want to add maybe that you can currently select tooling for Kubernetes. So Knative obviously comes to mind as a serverless runner. There are other options out there, but running Kubernetes yourself, is a challenge. So this is something definitely to keep in mind, because the resource cost that you will have as an actual cost for your infrastructure is one thing, but also there's a hidden cost in manpower, in brain power needed to manage your cluster. So definitely something to think about. So SaaS, absolutely, if you can, go for SaaS.
I'm so happy that you said that, Piotr, because I very often see people comparing and say, hey, running EC2 instances is more expensive than on-prem, because I compare the price of EC2 instance with the price of purchasing a server, completely ignoring the human factor in all that.
Exactly.
And so yes, human cost always included.
Any different ideas here, or should we pass it on to Chaos Studio question, Rolf, for you? How can you create your own custom failure scenario using that tool?
That's an interesting one, because can you? Yes and no, because Azure Chaos Studio has predefined fault capabilities, but if you play around with them a little, you can get, I think, very much close, even spot on onto the scenarios that you want to run, but you're unable to do like fully customized faults with Azure Chaos Studio. So the other platforms that I mentioned, like Chaos Mesh and things like Lit Chaos, which are other chaos engineering tools, give a little bit more capabilities to do that. But I think that there are not really any faults within the library at this moment to not come as close as you want to the what-if scenarios. So the real answer is no, but you can get as close as you want to the scenario that you are trying to emulate.
Okay, thank you for that. Back to Piotr, dedicated for you. Is there support for private cloud provisioning using Cloudplane?
Private, so Crossplane can provision anything that there's a provider for. So if you look at Abound Marketplace and other places like community providers, I believe there are providers for clouds that you can deploy on your private infrastructure as well. So I believe there's VMware, and other providers. So you could use Crossplane definitely to deploy the infrastructure on-prem if you can target the right provider.
Absolutely. I mean, I strongly recommend checking checking the blog post from VMware, right?
Yeah,
among
yeah.
others.
VMware,
they're working a lot.
Yeah, they lately released. There's Equinix, but it's not really on-prem. It's just like bare metal. But there's absolutely possibilities. So if you're interested in a specific provider, check out Marketplace, check out Crossplane Contrib, or make your own. It's relatively easy with the new tooling right now.
Do not ask what open source can do for you.
Ask for what you can do to open source, right?
There we go.
Okay, I don't want Safak and Mark not to answer anything, so here's one for event streaming. When you choose it over gRPC or vice versa, what would you say pros and cons are each of them?
So, Safak, you want me to take the first hit at it? So, I think that I wrote a blog around that, focusing around anything around being able to go through direct APIs versus asynchronous messaging and event streaming in general. Sometimes that we don't compare apple to apple kind of thing. So there's a use of gRPC for sure, and then there's a use for asynchronous, not completely buffering on using something like distributed persistence and so forth. So if you go with, you think of event as APIs, how can we go and do replaying for events or things like that on the buffering side, that using something like gRPC and so forth. So there is a use for queries, and then there is use for commands and events. It is not really either or kind of thing.
Okay, and to follow up maybe for both of you, since event streaming can be done with different technologies, Kafka, RabbitMQ, etc., and data products can have different requirements, here it comes. Can you elaborate on how you provide a self-serve data platform capable to host the plethora of technologies out there on the data landscape?
Yeah, it's a very good question. And we talked about self-service on different fronts, right? So discovery, for instance, being able to discover your events and data products to avoid redundancy, to avoid adding technical debts, having the ability to do quality checks, having the ability to do governance on the data and the metadata. So if you think about it as a platform, really different tools for different purposes. I don't think that we can, for now, combine all of them somehow into just one thing, like an API portal, for instance, or something like that. It's a big and huge space, and we have to go for the distributed model, use the right tools for the right job.
Anything to add, Safak, or?
No.
No. Okay, then I need to hand it over back to Viktor. I don't understand completely the context of this one, but maybe you can help out here. How to make this work for G-Cloud provider?
If it is referring to my presentation, I'm not sure what this is. But if the reference is to my presentation, actually, yeah, there are only few, like the compositions that I used, decided through labels that it should be AWS. If we change the labels, it will run in Google Cloud. The rest of the things I use, like KubeVirt and ingresses and storage, that should work without any changes. But if you ping me, Twitter, LinkedIn, Slack, Carrier Pigeons, anything, I'll give you the links to an example. And just you will have to tell me what this is, because I might be answering something completely random here.
I think you're doing well. And what I had already asked to Piotr previously, do you have any other inputs for the deployment versus Terraform here? Anybody else? Also, Viktor? Feel free.
So, Kubernetes went very far, and in great deal, it partly because of its architecture is designed to do what it's doing, and in big part because the whole industry, essentially almost every software vendor, half of open source projects, everybody's pouring innovation into Kubernetes. So in my head, there is no there is no doubt here, right? It's Kubernetes. We're going to use Kubernetes as a platform to build whatever is needed. And Terraform is, without really saying specifically Terraform, but the older generation of tools are designed with different logic than Kubernetes. Really, they are client-side based tools. I execute something happens, and then that's it, right? There are no control loops, there are no extensions, there are no APIs. So I don't see really. The only negative thing about Kubernetes, on a first look, from my perspective, is the learning curve. You really need to figure out how that works. However, what I will say is that in most cases, Kubernetes is easier than anything else if you really need to accomplish what it gives you, right? So it's hard to learn Kubernetes, so that's a negative thing. But I dare anybody to make fault-tolerant system, for example, in a way easier than with Kubernetes. So it's hard because what it's doing is complicated, right? Not because other solutions are easier.
And of course, I need to ask you the same as I had asked Piotr then as well, regarding if you have a strategy for transitioning from serverless to Kubernetes cluster.
I must start by saying that whether you're running in Kubernetes or somewhere else does not mean that it is or isn't serverless, right? Serverless is something that could run on top of Kubernetes, just as it could run on top of VMs. It could run on top of bare metal servers, right? I think that those are different levels. So kind of saying transitioning from serverless to Kubernetes, I think it's a wrong question, because you can certainly, Piotr mentioned Knative, right? You can use Knative to run serverless workloads in Kubernetes. Serverless is more about, I'm not managing what's below my application. I see it that way. It's not whether it's Kubernetes or this or that, right? Knative is serverless, runs on Kubernetes. Google Cloud Run is based on Knative, but it doesn't run on Kubernetes, and it's equally serverless, right? So I would choose Kubernetes for my serverless workloads if I want self-managed solution.
Okay, here's a new one coming in. How can we handle multiple subdomain-based workspace using engines and Node.js at the backend? Who would want to take this one? It's addressed to no one in particular.
I feel like I'm talking too much, so somebody else, please.
And to follow up, maybe, is there a good idea to go with subdomain-based workplaces for users? Or should it be handled seamlessly?
Come on, blank stares, somebody. Who spoke the least?
That wasn't me for sure.
I mean, don't be shy, Viktor. You're always welcome.
Yeah, I mean, I'm not answering partly because I don't know what that person means by workspace. Okay. But if I ignore the word workspace, then I mean, you can have as many subdomains or domains in Nginx as you want, as long as you can point it to the application, Node.js application, you should be fine. Now, that's not really good if you go directly that, because that would mean, hey, I know that my Node.js is running here, and that's the IP address of Node.js. The moment you upgrade, it fails or anything happens to it, it will stop working. You want to put some service discovery on top of that. Again, that can be Kubernetes, great. It could be Consul from Hashi, for example, or something like that. So I would probably add service discovery in between Nginx and Node.js, so that Nginx is going to the static IP of service discovery, asks where's my Node.js application, it's over there, and forwards requests further. Again, not ignoring workspace. I don't know what that person means by that.
You have to Twitter him or, catch him. Whoever asked that. So one for event streaming again. Any advantage, disadvantage of Confluent over Google PubSub?
Oh, that's a tough one in terms of having the right political answer. Not of the technical aspects.
It's live. They cannot stop you if you swear or say something unpolitically correct. So just go.
Yeah, it's gonna disappear from the screen. You mean suddenly you would know that I came up with the wrong answer, kind of thing. So I think the way I look at it, that you have different categories within the products in the market. We can look at, we call them event streaming native, someone like Confluent, Kafka, of course, and Pulsar and Solus, and then we can have cloud native, the one that you would have on the Google PubSub or Event Hub or Kinesis, and all of those that using different techniques for different use cases. Some of them that would use smart routing, some use pooling, and however, that I would say sometimes people, when they find themselves at using managed services on the cloud in a specific area, and things run within their several limitations in terms of the capacity, the size of messages coming in, the traffic, and the SLA, and they are good with the cost, then they would look into that. Some would look into a full platform, as we talked about, that where they can have schema management, discovery, and metadata, data lineage, like the things that happen with those Confluent right now. They will be able to have event observability for things that are coming in, and you would look for a full platform. Then you would look into that, and this is actually one of the things that we do within the group. We look into the use cases, and we have a certain way to try to match things together, and that really, I guess, that takes a lot of time and effort to make the decisions in there.
And I would like to add one more thing about, that Confluent's main reason why they're working is this event streaming, right? The Kafka and the ecosystem around Kafka. Of course, it has benefits and it has disadvantages, yet this is their main focus.
That's a very good point. There is a huge ecosystem also around the Kafka. Apache projects on the Hadoop side too, on the streaming side. Thanks.
Okay, so I do have an answer about managing or handling workspace. He was referring to the subdomain-based accounts some service provider provides, e.g. Atlassian, Slack. So does it make sense to you now, Viktor? The question about how we can handle multiple subdomain-based workspaces.
Yeah, I mean, without now going and pulling out the Nginx configuration, it's relatively straightforward to forward based on domain, subdomain, path, anything like that, cookies, headers, anywhere, right? And that can be a specific subdomain of any service. I don't have, unfortunately, I don't have a Nginx configuration at hand now to quickly show it, but if you ping me, I can walk you through it.
Yeah, a question could have different angles. It could come from best practice of the manageability of it, in terms of org, could come in terms of performance. It could come in terms of a lot of things. And so I think that it's a fully loaded question or overloaded question kind of thing when it comes to that.
Well, with this, actually, guys, you have answered everything that came in through the panels. Many thanks for that. It would be now up to you if you want to use the time and ask each other maybe some questions that you are interested in. Can I invite you to do so? If not, I mean, I would actually hand it over back to the organizers, but let's have a flashlight maybe from everyone and yeah, what they would like to see on this program next time. I'll have to ask Rolf this time to start because you had so little questions to answer.
Yeah, I understand. I'm the expert in breaking things, right? So nobody wants my questions being answered. What I would like to see in the next episode. Wow. Well, I do think it will be very interesting to see how things like multi-cluster management will evolve in terms of multi-cluster management scaled over different clouds or different hyperscalers. I'm very fun to see how that will work in the future.
I think that's a trick question for me or Piotr, because that's precisely what we are.
I know, that's why I'm asking it, right? I believe you will answer it next year, right?
Yeah, I mean, the short answer is, without going into specific projects and products, I think that we will see different versions of Kubernetes that are not really designed specifically to run containers or focus on that, but more to act as that management layer. A project that I would follow kind of, and because I think it shows glimpses into the future, would be KCP, because KCP really brings those ideas to reality, or getting closer to reality, right? It's a Kubernetes cluster that really cannot even run containers, at least not out of the box. It's designed specifically to be that entry point, that tunnel into everything else. And that everything else can be other Kubernetes clusters or not even Kubernetes clusters, but precisely a way to manage multiple types of resources or groups of resources, right? I'm trying to avoid saying clusters because it doesn't have to be only clusters. But if there is one thing I would recommend anybody to note and watch closely, that's KCP. I think it was showcased for the first time in Valencia in last KubeCon.
So without synchronizing behind the scenes, not touching keyboard, Viktor stole my idea. I wanted to highlight KCP as well. It is absolutely fantastic project. But I think what will happen, just to add my 2 cents, as always, when the technology matures and becomes kind of more boring, as people like to say, there comes a new wave of abstractions. So now we are starting to ask questions of how do we generate stuff more programmatically? How do we make things even easier? How do we streamline? So I'm kind of expecting more focus on tools that are dedicated to doing just that. So in space of Kubernetes, specifically cloud native, my prediction would be that those tools will start popping up, and this automation will be even more important in future.
Thank you. I will make sure to follow the KCP project. Thank you, Viktor, Piotr.
Maybe now Mark can have a wish for the next topic.
Yeah, I actually, along the lines of my colleagues that mentioned here, that we all think about collaboration, but also think about what's the next big thing. So I guess somehow that in the last couple of years that we made a lot of progress in so many areas, also on the Kubernetes side and the ecosystem and event streaming, as you can see, APIs and so forth. But I feel that we came to a little bit of impasse in terms of creativity. What would be the next big thing that would help with to move things faster so forth. That keeps actually running into my mind, and I think about it a lot.
I think that the next big thing is for Kubernetes to disappear.
The abstraction,
no, honestly,
as
disappear just as hypervisors disappeared from 99.9% of people, right, Carol? How many people here, or people listening, or panel, uses works with hypervisors directly? Nobody. I mean, nobody. Somebody, right?
It's the next abstraction layer, as you know.
Yeah, that was the idea from the start, right? I don't think that people who design Kubernetes and core contributors ever thought that Kubernetes is the thing to be used. It's just that it was so awesome that people started using it immediately. But it's definitely going down the lane of disappearing. And once that happens, because right now most of the industry is focused on precisely that, building those components on top of it that will ultimately make it disappear. And once that happens, I think that then we will see a next wave of innovation that is probably completely unrelated to Kubernetes. But for now, almost everybody is focused on that next phase, right? Okay, so we have a base. What do we do with that base?
Yeah.
After that comes not the disappearance of Kubernetes, but replacement. But that's later down the line, yeah.
Open distributed platforms. Kind of.
Something. Everything dies sooner or later.
Yeah, and actually the challenge is that it's typically that you go and see that somehow contention between innovation and the business model. Definitely you have big businesses making a lot of money in business plans on the innovation that we have in here. Sometimes they go in the same direction, sometimes they don't go in the same direction, and things like this. And that is very normal.
And what does Safak think about next topic, techie expertise that we might need?
It is a very big question because, from my point of view, the next big thing will be no-code, low-code environments. Because right now we are getting, more aligned with business, and business, usually they do not have enough skills to create something from scratch. That's why these no-code, low-code solutions will be, quite important. Maybe next couple of years.
Hey, I used no-code, low-code 30 years ago with Dreamweaver.
Yeah.
Nobody probably remembers that, right? That was no-code, low-code.
I remember.
Visual Basic.
I created my first web page without knowing what is HTML.
Yeah.
Yeah.
We all were there, So
yeah, it's one area that where you go too much into it and it loses value, and then you have to come back again.
No, I think that my perspective, I'm low-code, no-code, and I'm saying that without reading deep into that subject, so I might be saying something silly. But what makes current attempt in no-code, low-code very different from before is that they're not really focused on the solutions I've seen are not that focused on coders, people with experience writing code and stuff like that, but more that I feel, and somebody correct me please, that no-code is now more focused, okay, but how about non-developers, non-programmers? Can actually we have HR department that creates the application for their needs without actually bringing in a team of developers and having a project of a year and stuff like that, right? And to me, that's the exciting part of no-code, low-code. How can it enable people who did not spend years mastering software development to do applications for the things that they need? Because almost all applications are based on the same principles, and that's there is some input. You do something with that data, and then you output it. 99.9 applications are like that. We all think that we're doing something amazingly great, never seen before, but that's the essence. There is input, some data comes in, you do something with it, format it or calculate something, and then you spit it out.
Viktor, there's two big approaches in the data world, right? ELT or ETL, either extract transform node or extract load transform. So basically, this is it at the end of the day.
Exactly.
Yeah,
exactly.
And I think we are in the career track. We are scaring the developers on the career track.
But this is actually interesting. So those applications that you describe, I refer to them as blobas, which is boring line of business applications, right? Something in, something out. It's kind of like an Excel. You can do most of this in Excel, and I would agree that low code would shine there. But low code, no code focuses on generating code, but the skills that you need to have as a software developer are also beyond that. So how do you design? How do you decipher requirements? How do you actually kind of like bind the business requirements to the actual technical outcome? And as long as this is not blobas, but some more more advanced or more ambitious application, so there's still this design phase that is necessary, that currently low-code, no-code tools fall short. Maybe in future, if you combine them with AI, who knows? This can be a game changer, right?
But I see it in a bit maybe more simplistic way than you, Piotr. I see it as modern versions of Excel, right? Kind of. And my girlfriend, she used in a way low-code, no-code with App Dynamics when she had to add some fields and do some stuff, right? There is a huge segment of world population that can actually benefit from creating something what you might or I might consider, hey, this is too simple, kind of like, why would I bother with this, right? So I like it. I just don't give it to me. Kind of, don't make me use low-code, no-code. We're good.
We shouldn't resign yet because we also have to consider integration between those blobas, right?
Right, exactly. You have to consider integration, you have to consider maintenance, long-term maintenance, right? Pipelines, whatnot, stuff that goes in between. Yeah.
Guys, this integration part, is the nightmare part, but that's why we are here, right?
I can see all of you are having great ideas for your next talks. So I think we don't need to wrap it up at this point in time. Thank you so much again for sharing your wisdom. And I look forward to seeing you online a lot more. Thank you.
Thank you very
for
much.
having us.
Thank you, everyone.
So much.
Bye.
Bye.
All right. I hope everyone is enjoying the conference and everyone's having a good time. And we wanted to say thank you once again to CodeSync for joining us as partners and sponsors, and also for sending amazing speakers. Thank you, Emil. Thank you, Adam, for joining us, and thank you for the presentations. And if you want to actually move towards the more healthy code base, definitely check out CodeSync Software Engineering Intelligence tool, and it will actually help you to and will guide you towards a healthier code base where you can spend more time innovating and basically working on the ideas in the project, and meanwhile reducing the stress and the business risks in the dev process. Right now they are running a free trial. You can check out their tool via the link in the chat, register for it, and also you will need it to attend the workshop. So basically, give it a try, set it up, and we will see you on the 17th of November for the workshop. And I nearly forgot about the iPhone giveaway. To partake in this raffle, you simply need to fill in the form that you will see right now in the chat. So just type in your email, and we will have a giveaway at the end of the third block today. The form is in the chat. Good luck.
I'm Adam Thornhill, a software architect with degrees in engineering and psychology, and I'd like to welcome you to an exclusive workshop on November 17. In this workshop, I'm going to show you how you can pick up a codebase of any size and scale, and within minutes, identify all the technical depth in that codebase. As if that wasn't enough, I'm also going to show you how you can prioritize that technical depth in a way that makes sense to both the business and the engineering side. And of course, we're going to look into opportunities to visualize codebases too. Too good to be true? On November 17, we make it a reality. Hope to see you there.
Hey everyone, welcome back to the second to last block of today's conference. I'm Vaclav Pavlin and I'll be moderator for this blog. So let me add Petros to the stream, who is our first speaker for the blog. Petros is an author, a masterclass instructor, a passionate software craftsman. That's what I read on his website. And his talk will introduce us to the topic of modularization of mobile applications, similarly to how we would break down our monolithic backends into microservices, and I can't wait to hear it. So take the stage, Petros, and good luck with your talk.
Thank you very much for the introduction. So let me share my screen. All right, so I'm assuming you can see my screen. I'm going to start with the presentation. Okay, so welcome everyone for today's speech about the mobile microservices architecture. What we're going to do is that first I'm going to give you a brief overview about generally the microservice architecture, so we make sure that we are on the same page on what we're talking about. And after this brief introduction, I'm going to show you how we can port this architectural paradigm the same way as we use it in a backend system. We can actually use it in mobile development. But before we start with the actual speech, let me introduce myself. So I am Petros Efthymiou. I'm from Greece. I'm a mobile engineer, instructor, and author with about 10 years of experience. Started with the Android platform, which is my favorite, but I've also been developing with iOS, Flutter, and did some backend as well. I've worked into some Udemy courses, and I've also recently published a book. But enough about me. Let's get on to our topic, and let's align a little bit on why should the software system use microservices, and where can they help us? So a little bit before the start of our millennial, around the 90s, the software system started getting increasingly complex. So while a system could priorly be developed by one team of a few developers, by the increased complexity, it now required several teams of several developers in order to be developed. Now, as probably most of the people watching this talk know, when you have several teams working on a single code base, it's very often that you will get what we call a spaghetti system. The industry very fast understood the need to start modularizing those extensive monoliths and start building several independent systems that can be developed much easier than a huge code base. So the term microservice itself came from Dr. Peter Rogers in 2005, if I'm not mistaken. And by 2011, it was already a very popular architectural pattern that many companies like Netflix and Amazon were already using in order to break this monolithic system into several smaller subsystems. So pretty much when we talk about microservices, we are talking about independent subsystems that are communicating with each other via public API. But of course, not every system that has been broken down into subsystem is actually following a microservices architecture. There are three key elements that we must adhere to if we are really developing a system with the microservices architecture. Those three key elements is that, first of all, each of those microservices should be independent to develop. In other words, if we want to add one feature in one microservice, we shouldn't have to change the code of another microservice. This is very important because this is what enables multiple teams to work independently. The second key element that we must adhere to if we want to follow this architecture is that each microservice should be independent to maintain. In other words, if we have a bug in a feature that resides in one microservice, we should be able to fix it without altering the code of another microservice. And finally, we should be able to deploy each of those subsystems or each of those microservices independently. So yeah, if we just segregate the code base into modules without adhering to those three key principles, we aren't really following the microservices architecture. All right, so let's take a few minutes to discuss what are the benefits of following a microservices architecture. First and most importantly, by following this architecture, we can enable independent autonomous teams to work in parallel. And why this is happening? First of all, because we are avoiding to have several teams to work in the same code base, which is causing cross-team merge conflicts. You can imagine that if everybody is touching the same classes or the same functions at the time of the release, when we need to merge those branches, we would have to align every single team to sit together and fix those conflicts, which is not often a very easy thing to do. If each team is only writing code in specific systems, then they can resolve those merge conflicts without having to talk with different teams. And of course, each team is also free to choose the technology stack that best serves the problem that they are trying to solve. For example, one team might need to have a very performant microservices, so they might opt in for a language like Go, for example, while another team doesn't solve problems that need to be so performant, so they can choose other languages like Java, for example, which is very easy to develop with. In the mobile world specifically, we recently lived through the transition of Java to Kotlin and Swift to Objective-C to Swift. So this as well could leverage the microservice architecture. So a team could decide that they want to move to Kotlin faster than the rest of the teams. All right, besides enabling autonomous teams, we can also effectively contain cancer in the extensive application. And by cancer, I mean legacy part of the systems that are poorly architected. So if we were unable to contain those legacy systems, we will have all the new features tightly coupled to the legacy code, which will eventually cripple the productivity of the new feature and of the future of the system. While on the other hand, we can effectively isolate legacy parts of the system into specific microservices, which we can choose to actually deal with later. And while those problems are not dealt with, the new code which is developed on different systems is not heavily affected, as it's only interacted with the legacy parts via public API and not by tightly coupling the dependencies, which is pretty important. And the last thing that I want to state as a benefit of this architecture is that it can enable experimenting. So if we want to try another third-party library to do networking or to do dependency injection or a different language, we can do it in an isolated lab in a specific microservice without risking the viability of the whole system. If this experiment proves out to be successful, we can then port it in the rest of the system. If not, then it's just in one microservice, which we can even refactor later. All right, so those are the three key benefits we can take from this architecture. If it's one thing that you can keep from this talk so far is that we have this picture normally in the company where, for example, the blue team is responsible for those two microservices, the yellow team for this one, and the green team for this. And those two teams don't actually have to touch the same code bases. They only need to align in those lines which represent the public APIs and the way those features communicate. All right, so now we will move on to a very important concept, which is modularity, because essentially this is what creates a microservice architecture. And by modularity, I mean splitting an extensive application into smaller ones by adding meaningful boundaries. And we are going to stick in this talk a lot in the word meaningful, because there are a lot of ways to add the boundaries in a software system that does not provide any benefit. But we will get to the specifics of this later on when we see the specific examples of applications. All right, but before we move to the examples, we need to first understand what is a boundary. A lot of people are actually talking about boundaries without having it clear in their heads what a boundary is. A boundary is essentially anything that can separate code. And we cross the boundary when code in one side of the boundary is calling code on the other side of the boundary and is passing some data. A boundary can be soft or hard, depending on how easy it is to cross it. So the very first example I can give of a boundary is just segregating the code into functions. As you can see, the code that resides here cannot directly interact with the code that resides here. This is a boundary. Of course, it is a very short boundary because this function is free to call the other function and pass some data. So this is a boundary crossing. And as those two functions reside under the same class, even if they're private, they can call each other directly. That's why it's a very soft boundary, and sometimes it's not even regarded as a boundary at all because of how easy it is to cross it. The second softest type of boundary is segregating the code into classes. Again, we have two files. One side of the code cannot call the other side directly, but still one class can have the other one as a dependency. And this allows this class to cross the boundary by call a function of the other class. Now, of course, each class is free to declare any of its functions as private. Therefore, this boundary is a little bit harder because if I declare something as private, then I effectively protect it against any other external class. The second type of boundary is to add an interface between those two classes. This makes the boundary much harder because now the classes are not allowed to change as they want because they need to comply with the interface that they are extending. So this is considered a pretty tough boundary, but we can still bypass it. Let's consider this example. We have a client class which actually needs to use some functions that reside in a service. And what we decide to do is we don't have the client depending directly on the service, but we instead draw an interface in between. So the client is depending on the interface and the service is extending this interface, and therefore they can interact between each other. But if all this code, which means those two classes and this interface, they all live under the same software module, still nothing actually prevents this class to get directly an instance of this service and use it, which is an illegal boundary crossing, and it's something that can happen if we don't segregate those two classes into different modules. And this is what I would say the strongest type of boundary is to draw modules, hard modules, between the systems that we want to segregate. So for example, in an Android application, we would have an application module, data module, framework, etc. And if we wanted, for example, in the data module to use classes from the application module, we would have to explicitly state this into the data build Gradle. If we didn't explicitly state that this module is dependent on this, then we wouldn't be able to do that. All right, so what I want you to keep from this part of the talk is that modularization means adding boundaries in the code, and those boundaries can have different strength. They can be very soft or very hard. And the reason that I have added this section in the talk is that essentially the microservices architecture separates the subsystems with hard boundaries. That's what it is you place meaningful hard boundaries in the code base in a cohesive way. And of course, within each of those microservices, you are free to add the software boundaries like interfaces, classes, functions, etc., etc. But the outer walls here must be hard boundaries. And that's what makes an architecture following the microservice architecture. And of course, the three key elements that we discussed earlier. All right, so now that we have the baseline and we are aligned on why we want to use microservices and how we can approach this architectural paradigm, let's see how we can move it with specific examples into mobile applications and mobile development. Okay, so I want to discuss how we add meaningful boundaries. In my opinion, there are four ways actually, but one is, I will explain. There are four ways that you can add those boundaries in place. The first way is to actually choose not to add any hard boundaries in the code base. So for example, in an application that is developed by a startup, you can say, okay, I don't want to just yet add the modules in my code base. I will segregate the code into classes, interfaces, and packages. And I will develop everything in a single module in a monolith. We will discuss later why this is a good way always to start. But as the application is growing in complexity, you have to make two choices: to add hard boundaries between the layers, or to add hard boundaries between the features. If you decide to add hard boundaries between both the layers and the features, then essentially you create a grid where each of those small pieces of small subsystems actually is a microservice. Let's discuss those three examples in more detail. So I will start with the layer axis and with the layer-based modules. Here is a simple example of a clean architecture. We have decided we have baked this layer cake, let's say. So in the center, we have the domain and the application layers. The domain contains the entities of the application. In here, we have the use cases. It's my personal preference always not to draw a hard boundary between the use cases and the entities. But if you want, you can also make this wall harder. So a bold wall over here represents a hard boundary, while a not bold wall represents a soft boundary. Okay, so in the center, we have the application layer with the business logic and the use cases. Right after, we have the presentation and the data layers. Of course, the dependency rule apply, which means that every outer circle is allowed to depend on any circle that is inner to it. Here I have added the presentation and the data layers in the same level, not because they are allowed to depend on each other. As you can see, there is a hard wall that is separating them, but because one cannot live inner to the other. So those two must be completely agnostic of each other, and they must only have a dependency on the business layer. And on the other side, on the outer circle, we have the framework layer. which contains all the code that is framework specific, like the actual database, the actual screens, etc. Okay, so this is how layer-based modules would look in an Android application. We would have one module per layer, one module from application, data, framework, and presentation layers. The benefits of this approach is that we effectively protect against architectural violations because we explicitly need to state that the data module depends on the application modules in the build Gradle of this module. But on the downsides, in an extensive application with a lot of features, those modules will effectively become code buckets because as we add more and more features to the app, more and more code will be inserted in each of those modules, and we don't have a way to actually increase the number of modules to reduce the number of code in each module. So overall, I wouldn't recommend this approach. The next approach is to actually draw feature modules. So instead of looking at the technical aspect of the application, if a class belongs in the data layer or in the presentation layer, we can look on the business side and say we will add all the code that is regarding the authors in the authors module, then in the chat module, etc. And this approach has the advantage that is what also Uncle Bob refers to as a screaming architecture, because the packaging is the facade of an application, is the first thing that the developer sees when they join a project. And if they see something like this, they will probably think that we are talking about a books application. If they see something regarding to healthcare, they will probably think that we're talking about the healthcare app, a banking app, etc. So this type of packaging actually expresses what the system is doing, unlike the other type of packaging, which is more technical. And the other advantage of this approach is that as the application grows in size and in complexity, we are free to draw more modules between the features. And this way we can keep each module relatively small. So it's easier to scale by using feature modules rather than layer modules. And finally, we have the microservices, which actually draws hard boundaries in both dimensions. So we have hard boundaries between the layers and between the features. I have prepared actually two sample projects, one for Android and one for iOS. I'm going to display the one on Android, even though the architecture is similar, that demonstrates this approach in a mobile app. Let me pull up the Android Studio. So on the business side, this application is pretty straightforward. I will bring the emulator on the front. It doesn't do much. It just displays a list of articles. Each article has an icon, a title, a subtitle, and an author. And if it also has a number of stars or the number of likes. And if we click over here, then we are also liking the article ourselves. So the likes went from 10 to 11. And we also cannot like it again because the system understands that we just did. Okay, so we are talking about a very small application of a single feature. Let's see how it's architected with the mobile microservices architecture. All right, I will close the emulator. So the first thing that you can notice is that we have a single feature module over here, which is the home. If we had more features like chatting or like, I don't know, settings, profile, we would have more of those feature modules over here. So when we open this module, we can actually see that it contains several other modules. Each module is targeted over a specific layer. So the home feature is also segregated into application, data, presentation, and over here we have the framework-related code. And if, for example, we move to the build Gradle of the data module, we can see that specifically we are stating that the data module has as a dependency the application module, which, as we discussed, contains the business logic and the domain entities. The same is happening for the presentation layer. It is only depending on the application, and it's not by any means allowed to depend on any classes that live in the data layer or in the framework layer. Okay, I won't spend too much time like going through every class. You are free to go to the repo itself and study it if you are interested to do so. I will just show you that in the application layer, as I explained, I prefer to segregate the domain entities and the use cases with soft boundaries because I feel those two things live very close to each other. I feel it's an overkill to put the domain and the use cases in a separate module, but you are free to do it if you want to. In the use cases, of course, we have the use case to get the articles and see the articles in our screen. And we also have the use case to like an article. And here we have all the business logic to perform those actions. Our entities contain the article. I won't spend too much time doing it. I just want to mention a couple of key points. The data layer is pretty important to state that it doesn't contain anything framework specific. It doesn't contain the actual database because the database is a technical detail. What the data layer contains is all the interfaces and all the data sources in order to retrieve, in order for the application layer to retrieve the data from. So it has the interfaces for the local data sources, for the remote data sources that come from a backend, for example. And it also has the logic to combine the local sources with the remote sources over here. But as you can see, it doesn't contain database. It doesn't contain the actual service layer, which performs the HTTP calls. Those are platform specific, and the data layer is higher level. It shouldn't know anything about the platform that it's operating in. So this is very important. As you can see, those three layers are not Android layers. They are Kotlin modules. You can just copy them and paste them in the backend system, and they will work exactly as they work in an Android application because they are completely agnostic that they work in the Android platform. The only layer that is aware of the Android platform is the framework layer, which lives under here, which contains the fragment. The fragment is the class that displays the UI. It contains the actual database or some file access, and it contains the actual service that is performing the HTTP call to retrieve the data. So we have three completely Android agnostic modules that can be ported to a backend system exactly as they are, and just one module that is aware of the Android platform. Okay, so yeah, I won't spend more time because the time is short, but you can study those two repos in the following links. Okay, one last thing that I want to talk about is independent deployability. Can this actually happen in a mobile application? And the answer is a little bit trickier. And to answer it, we have to separate between the testing phases and the actual production phase. In the testing phase, we are producing a single executable and we are installing it in the device that we have as developers. The build systems are smart enough to identify that some modules have not changed, so it will only build the modules that have changed and then install it to our phones. This means that the microservices architecture will significantly reduce the build time to test our application. But when we deploy to production, the way that the mobile platforms work is that you have to upload to either Google Play or the App Store a single executable. So we cannot actually deploy just parts of the application. We need to deploy to production the whole thing. In production, we cannot achieve independent deployability, we can only achieve it in the testing phases. But what we can achieve is independent downloadability. We have those two things. In the iOS, it's the app clips, and in the Android is the play feature delivery, which essentially allows an application to be downloaded initially, not as a whole, but just parts of it. And then when the user needs the extra features, they can download it later on. And if we have a built application with this architecture, we can very easily take advantage of independent downloadability for our users. Okay, any drawbacks about the microservice architecture? Of course, the first drawback is that the boundaries cost. It takes time to create classes, interfaces, and apply data transformation from one side of the boundary to the other. And of course, it makes the code base inflexible. Now, this is both a good and a bad thing, because in a mature app, you want the code base to be a little bit inflexible because you have a lot of people working in it, and you don't want one developer to actually change the whole architecture by mistake because he doesn't follow the patterns properly. But on the other hand, on a startup, you need the flexibility. The product will probably pivot a lot of times until it becomes successful. And you don't want to have a lot of hard boundaries which constrain you to perform radical refactorings. So I would suggest maybe not to use it in a small application, in a startup, and it's best fit for an enterprise app with several independent teams working on it. Okay, so to sum everything up, the mobile microservice architecture take the concept of modularity to the extreme. In the mobile app, it makes it inflexible, which is a good thing in an enterprise app, and a bad thing maybe a bad thing in a startup application. It offers the advantages of independent developability, maintainability, testability, and downloadability. But we can't yet support in the mobile platforms independent deployability to production. If Google and Apple later on allows such a thing to happen, this architecture will already be ready to take advantage of it. All right, yeah, and as we discussed, better suited for a large corporation rather than a startup. Okay, so if you are interested in learning more about it, you can take a look at my book. It's called Clean Mobile Architecture. It contains pretty much all the information that you need to have to architect a mobile app. Or if you are more a fan of freebies, you can decide to follow me on the website where I'm maintaining a technical blog, Twitter, or LinkedIn. Thank you for attending to this speech. I think I took just 2 minutes more than I was planning to. But yeah, now I can open up for any Q&A and any questions that you might have.
Okay, thank you very much, Petros. That was a great presentation. The Q&A is scheduled at the end of the blog, so I'm not going to ask you any questions now.
Okay.
And let's leave it for that. If people have more questions, they can post them, and we will go through them after that. So I guess we can jump right into. Thanks again a lot. I think we can jump into the next speaker, which is Artsiom. Welcome.
Yeah. Yeah, thank you so much. Hi.
Artsiom is big data platforms architect and open source enthusiast. He will take us on a journey of how to build a lake house, which should be a big data platform and a collection of best data lake and data warehouse technologies to solve your big data needs. At least that's what I understood from his description of the presentation. And I can't wait for that because I've been in that space myself before. So Artsiom, please share your screen. Don't forget to switch to full screen for your presentation, and we are really looking forward to this.
So can you see my share screen?
Yep.
Cool. So hi everyone. Thank you for coming. Thank you for your time. And first of all, my name is Artsiom. And in this topic, we are going to talk about how to build the modern data platform using AWS. So you will be able to find here information about the AWS services that can be useful for you, about Lakehouse implementation, and some interesting architecture diagrams and charts. So before we start, I would like to say some words about me and my company. So for the last 7 years, I have been working with big data. I have absolutely different experience in this area. Now I work for Slate as architecture of the data platform. Also, I like to take part in the open source projects as Apache Spark, Spring Boot, etc. So if you have any questions, you can contact me on LinkedIn, Telegram, or Gmail, and else I will really appreciate you for the feedback after the speech. So yeah. About the company, we are the company who starts from PDF editing and your signature workflow to automating document workflow of any complexity. So we have several products under our umbrella, PDF Fillers, I know, and AirSlate US Legal. Here's a list of the most popular products which we have. Therefore, our data platform should be cross-product projects, and no, it's really important to understand for this medium. So as a company, we wanted to achieve some goals. There are a list of goals which we want to achieve. For example, increase the speed and quality of insights. We want to get more insight with high quality to make our decision better. So we have several products under the hoods, and the data platform should be able to handle cross-product analytics. The analytics for everyone, that means not only data science or data analytics team should build analytics. Some cases can be handled by product team, business analytics, product owners, and etc. So generally, the data science team and data analytics teams play a role as an answer on our questions when something wrong with data, or we found any kind of anomaly in our data, and we want to make them proactive. And the idea here is our data science team and data analytics team should warn or alert the product teams before something happened with our data. And the last goal is a data-driven decision making. I hope that it's clear for everybody. We want to make our decision not only on intuition. We want to prove from our data that our decision will be successful. So we have assumption that the data platform is the key to achieve these goals. The data platform is complete solution for gathering, processing, analyzing, and presenting data. It's like one system which has everything out of the box to make data decision. Since we have a good experience with AWS, and we decided to see what AWS can offer for us, and now AWS is one of the most popular cloud platform, and I'm sure that most of us has experience with it. And what do we try to do? We try to build the data platform on AWS. The data platform requires a lot of services. From my point of view, you have everything on AWS to build the data platform. Of course, if you add a little bit open source to your data platform. Before we deep dive into the data platform on AWS, let's discuss the history with different architecture concepts. The data warehouse, for example, the data warehouse concept has a long history. This concept is still existing in our life, but now in most cases, it's based on an MPP system. While data warehouse was a great for structured data, but many modern data platforms had to deal with unstructured data, semi-structured data, and data with high variety, velocity, and volume. Data warehouse are unsuitable for most cases due to lack of the cost and performance efficiency. So another concept is data lake concept. Generally, companies have a lot of data sources. These data sources have different variety of formats. Moreover, we didn't know which data will be the most valuable. So we started collecting all the raw data in our data lake. What do we have? A lot of variety of data, a lot of data sources, and a lot of volume of data. In this deal, data lake will help us. But data lake has lack of some critical features. For example, transaction, isolation, and consistency is not up to the mark. Any data lake can turn into data swap. And schema enforcement also is not a simple part of data lake. For this reason, many of the promises of data lakes have not realized our expectations. So anyway, data warehouse and data lake are a good concept to build the data platform based on it. But now, in big data world, you can find some modern concept which collect advantages from warehouse and lake. It's lakehouse. So lakehouse is modern concept of architecture that help us to combine products of data lake and data warehouse. From my point of view, we should implement the several things to be successful in the lakehouse building. But in the internet, you can find such things as advantages of lakehouse. Since we decided to build lakehouse from the scratch, we use this list as a requirements to our lakehouse. What we have here, transaction support. In enterprise, lakehouse has many data pipelines, and these data pipelines will open, read, and write data concurrently. You should be ready for it. Schema enforcement and governance. The lakehouse should have a way to support schema enforcement and evolution. Read directly from the source. So, lakehouse should be able to read data directly from your source using BI tool or using SQL engine tool. Separate compute and storage. In practice, this means storage and compute use separate clusters. This system are able to scale to many more concurrent users or large data sizes. So openness format. The storage format should be supported by most tools and have metadata management. The next one, support unstructured and structured data. The lakehouse can be used to store any kind of data format. Support for diverse workload. We have a lot of teams in our company. There are data science, machine learning, product teams, etc. So they have the different behavior of querying data, and all the variety of behavior should be supported by your lakehouse. And the last one is support streaming. You should be able to stream data to your lakehouse. So, on the market, there are some solutions of lakehouse which support it out of the box. So here you can see some services which can offer the lakehouse implementation out of the box. These services make sense and can simplify our difficult data engineering life. But you should understand that you should be ready to pay for simplicity. If we have experience in the building data platform and experience in the AWS, I think that we can do it by ourselves without any external services or any external solutions. So let's deep dive into how to build data platform on AWS. I propose to set up the following main component to build the data platform. There are a list of minimum components that you should have from my point of view. Let's see what we have here. Data acquisition is responsible for data gathering and collection from different sources. Data lake is responsible for storing and keeping data. Data catalog helps us with search or discover and metadata management. Data pipeline is a brain of our data platform. It helps us to build any analytics pipeline or automation tool to increase the stability of the data platform. And last one, data presentation. Data presentation is responsible for query our data using SQL engine or integration with BI tool. So each component can have own life cycle, and moreover, it can be developed by different teams. So, and we are going to build each of these components. Fortunately, AWS offers us all necessary services. Let's deep dive through each one. Let's start from Data Lake. Data Lake is the center of the data platform, and all data should be stored here. Now, from my opinion, it's good practice to divide our data lake on logical zones. So we have landing zones. This zone is for third-party data that doesn't belong to us. Row zone, this zone is responsible for duplicating data of our production system. Curated zone, so here you can find a clean data with high quality, or it can be any common intermediate analytics result, which can be used by different teams or something else. Marked zone is final analytics result that are ready to be shown for the business. So, and last one, sandbox zone. So this zone is used for experimentation, testing. No, it's for data that are not ready to be sent in production. So when we have a vision about how to divide our data lake, we should think about technical solution. I recommend to use AWS S3 plus Delta Lake. I'm sure that you are aware about S3, it's object store, which can help us to stop thinking about the space, but start thinking about the cost. So Delta Lake is an open source storage framework which enables building lakehouse architecture. Most of all points which we discussed before about lakehouse concept are achieved using Delta Lake. And unfortunately, this topic is not about Delta Lake, but I recommend you to pay attention on this technology. So we faced some pitfalls during Data Lake building. When you work with Delta Lake, you should understand that it has Apache Perkey under the hood, this immutable data format, and the number of duplicated and small files will be constantly increasing in each mesh during the streaming data to Delta Lake. Therefore, you should find a way how to conduct compaction and vacuum periodically. For example, we have compaction 2 times per day and vacuum executes each 3 hours. So, okay, now we have discussed Data Lake, and now we should think about how we can enrich the data. So data acquisition can handle such things. For implementation, we choose the following stack of technology. There are Debezium, Kafka Connect, which is deployed on EKS, AWS MSK, it's Apache Kafka on AWS, AWS UMR plus Apache Spark. So let's see the data flow in data acquisition. Debezium is connector that can read bin logs, well, or something else from your databases. We have deployed this connector on Kafka Connect and start to uploaded this data from tables and send this data to MSK. So after the data is in MSK, we can connect to MSK using Apache Spark with EMR cluster. We use Apache Spark structured streaming to stream the data from MSK to Delta Lake on S3. We have implemented a chain data capture solution inside of our Apache Spark. As you can see, the data acquisition also communicates with the data catalog. Data acquisition use data catalog to get schema of events and parse events using the schema. So when we have decided to build data acquisition in such way, we have faced the following pitfalls. Generally, the data volume which should be collected by data acquisition will be increasing. You will get requests from your colleagues for instance, data science team or data analytics teams will ask you to add new tables to the data platform. And my recommendation is automate this process. The Apache Airflow will help you, but we'll discuss it later. So for instance, we have automated the process of adding new tables, which should be gathering by data acquisition. It allows our colleague add new tables by themselves. There are some reasons why we did this automation. Data engineers should have time to develop the data platform and implement new features, so not to support colleagues with adding new tables all the time. And moreover, we have more than 2,000 tables. But for the analytics, generally we use 30–40% of these tables. As we don't know exactly which tables we should have, we allow our colleague to do it by themselves. They add only tables which they use for the building analytics. So since colleagues start to add more and more tables, the system should be ready for the scaling. You should have a plan how you're going to scale the system. In this architecture, all services can be easily scaling. So as you can see, that your system should be scaled, but you need to understand which exactly part of data acquisition should be scaled. It can be Kafka Connect cluster, Remark cluster, Kafka, or something else. Therefore, you should have a good monitoring and not to forget about your data log. In the data log, you need to understand how much time takes each step of your data acquisition. And in our data platform, we have near 30 minutes data lag. And this data lag looks good for our system, but it depends on your requirements. So also the current solution can lead to have a lot of connectors on the Kafka Connect cluster. And because we choose the way where we deployed connector per table. So therefore it may take time for supporting all these connectors. So we can collect our data using data acquisition. We can store and keep our data using data lake. Now we should start to work with this data. And data presentation is really good for it. Data presentation is component that is responsible for querying and displaying data. That's why we should have two services minimum. The first one should be a SQL engine, and the second one is BI tool. As SQL engine, we have chosen Redshift and exactly Redshift Spectrum. Redshift Spectrum is an MPP system, and we can read data directly from AWS S3. Moreover, Redshift has a native integration with Delta Lake. Our idea here is separate computation cluster and storage cluster. So for storage cluster, we use S3, and for computation, Redshift Spectrum. In case if you want to scale your computation cluster, it's not a problem because you don't store any data inside of Redshift. Also, you can create a several cluster where each cluster will be used by different teams. As example, the size of each cluster can be chosen by your needs. But you need to understand that the payment for the Redshift Spectrum depends on the data scan. So we choose the Delta Lake, as I mentioned before, which is based on Apache Perky. And Apache Perky is column-oriented format, and Redshift Spectrum is good to work with such data format. But it doesn't mean you can choose another one. You can use CSV, JSON, etc. Just be careful because some formats can lead to cost increase. So, and another service, SBI tool, we use QuickSight. This simple BI tool, it has deep integration with Redshift and allow you to work with Redshift with Spicy or direct queries. Spicy is simple cache for QuickSight to decrease the loading on data sources and speed up your dashboard. Of course, Spicy is not free and you need to pay for it, but you can choose between direct queries to Redshift and the size of cache. On the one hand, you will pay for the size, on the other hand, you will pay for computation. So I think it's a good chance for you to find the balance. So, and what's about the pitfalls? Spicy is not free. You should pay attention to find balance between the size of Spicy and the number of direct queries to Redshift. In case of Redshift Spectrum, you will pay for the scan. The scan of 1 terabyte of data is cost $5. Regarding the quick site, we face some inconvenience with permission. For example, as admin, you cannot see the old dashboards. You'll be able to see only dashboards that we shared with you. And if you want to troubleshoot something or help with any dashboard, it can be a problem for you because this dashboard should be shared with you. So that's all about pitfalls, but I would like to share with you one story. We met one hardware issue with our cluster. This issue was on AWS side. Our redshift goes down and we cannot restart it again. Thanks for separating computation and storage, we just start the new cluster of Redshift and continue all our pipelines and dashboards. We didn't lose any piece of our data because the data doesn't store inside of Redshift. But how we reestablish all schemas in our databases? The data catalog helped us to do it in the fast way. Before we discuss the data catalog, let's see the architecture of data pipeline component. So data pipeline is brain of the data platform, and data pipeline is responsible for automation and data processing. So this component has the following stack of technology as AWS, MWAA. So the service is Amazon managed workflow for Apache Airflow. It's the same as Apache Airflow, but it's just on AWS. And AWS EMR cluster for executing Apache Spark job. So at the current, there are two Airflows work inside our components. One is for building pipelines, and generally we set up this one for our data science team. The second one is for automation sync. For instance, we should conduct compaction and vacuum for data lake. So these actions are working using Airflow and EMR. For example, Airflow just submits Spark job to EMR if you want to conduct or if you want to compact your data or execute any vacuum for your data lake. Data pipeline helps us to enrich curated and merge zone in our data lake, and only data acquisition can enrich data in row zone. So that means data pipeline has access only for read data from row zone, and it's impossible to change the data in row zone by data pipeline in our architecture. So as I mentioned before, that automation is part of our data pipeline component, and we don't want to support each time when someone would like to add a new table to the data platform. We have decided to create the special bot with the name as Jarvis. So he helps to add new tables to the data platform. How does it work? Apache Airflow has a good integration with Jira, and you can find a lot of operators, sensors, and hooks for Jira. We have created the fake account in Jira as Jarvis and create the new type of ticket as data enrichment in Jira. This type of ticket has special required fields as name of product, databases, and tables. Like you can add any kind of fields to this ticket. After some of our colleagues assign such ticket to Jarvis, Airflow detects and triggers the automation. From this point, we have special DAG in Airflow, which process and execute all action to set up streaming from this table in our data acquisition component. So this automation has helped us to absolutely remove the row zone data enrichment process from data engineers' hand. Teams are responsible to enrich the data platform by themselves, and we have time to add more and more features for the data platform. Thanks for this way of automation, you can automate any process, and moreover, you are able to see the history and make any kind of statistics. For instance, we can see how many people add new tables, which team uses Jarvis, how often they use Jarvis, and a lot of useful information for you to understand how people enrich data in the data platform. So pitfalls. Airflow on AWS has a lot of limitations. The workers which can be used by Apache Airflow has the maximum for CPU and 8 GB RAM. Generally, it should be enough for you, but sometimes you can meet cases when you want to increase the memory for the Airflow, and you won't be able to do it in AWS. Also, Airflow has some limitation in configuration on AWS, and not all configuration which you have in the open source version can be overridden on AWS. Sometimes it can be a problem for you. So I think that we discussed most of component, and the last one is data catalog. So most of component in our architecture communicate with our data catalog, and data catalog manage schema, tables, metadata, and etc. Now we have one place for all our metadata of our data platform. We can search or discover our tables. Moreover, we can add descriptions and comments to help us better understand the nature of data. So the main technology which helps us is AWS Glue. And AWS Glue has data catalog, schema registries under the hood, and it includes more part, but we focus only on these two components, two services of AWS Glue. AWS Glue data catalog describes all data which we have in each zone. Thanks for this catalog, I can use Redshift, Athena, and Lake Formation without creation of table schema in the services. Everything what I need to do is to link my service with catalog, and it will drag out all tables to the services. So in many cases, services from AWS work with data catalog by default without any extra actions. AWS Glue schema registry is part of our data catalog component, and data acquisition, as I mentioned before, uses schema registry to say our streaming how to parse our events. Also, it supports version of schemas and backward compatibility check, really useful services for us. So, and of course, one of the important things in the data platform is sensitive data. We hide our sensitive data using lake formation. It allows us to hide sensitive data for some groups of people and enables this data for others. Also, we can hide rows by different, in our tables, we can hide rows by different conditions, and user won't be able to see some part of your data in the tables. So one of the most difficult part of the data catalog is metadata enrichment. When you have a lot of tables in your data catalog, the search and discovering won't be enough for you. Often your colleagues don't know most of your tables, and they want to know what kind of data in these tables. Generally, you want to have any kind of descriptions and comments about tables or columns. And the key question here is how to enrich your metadata by descriptions and comments. Unfortunately, we don't find the answer for this question, but solution which we are going to implement is we have, as I mentioned before, we have automation tool to add the data to the data platform using Childress. This automation tool won't allow to add any tables to the data platform if you don't provide any kind of description to the tables or comments to columns. If you want to add tables to the data platform, it's impossible without providing tables description. It's our idea about how to automate the description enrichment in our data catalog for our tables. So the next one, pitfalls which we faced, that Kafka Connect and Debezium don't support AWS schema registry. We had to integrate it using custom lib provided by AWS, and I think you can find tutorial in AWS docs. Anyway, we faced some bugs in this lib. Due to this fact, we made some changes in this lib to integrate with our data platform. So, and the last pitfalls, one of the important pitfalls in this list is UI changes. We share data catalog with our colleagues. Since we are not responsible for this UI, because this UI provided by the AWS, sometimes AWS deploys the new changes, and we surprise about these changes. In one time, the search by column in our data catalog didn't work, like in this new version of UI. So this important feature for us, because a lot of our colleagues try to search data by column, and we just lose it in one time due to AWS has deployed the new version of UI. So that's all about components. What's about our next steps? Absolutely, we have a lot of plans how to improve the data platform. There are some our ideas. Enriched data, what I mean here, we have third-party sources which can help us to improve the quality of data, and we want to add more and more data to our data platform. So, except integrated with our products. We are going to add new component as data observability. This component will help us to collect information about our data. For example, we can set up data profiling. Data profiling will help us to analyze the behavior of data and monitor it. In case if we have any anomalies, we'll be able to alert the teams and make our data platform more proactive. So serverless is a popular topic. I see AWS offers options with serverless, and I think that it makes sense for us in some cases. But now the serverless services doesn't support all functionalities which we use. I guess later we should pay more attention on serverless services. So, and of course we have things where we need to have the real time. So such cases, not many, but anyway, we should think about it and think how we can integrate it in our data platform. So some useful recommendation from my side. AWS offers a lot of services. Don't be afraid to spend more time on investigating and find some suitable services on AWS. Delta Lake looks good, but requires some support as conducting compaction and vacuum. Also, you can see some alternative for Delta Lake as Apache Iceberg or Apache Hudi. AWS Glue is crucial technology because it helps us to integrate Redshift, Athena, lake formation between each other without any extra actions from our side. So try to automate the process of enrichment because it will remove routine jobs from data engineers' hand. And also it can be one step to the data mesh side and data mesh architecture. So QuickSight has a deep integration with Redshift. You can balance between direct queries and cache. So since we have the list of components as data acquisition, data lake, data pipelines, etc., it's very convenient to organize a lot of support around the services. For example, monitoring. Each component can have its own monitoring with specific charts or something like that. Data science and data analytics team can build pipeline by themselves, and data engineers are responsible for building tool to work with data. For example, data platform is such tool. So some conclusion, which we said during the data platform building. Data platform should simplify the process of decision making, and you need to find a way on how to monitor it. For instance, we conduct some NPS questions each quarter to monitor if the process of working with data is becoming simpler for our colleagues. The data platform is not only for data science and data analytics team. It also should work for PO, BA, and engineers. It's important to understand because it has impact on your decision and impact on your architecture. AWS looks good for building the data platform, a lot of useful services. So to try to investigate the services and find the most suitable for you. Try to organize the feedback loop because it will help to constantly develop in your platform. Sometimes you can get you can get useful feedbacks which will be converted to idea or epics for your teams. So, and also we have created OKRs for the data platform. generally, it helps us to generate new ideas which should be implemented. And also you can monitor using key result how your objectives are improving. So therefore OKRs can, from my point of view, that OKRs can work for data platform. So I think that's all from my side. If you have any questions, I will happy to answer on it.
Okay. What we will do now, Artyom, is that we will switch to Petros because I screwed it up a bit, and there was supposed to be a Q&A section after his presentation, and then we come back to you and let people to ask some questions before we get back to Q&A for your presentation.
Okay.
So Petros,
sorry for interrupting. Can I stop the screen sharing?
Yes, absolutely. Thank you very much for the presentation. It was really interesting, and I'm already formulating a question by myself. So Petros, let's take a look at what we have there. So first question there is, how does microservices architecture benefit mobile app development? I think that was basically the topic of your presentation, so if you can summarize it in 2 sentences.
For sure, yeah. So pretty much you get all the advantages that you get in the backend, which is independent developability, testability, maintainability, which means that you can have several teams working in a single code base. Each team will own specific parts of the app, and they will only focus on those, avoiding merge conflicts with other teams. What you don't get is you don't get the independent deployability, because you need to deploy a single executable to the Google Play or the App Store. But you can, instead of deployability, you can get independent downloadability, which means that a customer doesn't have to download the whole application, which can be, 70 megabytes or more, but they can download a small part of it, a main application. And then if they need more features, like if they need to chat, if they need to have different screens, they can download them later. So that's also one benefit that you can have with the microservices architecture.
Okay, great. So second question, Petros, what is your opinion on multi-platform technologies like KMM? Do you feel like they can simplify development in case, or are they not mature enough yet?
Yeah, Phil, I mean, I haven't worked in an application, an extensive application that is built on KMM. I have worked in a kind of big one with Flutter. I would say that it's a great platform if you want to do anything that doesn't require too much hardware. KMM, I haven't too much experience myself, but as far as I know, is mature enough. But it all depends on the teams and the setup you have. If you are starting an application, in a greenfield application, and you want to try it out, yeah, I think it's a good choice. But if you already have an excessive code base and you want to migrate to it, then yeah, it might be kind of tricky. That's my take on it.
And I would just quickly follow up with another question to you, and that's what would you think about the things like React Native? I think it falls into the similar packet, right?
Mm-hmm. Yeah, I think it can work on any platform. I haven't any experience with React Native myself, but they have with Flutter, and in Flutter you can actually use it because it, as long as you can create modules, then you can segregate your code base. And it doesn't depend so much on the technology, the programming language, or the platform. It more depends on the company you are working at. How many people does it have? If you need to split the application in those microservices, or you don't need to. But regarding the technology, yeah, it can pretty much work in anything. It's language agnostic, let's say.
Perfect. Thank you very much for that. Artyom, can AWS serverless event bridge be used in the data platform architecture design you explained instead of Kafka Connect?
So, yeah, I think that it's possible to be in the data platform. It's really depends on your sources. But you know, also you can find such services on AWS as MSK Connect. It will be the same as Kafka Connect, and you won't be responsible for deploying Kafka Connect, for example, on the EKS as we have in our architecture. But you just should understand that it's new service in AWS and has some they don't have all features that we need, for example, with security or something else. But yeah, it can be. It's really depends on your sources of data.
Okay, thank you very much. And Petros, back to you. Let's say we have multiple mobile applications sharing the same entity and base logic. Is it a threat to the boundary restriction to use a shared package between these applications? Where would you put the code sharing limit?
I would say not at all, because in any case, the domain layer is something that lives on the very center of any application, which means that it is not supposed to have any dependency, but anyone else can depend on it. So pretty much you will have a module that multiple apps can depend on. This module doesn't have any dependency by default. So it's a pretty good situation to be in if they can share the domain between several apps, even between mobile and backend services, they can share entities. And as long as this layer doesn't have any dependencies, it's pretty easy to do it as well.
Okay, sounds good. Thank you very much. Artyom, what load did the architecture that you presented was able to handle? Would you recommend such an architecture for real-time data retrieved from IoT devices per second?
Okay, yeah, good question. So first of all, I don't recommend this architecture for the real time because we have in this architecture we have a data lag. This data lag is near 30 minutes. It's not real time. Therefore, you should find another solution if you really need to have a real time solution. So regarding the performance, I don't remember exactly, but I think that now we can process near 200,000 message per second. But you should understand that we work with Apache Spark structure streaming, and under the hood it's micro batching. So it's like we have micro batch when we stream our data to data lakes. It's one of the reasons why we have this lag. So yeah, I think that it's not this architecture is not good for real time. Therefore, we'll think more about how to integrate the real time components in our data platform.
Okay. Let me clean this. Petros, would you recommend to extract the clean architecture abstraction into a library so that you can use it in the front end and in the back end? For example, a TypeScript library that works for both React Native and also Node.js.
Yeah, I would say the entities is something that can be shared. Maybe it depends also on what the systems are built, but on how the systems are built. But yeah, it's something that usually it appears to be easier to imagine happening than actually happening. But I think let's say in a small company where people have direct communication, like front end, mobile, and back end developers, and if you have really good people there, I think it's something doable. It's something doable to have platform agnostic code, especially particularly entities and use cases that can be shared between apps. Now, yeah, in a large corporate world, I would say it's maybe a bit tricky to make it happen. In theory, it can happen, but in implementation, it can be a bit tricky.
Okay, thank you very much. And Artyom, I think this is the last question. For streaming analytics, data products latency is key. Do you think Lakehouse architecture is a problem or has a problem with latency? I think that's what the question is meant.
It's I guess it's not absolutely clear for me these questions. As I mentioned before, that we have a data lag, and we should understand the data platform was created for analytics, and generally we try to analyze our history. So we have data like 30 minutes, 40 minutes, and it's good for us, and it's we are okay with this data lag, and we can conduct any kind of our analytics. But it really depends on your requirements. If you think about lake house, I guess that it's not a problem. It's not a problem for streaming, and you can do it with low latency. But first of all, you should understand if you really need it, and if you need, you can find any other kind of solution which will allow you to have the really low latency.
Okay, that makes sense. Thank you very much, gentlemen. Petros, sorry for the mess up with the Q&A, but I think this was good. Thank you both for the presentations. I hope you enjoyed it. I hope people enjoyed it. I definitely did.
Thank you very much.
Yeah, thank you very much.
Okay, and let me add straight away our next speaker, Alberto. And let me introduce him a bit. Alberto is a CTO and architect in the space of real-time audio, video focused on IoT, VoIP, and WebRTC. As our world becomes ever more globalized, real-time audio, video technologies become more important and leveraged. This is why it is important to know how to properly architect real-time applications, and that's exactly what Alberto is going to talk to us about. So, Alberto, please welcome and take it away.
Thank you so much, Vaclav, for the introduction. So yeah, I'm going to talk about architecting live video applications. I will share my screen 1 second. Hopefully, you can all see
it's
it.
good.
Okay. So yeah, the agenda today is going to be about, well, first I will introduce a little bit of WebRTC, which is a very common protocol for low latency applications, real-time applications. And then I will talk a little bit about the challenges, some alternatives on how to build, architect WebRTC applications, specifically some basic architectures about the CPU and MCUs. And then at the end, I will get a bit more in depth into like scalability, optimizations, and other things that can be done potentially in the future to optimize your architecture. So yeah, WebRTC is basically a open framework for web that enables real-time communications. It was built designed years ago, but what has been officially standardized in 2021. And yeah, it's being used. I've seen being used in many of the companies, all the companies I'm showing just right here. So it's pretty popular for low latency. So as you can see, for example, here in this image at the bottom right, there are alternatives, for example, for streaming that are like HLS or Dash that are good for like 5 seconds latencies. But if you are aiming for something that needs to be sub-second, yeah, WebRTC is one of the main protocols used for that, and that's all the architecture comments and those things will be focused on this protocol. And yeah, it's not only video chat, it's not only video calling. There are many use cases. Can be professional events, live broadcasting, telepresence. So could be remotely controlling cars, for example. We could use WebRTC as well for that. So there are really many use cases. It's not just Google Meets and those video conferencing tools. So in two very basic steps, WebRTC works by has a signaling server. Here we call it signaling, where it says signaling and messages. That's like a server where we exchange communication between participants, and we make sure the participants can connect at the right time, and we know how to coordinate things. And WebRTC actually doesn't define this piece. What WebRTC defines is the video and audio communication. So there are two very the main APIs used are the Media Stream API and the RTC Pure Connection API that I'm showing here at the right. And those are mainly the two basic steps you need to do to have like a video call flowing for a one-to-one call. In the first step, you capture the audio or the video or both. And in this case, we use the what is called the get user media method. And that is basically capturing your stream like I'm using right now. And then there is the other part, which is the core of the WebRTC protocol, which is the RTC Pure Connection, which will allow us to send and receive video from between participants. And here I just briefly describe the main steps. So you would create something called a RTC Pure Connection, which would be the connection that allows us to send video and audio using UDP. So it's really low latency. And so that was like a very high level introduction. Then this is for a one-to-one call in a more realistic scenario where we have an additional piece, which is called a stand server. And this is being used to be able to communicate also between participants. Is what allows us to know what's the IP address of the other participant, because this is a peer-to-peer communication. Usually you don't know what's the IP address of the other peer, and that's why we use stand. And in even also in some situations, some firewalls might have restrictions, or there can be issues with the configuration of your router. So we have something called a turn server too that allows us to relay the traffic through. So we are able to circumvent the firewall rules, and that's like our worst case scenario. We would be using this, but this is not hopefully used all the time in video or audio calls. And this is just for one-to-one again. And what happens now if we want to have more participants? So native peer-to-peer connections is a very beautiful idea, but complicated and not practical when scaling more than 3 to 4 participants, or when you want to process video or do recording. In that case, we need some type of web server. Otherwise, we will have a situation like the diagram I'm showing here at the right, which is called like a mesh network, where all the participants send video and audio to all the rest. And obviously that's not very performant. Each participant here, for example, would be sending like audio and video, like 14 streams each. And there are better ways to do this, and that's what it brings up the idea of the media server. So if we want to scale for larger groups of participants, we have something called WebRTC media servers, and we can scale them, so it's not necessary to have just one. We can have multiple of those, and at some point we can scale not only vertically but also horizontally. And I will get a bit more in depth about this in a few slides. But in this chart at the right, I'm just showing like a representation of the number of connections we would need in different situations. So if we use a mesh network, we would be blue line where we have a linear increase, a 2x increase in number of connections. And then there are other types of media servers that would allow us to have much less connections, which means much less resources for the client, better experience. So one interesting way to build your architecture is just using open source media servers. There are, of course, also paid ones. And here just mention some of the popular open source ones, like Janus, Jitsi, Pyan, MediaSoup, LiveKit. Probably you have heard about some of them in some, like maybe you have even used them for some video conferencing. But yeah, they are used in really large solutions, like could be like Twitter or like large companies are using this. And basically Janus is built in C, Jitsi is in Java, Pyan and LiveKit in Go, and MediaSoup in C++. So you can choose based on the stack they use, but also maybe there are some use cases that are better for a specific one of them. And there are many more, of course. So I mentioned WebRTC media servers, but there are two types of WebRTC media server architectures. And here I want to mention one of them is the MCU architecture. And this, well, means basically multi-point control unit. And what it does is mixing all the audio and video streams in a single server. So as you see in this diagram, there is only one connection going uplink and one downlink. So we have, yeah, just 2 streams per user is obviously the best for minimizing resources on the client side, but also is more CPU intensive, of course, on the server, and requires processing, and also it might add slightly amount of latency, although we are still in the sub-seconds latencies, of course. And these are just some examples of popular open source MCU WebRTC servers, and like FreeSwitch, Asterisk, that are more popular in the telephony world, and LiveSwitch and Current. And the other type of architecture for WebRTC media servers is the SFU approach. So SFU means selective forwarding unit. And in this case, we are routing the streams through the server, but the server is not mixing them. So we, as a user, I would be sending a single stream or audio and video stream, and that would be distributed to all the participants that need to see or hear that. In this case, you can see then that we have as many downlink videos or audios as participants -1, but we will only have one video uplink. So this is like a middle point between having like a mesh network where you have like many connections, as many as user almost, and the MCU approach where you have just a single stream. The benefits, of course, of this is lower CPU requirements, and also it is possible to do end-to-end encryption. So basically make sure that the audio and video is encrypted all the way, even going through the server. In the case of the MCU, that's not possible because we're mixing, and for mixing, we need that traffic to be unencrypted. And yeah, just some popular open source media servers that are that have an SFU architecture are Jitsi, Janus, LiveKit, and MediaSoup. So some of the ones I mentioned before. So how, like now it's nice I talk about like a single media server. So how do we scale beyond like a single server? Like if our, just as an example, media processing is really CPU intensive. So a X-large AWS instance could handle maybe 100 or 200 connections. But what happens if we have 1,000 viewers 1,000 connections required, we would be reaching basically the limit of what would be the vertical scalability of the servers. And this is how you can solve this problem. No? That's one high-level representation of how you can do it by distributing the traffic. So having maybe, in this case, an SFU, although it could be also an MCU. But we have a server that is like the server receiving video or audio, and it's like the publishing server. And then we have other like subscribing servers they are going to allow subscribers to listen to that audio or video. So that way we are scaling horizontally, but we need to make sure, that traffic that goes to the main SFU that we see in this image, it gets distributed or cascade to the other ones. And so that was in the case of the live streaming use case, but this is just another example. In this case, it's not a live streaming use case. This is more like the common large video conferencing solution where we want to see, I don't know, 25, 50 plus participants in the same room. So you might be also, again, reaching the limits of what is the vertical scalability of a server. And it would be a good idea to use an MCU or SFU servers and to be able to connect to both of them simultaneously. So in this case, we can see all these participants, maybe they are in the same room or the same video chat call, but some of them are connecting to one server and others are connecting to another one. And the benefit of that, of course, is that then we can have more participants. We would be distributing that traffic to the secondary server, and when the main one is full or is at capacity, we would distribute the rest of participants to the other ones. And there are smarter ways to do this. This is just one approach. So now how we can orchestrate, those diagrams were really, really high level. One proposed architecture that can be used is something like this one in the image, where we have the 3 main steps, basically. So we have 3 services. So we have the dispatcher, which is the authentication server, if you want, the one in charge of managing the scaling of the other services and also distributing the actors or participants. So once we authenticate, the dispatcher decides what to do with that and redirects the user to the right SFU in this case. So you can see here we have group number 1, group number 2. We could have as many groups as we want, but this is represents just scaling peers. So we have the wrapper node, which would be in charge of managing the media server. So how this would work, for example, is I authenticate. I get like a URL that redirects me to a specific group, and then I will start doing the signaling to that specific group. In this diagram is the group number 2, and by signaling, I mean it could be just WebSocket communication that is just exchanging messages like saying, okay, I'm going to join this session. These are my parameters or my permissions for the session. Maybe some users are allowed to do some specific stuff and others aren't. So that's what would go through, would happen in the wrapper node. And the wrapper node would be in charge of communicating with the SFU and making sure the actor and the SFU can communicate and have video flowing 2 ways. So the actor is sending and receiving from the SFU. That's pretty much how like a establishment of media would go. And there are some challenges if you compare it with other solutions that maybe doesn't need to be low latency. In this case, this is a stateful system. So yeah, you are in a call in a specific session. So any like in this state, there are some complexities there. Also, in this diagram, we try to decouple media service and another logic. So that's why we have something called wrapper node and something called SFU separate. We want that to be decoupled, so the SFU or the MCU, the servers of media, focus on just that, processing media, and the rest, all the business logic is in the wrapper or the dispatcher. So we don't, it's easier to manage and to scale. And something complicated also in this type of applications is auto scaling and being careful also with over provisioning, because yeah, obviously in this case, like because you are in video calls, everything needs to be pretty fast. So if we need to start usually provisioning new services, so spinning up new services very soon, because we might not have time to have them ready when we need them. So that's one pretty complicated issue with WebRTC scaling WebRTC solutions. And also we need to make sure also to not over provision and destroy those or stop those services that we don't need anymore. So for example, if we are increasing at a piece of 2 users per second, we would need to make sure our services are can spin up fast enough to handle those spikes of usage. And again, yeah, talking about scalability in this diagram at the right, I try to define what a basic WebRTC scalability and high availability architecture would look like. Yeah, in this case, is using AWS, but could be any other cloud solution, cloud service, sorry. And yeah, what we have here is load balancer that distributes the traffic to the different wrappers. So it's a diagram very similar to the previous one, where we are distributed based on load, and we reach any wrapper, and all of them should have persistence and should know about what session they need to join, and so it shouldn't matter which service I reach. All of them should be aware. And then I should be also able to connect with the RTC media server and always connect to that one if I need to. So yeah, there are 2 important points that I wanted to mention when building WebRTC scalable solution is having stickiness and persistence. So we can have sticky sessions by using there are 2 ways that we have used in the past. Like we can use cookie-based load balance sticky sessions. So in this case, we could make sure that we always reach the same server, and then we are fine. The problem with that approach is that we wouldn't be able to do some of the more advanced architectures, like the ones we were talking about, where we have more than one server for the same session. So where we have servers sending media between them, and in that case, we need some additional logic to make sure that it doesn't matter where we connect. And the other approach is direct routing through initial authentication. So I reach an authentication server. The authentication server tells me where I need to connect, which service within our scaling group I need to connect, and then interact with it all the time. And the data persistence, I mentioned it also a bit, but is basically needed to make sure we can recover. So if a specific wrapper goes down, we should be able to spin up a new one and be able to use that, and that's what is achieved with a scalable database solution. And sometimes doesn't need to be a RDS, could be Elastic Cache as well for if we want to focus a bit more on performance. And one thing I didn't add here, but that's also common to have, is have some pub/sub mechanisms to decouple some of these. But yeah, this is not shown in the diagram here. So yeah, I talk about the architecture, the stickiness needed, the persistence. So we have that running, but there are other things that can be done and optimized. There are application and media optimizations that you can use to have better quality and have better experience when scaling solutions like this. One way is one tool that we have in WebRTC is called Simulcast and also SVC. So SVC is a bit newer, and what it does is allows you to send basically like a technique that allows you to encode video streams in multiple layers. So in this image at the right top corner, I kind of describe this, where you are sending different qualities of video, for example, and based on the situation of the network of the clients, some would be able to receive higher quality, and some would be able to receive lower based on the network conditions. And that's something that is mostly handled by the WebRTC stack. So there isn't much that need to be done, especially if you use media servers. And you can you could choose, for example, based on that, some users would be receiving maybe more frames per second, others less. So that's a pretty powerful option to optimize your WebRTC solution. Also, there is the audio detection, where you can have just audio and display video only when the speaker is interacting. And that's something very common in many applications today. Like, you are not seeing everyone, you just see the main speakers, and we use just audio detection to display that. Or sometimes maybe you don't even need video. So there are other solutions that work pretty good with just audio, and that's a way also to scale to a much larger audience if needed. Another thing that is commonly used is adaptive bitrate based on resolution of the screen. So, for example, if one of those users in the SVC example minimize the screen, we wouldn't want to be receiving like that much video quality, like the frame per seconds or the resolution of the video maybe doesn't need to be that high. So we reduce it based on the client movement of the screen and the size. And other also pretty cool techniques are the Opus Red and DTX. Those are techniques for audio optimization. And here I explain a little bit how Opus Red works. And is basically a technique of sending redundant audio. So you always send redundant audio in the next package. So if there is a missing packet, we recover it just after. And it's proof that improves audio quality. And yeah, there are some future application optimizations that can be done that they are kind of more in progress. So there is AV1 video, the AV1 video codec that is today being used for very commonly in YouTube for consuming video or in Netflix, but it's not as popular today for publishing video, just because many of the devices today doesn't come with hardware acceleration for AV1. And that's something that will change and will improve a lot the performance of video calls, and that's something that, well, many people is already experimenting with, and that's one way to improve quality with the same bandwidth. So that's interesting. In similar way, Lyra v2 is an audio codec that does something similar. It's an improved codec that allows similar quality to Opus, which is the current codec being used today. But as we can see in the results here at the right, with much lower bit rates, we are able to achieve same level of quality in audio or score. So playing with those codecs, would make a huge difference, and especially in the future. And there are other machine learning optimizations that will be interesting. They are being used today for noise reduction or packet loss concealment, which what it means is that it fills the blanks of what when we miss a packet, we just fill that with some noise that simulates what it would be, what we would be hearing. So it makes the experience more smooth. So in summary, I would say, like, if you are building like a WebRTC application for scale, first, focus on your use case needs. There are different architectures. There is the FUMC, as I mentioned, but also just once you decide that, also there are different ways to scale it. And you might want to also review if you really need to use low latency streaming, because it's much more complicated than just streaming HLS or some like on-demand video. And so that's something you need to consider if you really need that sub-second latency, and some use cases perhaps don't. Also, don't underestimate the importance of efficient, scalable, and highly available WebRTC infrastructure. So it's really critical. Like, it's just not going to work if you don't have that set up properly. You want to make sure when you reach a specific amount of connections to make sure you spin up your new service, and if a new service goes down, that we are storing the state and being able to recover from it. And you will need also to decide where you are willing to compromise. So as I was mentioning, you have the, for example, the MCU architecture, which puts all the pressure on the server side, and it's a better performance on the client side, or perhaps an SCFU approach, which is a bit more CPU intensive on the client, on the edge, on the user. So you always need to compromise on what you care more about, and if you want to display all the videos, or maybe just display one with high quality. So these are some things to consider. And of course, optimize and leverage the latest WebRTC capabilities, that some of them I mentioned today. And I think they also make a huge difference. So thank you so much. Now you hold the ring of power to build your WebRTC application. And thank you for listening. I don't know if anyone has any questions.
We do have some questions. So thank you, Alberto, for the presentation.
Yep.
You talked about, let's jump into the question. So you talked a lot about networking, latency, and containers. So there's a question for that. Container technologies like Pivotal Cloud Foundry offer container-to-container networking capability, which helps minimize latency incurred in invoking services remotely. Can you discuss this more and how it can help with service orchestration?
I need the first part. 1 second. Offer container. I haven't specifically used PCF, but so one issue with low latency is that many people traditionally it always have been built in physical devices. So it's always that's how many of these media servers were originally built for. And now adding, of course, adding like building them Dockerized and building them in using Kubernetes and things like that facilitates a lot, like the spinning out of the services. But at the same time, there are some unknowns sometimes in terms of networking. There are complexities that, like you are using a virtual machine, and that's something that many developers, like in the team, like you are DevOps, you don't know that much about networking, and network engineer maybe doesn't know that much about DevOps. So it's a point where it's complicated to be very successful with. But yeah, it can help minimize latency by well, it doesn't minimize latency. It minimizes like the spinning, like the efficiency. I think it's mainly it helps for efficiency reasons. So you don't want to have resources you don't need. But having container technologies or not, it really is not going to change the latency experience on a WebRTC call, because it's just going through the same path, and that's
Okay, thank you for that answer. Anyone, if you have still questions, please ask them in the chat. We have one more here. Do you recommend to use PJSIP library in such applications? So I assume in low latency WebRTC applications.
Yeah, I think PJSIP is a SIP library. So this is more of a signaling question. So it just one of the signaling piece. You can use. I'm not familiar specifically with PJSIP, but you can use any signaling piece that you want. I think the signaling is not usually the problem for real-time applications. The problem is more of how efficient is your media server and how fast is like how close it is to you and things like that. But really, the signaling communication, you could use PJSIP, which is, I assume, is using SIP for signaling. You could be using even WebSockets or whatever signaling you want. I don't think that's a critical piece for your architecture, for low latency and for real-time applications. So I would use just what you prefer to send messages.
Okay, thank you for the answer. It doesn't look like we have any other questions right now. So I guess that people will have to reach out to you offline. I mean, probably online, but offline from the conference perspective, and ask those questions if they still have them. Thanks a lot, Alberto, for the presentation, and have fun for the rest of the conference.
Thank you. Yeah, thank you for inviting me. Have a good one. Bye.
Okay, and I'm gonna add the last speaker of the blog to the stream. Welcome, Brian. Hey, can you hear me?
Thank you for having me.
Cool. Brian is an application architect, fractional CTO, and a mentor. He asks important questions about how teams and team members feel and work together, and finds inefficiencies there. And in his talk, he will show us some of the approaches to enable developers to get more done. And I'm really excited about that, because everyone needs to get more done these days. There's no time to waste. So I'm going to enable your presentation. Brian, can you make it full screen by any chance? It seems like we see your top of the window there. Awesome. Thank you very much, and take it away.
Alrighty. Yeah, thank you for having me. I'm really excited to be here this afternoon and to talk about some of the ways that we can enable developers to get a little bit more done. Oh, might have some lag there. Curious, are you able to see the slides change at all?
Sorry, I was muted. So I was saying that yes, they changed just now.
Okay, perfect. Let's restart then.
But it took a while.
Yeah. Okay. There we go. Let's try again. All right. Yeah, so like you heard, my name is Brian Childress. I am an application architect at a growing scheduling startup called Calendly. If you're not familiar with what we do, we help to enable individuals and organizations to more easily schedule external meetings. So I would encourage you to take a look at what we're doing. There's a lot of cool things happening. In addition to my role at Calendly as an architect, I'm also very, very passionate about the developer experience. And throughout my career, that's been an area that I've tended to focus a lot on, is how can me as an engineer or as part of a bigger team get more done? How can we automate? How can we improve? And how can I share what I learn with others, either within my organization or externally? And so some of those ideas I want to share with you today. So a quick kind of rundown of some of the topics that I'd like to discuss. First, I want to start with what is the developer experience and what do we mean by that? Some of the goals that we might have for the developer experience. I'd love to share some of the tools, tips, and techniques that I've learned over the course of my career working in big organizations and small organizations both. And then finally, one of the most challenging parts of our job is talking with others. So I'd love to share some of the ways that I've been successfully able to better collaborate across teams, especially in a distributed world that we live in today. Now, these ideas aren't all mine. They don't come just from my work at Calendly. Some of these ideas do come from current initiatives, but also from other organizations that I've been a part of or research and conversations that I've done. So I want to first start off with what are some of the goals that we have for focusing on the developer experience and enabling developers to get a little more done. And I want to start with a backstory here. So at Calendly, the original application, which we still run today, is a monolithic Ruby on Rails application. There's a Postgres database, and up until maybe 18 months ago or so, that entire application was running on Heroku. Arguably a very simple architecture that has allowed the application and the organization to grow quite significantly. And I think the pandemic has certainly helped in accelerating the need for better scheduling software. Over the last 18 months or so, we've been going through a process to decompose that monolithic application. And this has really been a key driver in the focus on the developer experience at Calendly. In addition to decomposing the monolithic application and going more towards a service-based architecture, we've also grown significantly. Our engineering organization has grown leaps and bounds. We now have many teams of new developers, and we're distributed across the globe. Now, this is fantastic for bringing really, really smart and talented people together to solve some challenging problems, but it also creates new challenges of its own. So when we think about the developer experience, many of us think about ways that we can improve or increase the speed and effectiveness of delivering new features to our customers. A lot of the ways we try and do that are to remove boilerplate, manual processes for engineers so that we can allow engineers to continue to be creative without having the burden of manual processes. Now, some of the other names that you might hear for developer experience could be developer enablement. At Calendly, we use DevX, and you may also see DX as an abbreviation across the industry. But really, the developer experience is a focus on what experience developers have while using your product. And one key piece of this is your product may only be seen by internal teams within your organization. So even if what you create and build isn't shown to your final customer, you do still have customers, and we want to make sure that we're focusing on them. So when we started to look at how can we focus on and improve the developer experience, we first started by taking a look at the journey of the developer. And one of the ways that we evaluated this was to take a look at what is it like for a new developer to join the organization. They've joined the organization remotely. They are distributed somewhere on the globe, and they want to join a team that can help them to get up and running quickly. They want to help deliver new and exciting product features, and we want to find a way to remove any friction points in that process. Similarly, in looking at what does it look like for a new developer to join or onboard the organization, what's it like for a developer to start a new project, join a new team? How is that transition handled? What are some of the ways that we can help to improve and smooth out that process? And so we took a lot of what we learned from that evaluation and identified some friction points that we have focused on over the last 18 months, 12 months to really help to improve that process. And really, the goals for focusing on developer enablement is to provide smart guardrails to our engineers that allow them to move quickly and safely while not putting in place any types of roadblocks. We want to smooth that process as much as we can. And really, for me, the biggest focus around the developer experience is this: it's developer happiness. Because when developers are happiest, they can be productive. And our developers are most productive when they're happy. So what are the small things that we can do to improve that day-to-day workflow for our developers that could vary among teams, among individual developers? If we can reduce those pain points, we can inevitably increase developer productivity and efficiency. One of the other ways that we tried to identify some of these pain points is just by asking our developers in an anonymous survey. So several months ago, we sent out a survey to our devs, completely anonymous, but we were trying to find the points of friction that they're feeling in their day-to-day work. What are some of the areas that we can focus on, both at a large organizational level, but also at an individual and a team level? And some of the areas that really came out in that survey were things like the local development experience. which has become really challenging as we move from developing in a monolithic application that can be easily run on a developer's laptop to a service-based architecture that cannot be run on a developer's laptop. How can we better improve that local development experience? Similarly, how can we improve our testing? Fortunately, we have a very extensive set of tests, but those tests have become more and more challenging to maintain. What are some of the ways that we can improve the maintenance of those tests so that we can still feel comfortable with what those tests are telling us, but not increase the maintenance burden? And then finally, like I would imagine many organizations have, is a challenge around cross-team collaboration. And for us, our teams are not only focused on different areas of the application, they're also geographically distributed, and that can introduce some real challenges. So some of the ways that we've tried to solve for these problems and improve the developer experience started with what technologies as an organization are we adopting? Now, our monolithic application is a Ruby on Rails app, but as we start to grow, we want to be able to explore and use other technologies. And so we started with this idea of a tech palette. Now, the tech palette is a way for us to distinguish technologies that we are adopting within the organization and which we are encouraging our individuals and teams to use. And there are also technologies that we're exploring for potential new use cases. So here's a number of different services or frameworks or languages that we've adopted as an organization. We've got a strong Ruby on Rails user base. We have an existing Postgres database. We want to continue to leverage those technologies, but we also want to leverage newer technologies as well for certain use cases. Now, alongside our tech palette, we have this concept of a paved road. And really, this is an affectionate term given by our platform team for our CI/CD pipeline. Now, built on the technologies or following the technologies that we have in our tech palette, the paved road enables our developers to easily deploy new services out into our environments. Alongside our paved road, we have this concept of a sidewalk. And the sidewalk allows for some level of automation. It follows our tech palette in enabling us to explore new technologies, but it gives us the same types of information feedback that our paved road or our CI/CD pipeline gives us. And the sidewalk concept has been instrumental as we build out our data warehouse and our data ecosystem, because it's allowed us to explore new technologies as we start to grow and expand our focus on data. Now, following our tech palette and supported by our paved road, we have this concept of service templates. As I mentioned, we're moving from a monolithic application into more service-based architecture. And with that, we want to make sure that we have consistency across our services. And so what we've done is developed a series of service templates or reference implementations that have all the libraries and the structure that we're looking for in our new services, so that developers, as they spin up a new service, they don't have to think about any of that boilerplate code. It also gives us consistency so that developers can move from one service code base to another service code base without having to figure out what is going on and what's the difference in those particular implementations. We only need to understand the business logic that supports that portion of the technology. Now, within here, we've got things like shared libraries, all of our linting and formatting, all of that's kind of baked in to the service templates. And this has been a big win for us in enabling us to create new services easily. Now, the service templates are backed by an internally developed tool called CalPal. Now, CalPal is a CLI application that allows a developer to write a simple command to create a new service. That CLI will go and grab the latest version of the service template, create a new service. All the monitoring and observability is already baked in. All of the necessary controls around branch management within our code repositories, all of the CI/CD pipeline, all of that is completely done in an automated way. So the developer doesn't have to worry about any of that, and we have consistency across our environment. Now, this has been really, really impactful for us. Now, like I mentioned, one of the biggest things that we heard from our developers is we need to focus on the local development environment or the local development experience, especially as we're bringing on new engineers and we're looking to move to more service-based architectures. Now, as I would imagine, many of us have a lengthy document somewhere shared that walks through every step required to get a new developer's environment set up. For us, it's stored in Confluence, and every developer that joins is encouraged to follow that document and then make any necessary edits if there are updates needed to that particular document. Now, that works great, but it can be error-prone and time-consuming to get set up on. So another thing that I've seen organizations and teams have great success with is essentially trying to automate some of that process with a series of scripts. So a lot of times this is a few bash scripts that an engineer might write and then share with others on their team. I like to call these coffee scripts because if I'm lucky, I can run the script, go get a cup of coffee, and then come back, and then hopefully I've got a running environment. This works really well for things like creating a brand new database with fresh data for local testing. And this really does help improve that process and the effectiveness. And then finally, one tool that has also worked really well is creating a custom CLI that can enable new developers that are onboarding to get their environment set up quickly. Or if a developer receives a new laptop or has any issues, they can kind of get back to a baseline implementation quickly. Now, not every engineer cares about the same things. And so this is kind of that challenging balance is some engineers love certain development environments or IDEs. Some really like their key bindings and the way that they have their setups. Some really just want to write code and not worry about the hassle of where it's going to run. And then other engineers really just like to have that very tight feedback loop so that they're getting feedback on what they're developing and if they're going in the right direction. So this was a big focus for things like the local development environment is having that fast feedback loop. Now, one of the approaches that I've really found effective in rolling out some of these new tools is something that I call the stoplight approach. And so it's my understanding that this isn't the case everywhere, but in my experience, say there's a new road or a new intersection that's introduced, that they will install a stoplight. But at first, that stoplight is only installed and then kind of covered up, right? It's not turned on and made active right away. And then a few weeks later, a month later, that's when the stoplight will ultimately be turned on and made functional. And it's my understanding that this is done so that in the road example, as you're driving down the same road every day, you're not all of a sudden surprised that there's a new stoplight there. And for us, there's not a new tool that's introduced. And so I found this kind of concept to work really well when I'm rolling out new tools like code linting and code formatting, right? I don't want to all of a sudden surprise my engineers and say, oh, this is how we're going to start to think about formatting our code. Now I need to spend 2 days getting the entire code base up to par. And so by incrementally rolling out some of these tools and changes, and to what degree they are enforcing compliance, I found that really to be effective in the adoption from the engineering teams that I've worked with. Now, another big area that I think a lot of organizations have an opportunity to smooth out the process and remove friction is around granting access to the systems and information that engineers need to do their jobs. This is everything from documentation and designs to different environments and data, logs, that sort of thing that they might need for troubleshooting purposes. This is really important to make sure that developers have access to the things that they need to do their job without over granting access. Now, to kind of switch gears a little bit, I do want to reveal a little bit of a secret that I've found to be more true as I continue through in my career. And that's that technology is the easiest part of what we do as software engineers. The greatest challenge to us is around communication and focusing on what engineers are telling us. Now, some of the ways that we can improve the communication, especially across teams and as a globally distributed workforce, communication is very important. So some of the areas that I found to be really effective are things like team newsletters, where one group within the organization might share some of the big things that they've been working on that could have impact on both our external customers or our internal customers, right? Other teams. Now, one thing that Calendly does really, really well is sharing information through regular all hands meetings. And it's an opportunity for engineers and teams to demonstrate some of the really cool things that they've been working on. And as we kind of stay huddled down in what our individual teams are focusing on, this can be really valuable and just keeping aware of what all is going on around us in the ecosystem. Another thing that we do really well is around documentation and focusing on asynchronous communication that happens in public. So our documents are shared in Confluence, or conversations are happening in Slack, but they're happening in public. And that's a way for us to avoid having knowledge silos or conversations that are happening in a vacuum. And this has been really, really helpful for us as we're spread across so many different time zones. And another thing that we've recently adopted is sharing asynchronous communication through recorded videos. This is a great way for us to walk through things that are working or questions that we might have, and as a way to be able to communicate with each other without having to do it in a synchronous way. Now, one of the things that we need to make sure we're doing as we're focusing on developer experience and enabling our developers to get more done is to make sure we're focusing on, are we doing a good job? One of the challenges that I've seen is too much focus on perfection and not enough focus on just making incremental progress. And so this is where concepts like the crawl, walk, run can really come into play. Focus on the small wins, the little things that can really impact developer effectiveness and efficiency, and start to chip away at those friction points within your organization. And ultimately, you'll get to an organization that can move much more quickly and efficiently without a lot of manual processes, without a lot of conversation. Things just happen smoothly. Now, another way to help improve developer enablement or the developer experience is to find your champions. Look for the folks that are really excited and interested about the work that you're doing and help encourage them. Dedicate time and resources to those individuals to allow them to do more and better provide for the rest of the engineering ecosystem. But don't let perfection stand in the way of your own progress here. So
Okay.
I'd love if we have any questions in time. I would love to try and answer them.
Absolutely. Thanks a lot, Brian, for very insightful presentation. So the question we have here, and we'll see if other questions come our way. How do you distribute knowledge on used technologies among multiple teams and members? Do you think that specialization on specific technologies works best, or aim for familiarizing every developer to the entire tech palette? So let's start with the first half. So how do you distribute the knowledge? If you can sum it up, I think I saw it in your slides.
Absolutely. So there's a few ways that we distribute knowledge. One, we have a centralized architecture team. So personally, I work with 6 different teams and help to distribute some of this information to those teams. We also do a really good job at documentation. So that information is written down and freely distributed among the entire organization. And then finally, we talk about that information as well in a number of cross-organization conversations, whether it's our technology all hands that we hold once a month, or regular sync conversations between certain groups of individuals within the engineering org. And then finally, a lot of those conversations are recorded, but we're also starting to increase our adoption of just regular recorded videos where, as an individual, I can record some information or how can I stand up a new service quickly and easily, and then I can distribute that out to the entire org.
That makes a lot of sense. And for the second part then, do you think the specialization on specific technologies works best, or every developer should be familiarized with entire palette of the company, basically, or the project?
I think this is a balance here. I would encourage all developers to kind of understand the components of our entire tech stack. What are we using certain technologies for versus others? What technologies are we using in our data ecosystem versus our asynchronous, pub sub type communication. And then as we get more specific into what an engineer or a team is focusing on, I think that's where we want to specialize then on more specific technologies. But we always want to focus on what problem are we solving so that we can make sure that we're solving that problem with the right technology solution. And that's been a big focus for us, is to make sure that our tech palette is big enough that we can solve most problems that we anticipate encountering, but not so broad that it's overwhelming for any engineer to come in and understand the technologies that we have at play. So this is where we really want to reduce the number of languages and frameworks that we are using across our architecture.
Awesome. We have 2 more questions here, and both kind of follow up on this one. So I'm going to start with this. Do you work with new graduates? How do you differentiate between fresh grads and seasoned developers in your framework of developer experience?
Personally, I do work with a lot with new graduates, especially folks coming out of boot camp programs. Calendly is starting to have more folks that are coming in at a new graduate or more junior level. And one of the ways that we're really focusing on that is to provide some really close mentorship to those individuals, right? Whether it's pairing them up with a more senior developer in the organization, providing learning resources so that they can learn on their own and understand, and then just making ourselves as more experienced folks available to answer any types of questions. As far as differentiating between fresh graduates and senior seasoned developers, we don't really try and distinguish in any way from as far as the developer experience goes. I think, at certain levels in our career, we have different needs and challenges. And so that's where we're more focusing on the individual and what do they need for their kind of where they're at in their career journey.
Makes sense. And with all the differentiation, how do you handle diverse laptop hardware setup preferences? For example, operating system, IDE, anything else that can fit into that category?
So this is thankfully from an operating system perspective, I think the majority of the engineers are on a Mac-based system. There may be a couple that have adopted, maybe a Linux OS or something. Typically, in my experience, we've selected an operating system and then maybe an IDE. So let's say everyone is on Mac OS and using Visual Studio Code. And if you choose to go outside of those, those would fit within the same realm of our tech palette. If you go outside of that, then it's your job, your challenge to make sure that the code that you produce in that environment is able to match up with what everyone else is working on. So if you're going against the grain there, then it's your responsibility to make sure that what you produce kind of fits in.
Okay, that makes sense. We have another question here. What do you do when a service template has some improvement? How would you replicate it on every already created service? Would you replicate it on every already created service or use it only on the new services?
This is a really good question and something that we're working on solving for right now. So all of our service templates are versioned, and then using our CalPal CLI tool, I can create a new service and select a version of the template. So I can use older templates. By default, all services that are created new are using that latest version. And then to answer the question, any previously created services, we're working on updating the CLI now so that it can go and create basically a diff between the version that the service was originally created on and the latest version, and try and bring those two together. So we're working on it so that the tool can hopefully help us and do a lot of that updating that would be required. Say if there's a new version of a library that's been introduced, we can bring that up to speed. And then we're trying to just keep all services up to date as much as we can throughout its life cycle so that they don't fall too far behind the latest version of our service template. It is quite a challenge. We're trying to put as much automation around that as well. And this has also been very important as we focus on continued security within the application so that we know which versions of libraries are running within which services. And so this is a way that we're trying to address that concern as well.
And I'm seeing organizers lining up, so I guess that they want to close it, but I want to ask this question. So I think first we need to ask, are your templates public? And then, if they are, do you also have a template for Spring Boot or Kotlin on GitHub?
The service templates are not public, and we unfortunately do not have a service template for Spring Boot or Kotlin. Our Android native application is written using Kotlin, but because that's a single application, it's not something that we necessarily needed to templatize.
Okay. And since there is just one last question, what would you suggest to achieve a good developer experience on testing feature or bug edge cases before publishing to production?
For me, I think it's most important to have quick feedback. So this could be things like automated testing as part of your deployment workflow. This could be identifying a bug or an edge case issue, even if it was introduced into production, identifying that quickly and then prioritizing the fix as part of future work. And so not allowing a bug fix to be written down on a user story and then put somewhere on the backlog. We want to prioritize that so that it gets taken care of as quick as possible, while the context of that particular feature is still fresh within the developer's mind.
Awesome. Thank you very much, Brian.
Yes, thank you all.
Okay, that sums up this blog. I guess that I'm just gonna remove myself and let the organizers to take over.
Hey, Vaclav, thank you once again for helping us with this blog and for moderating this blog. And now we have a giveaway. We have a sponsor giveaway from our sponsors, CodeSign and from Geekle. So we're gonna have a randomizer, and we gonna give away an iPhone 14, as we promised. Yeah, and I just want to excuse myself if we will in any way show someone's email, and if governmental emails got leaked. Just kidding. Yeah, so we're gonna show the randomizer. We're gonna show the list of the emails. We're gonna upload them to the randomizer. Then we're gonna run the randomizer, and then we will find out who's the winner. Yeah. So let's get started. So we're copying all the emails, and it's 246, and we are uploading them to the random.org. Yeah, we're gonna randomize them now. We're gonna do it a couple of times. Let's do it again. And yeah, so, and the winner is Emil Angelov. And we need to check if Emil was actually registered for the junior track, or maybe somehow he got the link. Maybe someone posted it on the social media and he never did visited us. He never did attend it, but we hope Emil is the legit winner. So Yuri is gonna check our tech support will check if the registration and if all the necessary procedures was in place. Yep, a legit winner. So Emil Angelov, dear friend, you won yourself an iPhone 14. Yeah, so we will contact you soon, and we will tell you about the procedure, how you will get your prize. And now we're gonna have a short break, and after the break we're gonna have 3 more awesome topics. And don't forget about the awesome workshop from CodeSign on 17th. of November. And you will definitely have a reminder on your email with all the credentials, with all the links necessary. And don't miss Adam's talk tomorrow. All right. So we have some questions in the chat, and we will post the name in the chat in case Emil missed it. Have a nice end of the day and have a great evening and have an awesome rest of the conference. Bye, everyone.
I'm Adam Thornhill, a software architect with degrees in engineering and psychology, and I'd like to welcome you to an exclusive workshop on November 17. In this workshop, I'm going to show you how you can pick up a codebase of any size and scale, and within minutes, identify all the technical depth in that codebase. As if that wasn't enough, I'm also going to show you how you can prioritize that technical depth in a way that makes sense to both the business and the engineering side. And of course, we're going to look into opportunities to visualize codebases too. Too good to be true? On November 17, we make it a reality. Hope to see you there.
Well, hi everyone. Welcome to Block 4. Good morning, good afternoon, and good evening to wherever you are. My name's Adrian Kearns. I'm a solution architect with Middleware New Zealand, based in Wellington in New Zealand, where it's a nice sunny morning here. So yeah, kicking off this last block, I've got a couple of live sessions and one recorded. And our first speaker today is Rahul Gupta, architect at Microsoft. He'll be talking to us about data meshes. So I'll just bring Rahul into the stream. Good morning, Rahul. How are you? Oh, you might just be muted. Don't worry, I've done that 1,000 times. It's everyone. So Rahul's had 2 decades of experience in data modeling, database design, business and technical analysis, working for various companies such as Microsoft, Deloitte, Tata Consulting Services, Philips, CGI. How you going there, Rahul? Oh, still seem to have some technical difficulties there. Always some gremlins first thing in the block. That's the way it goes. That's all good. So for those of you who this is your first Geekle, welcome. This is actually my 4th. I've had the pleasure of being involved in 4 of these.
Now,
hey, here he is. Hey, good morning. Congratulations.
Good morning.
Good to see you.
Good to see you as well. Thank you.
No worries. So, so you're talking to us about data meshes in Azure today. I'm interested. I mean, how long have you been interested in data? Did you, when you were a young boy, did you grow up thinking that you were going to be involved doing, data when you grew up?
Yeah, I have always been interested in computer science as such. So when I was young boy, I used to build my own computers. Data is something which got me interested once I started my professional career in data. So that's when, I was working on databases like SQL Server, and from there, I expanded my scope to a lot of other areas in data, including big data, machine learning, data lakes, data architectures.
Oh, brilliant. Awesome. Fantastic. So are you ready to launch into your presentation?
Yeah, I'm ready to go. I hope you can see my screen.
I'll bring that up in a second. So, so just to introduce Rahul's topic, he's going to be talking about data meshes in Azure, talk about data meshes, the new kid in town, and explain whether or not they're a buzzword or a legitimate feature of data architecture. So I'll hand it over to you, Rahul. Welcome.
Thank you. I hope everyone can see my screen. All right. I'm assuming it's visible. So yeah, let me start this discussion with data mesh. So I know data mesh is a new kid in the town, and a lot of customers whom I work with, they ask me whether they should go with data mesh, whether they should not go with data mesh, and what is this all about, right? So in this presentation, I'm trying to, compress this material into 30 minutes. We don't have a lot of time, and this is like something where, we have a lot of links also. I can send some links of data mesh in Azure specifically. But what I will talk about is like some of the pain points which I have seen customers today having in their current data architecture, right? And how data mesh can be helpful there, right? So fundamentally, if you think about data mesh is a paradigm shift. So up till now, we have been talking about a centralized monolithic data lake kind of architecture or data warehouses. But those warehouses or data lakes don't fit the needs of all the customers. There are challenges with those kind of architectures. Many of those projects fail, and then we have so many issues there. So I will talk about those in detail for one of my customers whom I worked with recently. And then data mesh is more of a distributed data architecture. So we are moving from more like a monolithic data lake or a data warehouse to a distributed data architecture, which is I've seen helpful in some of the scenarios which I work with the customers. All right. So I'm going to talk about use case here. So recently I have been working with one of the customers. They had many different systems on premise and cloud. There were several data warehouses, data lakes, etc. But they were not getting the value out of those warehouses or the systems they had. And there were different challenges. There was a whole complexity of managing these different data architectures. And there was complexity of getting the data out of these systems in timely manner as well. So if I go to the next slide, this is some of the common issues that we have seen. So one of the fundamental issues that normally this customer faced was like they had all these different kinds of systems there, as I talked about, but it was all siloed. There were different business units which were having these siloed kind of architectures, and it was very difficult for them to get an integrated view of that. They had, in fact, a data lake in which they tried to cram these data into one data lake, but it was also not serving their needs due to many reasons. They are a central IT team. which was very slow because of the like different priorities from different business units, and that caused a lot of issues. The other thing is on the data governance. This customer was a big customer, and they had like issues in terms of how do they govern their data. Like a lot of the data they had was dirty. It was not integrating well with other systems which they would like to integrate and get a unified view, and the cost of the data engineering was too high for them, so they wanted to reduce that as well. So in a nutshell, I won't drain the entire slide, but the whole idea was that it was not giving them the data insights which they wanted in a unified fashion and in a timely way. So what I'm going to discuss next is on how do we evolve from a traditional
Hi, Rahul. Sorry to interrupt. Would you mind just being able to go full screen? We can just sort of see the editor mode at the moment.
All right, sorry. Let me do that.
No worries. All good. Thanks very much.
Yeah. Can you see now?
You might need to share a different screen.
Oh, this is my only screen. Are you not able to see it?
We can just see the slides down the side. I think we're just hoping to get to maximize the slide that you're currently presenting, just so people can read the text most clearly.
I'm doing a full screen. So what are you able to see? Because that's what I did. I just did a full screen. Let me check. Like, is it like you are seeing some edges of the screen, or what exactly?
Oh, we can see the mode that you normally see when you were composing a deck, editing the slides and so forth. So we can see a list of slides down the side and the toolbar across the top. Right, sorry about this, everyone. It's always a bit nerve-wracking coming in doing a presentation, especially for the first time. So
let me do one thing. I will try to reshare it and see if that works.
Yeah, all good.
All right.
Here we go. Awesome. Thanks, Rahul. Fantastic. Back to you.
You're welcome. Yeah. So what I was talking about was some of the challenges which I have been discussing with the customers. And as I said, right, one of the top challenges, of course, is that they have a lot of siloed data sitting in different systems, and it becomes very difficult for them to integrate the data and make sense out of it. And then the other challenge which I talked about is on data governance, which is one of the top priorities for them as well. And I think you can look at the other challenges. These are very common in some of the other customers also that I work with. So as I said, like I'm going to talk about how to evolve from a traditional to a data mesh implementation. So if you look at this slide, this is traditionally what most of the customers have, like which I work with. So they have data coming in from different data sources. They have a central data lake, and then they have a serving layer using Power BI and other components through which they get the insights. In the case of this customer also, they had an architecture like this, but it was maintained by a central IT team, and all the data was actually ingested and loaded by that team into this central data lake. And due to the priorities of the different business units they had, it was becoming a bottleneck because every business unit had to go through that central IT team and then get their data into the data lake, get it curated, get it cleansed, and so on. So this kind of architecture, what I've seen is work well for smaller customers. But like if you have a bigger customer with many different business units and they want to be more data agile, this architecture for those kind of customers will not work that well. And that was the case with this customer. So instead of going into this traditional monolithic architecture where we have one data lake, what it ended up doing is a data mesh. So instead of having everything crammed from different business units, all the data into one central lake, we had actually come up with this architecture, and I will talk about this data mesh implementation more in the upcoming slides. But essentially what we are doing here is like we are having different data landing zones for different business units, and then we have a data management zone, which is more of a federated governance for all these different landing zones, so as to make sure that the data is standardized, it's in conformed form, and it can integrate well. So before I go into details on data mesh implementation in Azure, I just wanted to talk about the guiding principles as well. So there are 4 guiding principles. This is nothing specific to Azure, but this is from the data mesh founder itself, right? So we have this domain ownership, right? Going from a decentralized ownership. So as I talked about in the data lakes, we have more of a central ownership of the IT team, and that can be a bottleneck. So one of the core principles of data mesh is to go to a domain ownership, which is more of a decentralized kind, right? So each of the business units, you can think about having different domains, and those domains having separate ownerships. This really helps, as I said, for bigger organizations where they want to be more agile. The second one is data as a product. This again is something where we want to have data not as an afterthought, but it's something which can be consumed by the other business units within the organization as well. So in the scenario which I was talking about, the customer had separate business units, and we wanted to publish the data from one business unit so that it could be consumed by the other business unit. So in terms of the trust and the quality of data, it should be at par so that it can be easily consumed and trusted. The third thing is on self-service data infrastructure, right? So this is something where it should be easy for the data developers to set up a data infrastructure. Specifically in Azure, we have different templates which make it very easy to set up this infrastructure. And I will talk more about this in the upcoming slides. And then the last point here is on the federated governance. This is to make sure that your data is easily discoverable, and it can be found by the different business users. So this is an area where we have Purview in Azure, which can easily help you to classify the data and make it easily discoverable so that the different business units can consume it. All right, so moving on, I will talk specifically about cloud scale analytics. This is the Azure implementation for setting up the data mesh. So basically here, using this framework in Azure, you can easily spin up data landing zones and data management zones. And each of these can be in a separate subscription in itself. And I will talk more about this in upcoming slides, but the whole idea here is that cloud state analytics again is specific to Microsoft Azure way of implementing the data architectures. And using this framework, you can easily implement data mesh in Azure. All right. So this next slide, which you see here, is specific to single landing zone implementation of a data mesh in Azure, right? So if you look at this, at the foundation here is the cloud adoption framework. This is, think about it as your network identity, your security, which are some of the basic elements which needs to be set up before you can implement your data mesh in Azure. So like if you are going to construct a house, you need your sewage, your electricity, your water to be there, right? Before you start constructing. Similarly, in case if you want to build a data mesh using cloud scale analytics, we recommend first deploying a cloud adoption framework, which will give you those basic network security and identity management setup before you start building your data mesh using your cloud scale analytics. All right. So basically, if you look at this, this is the first step. You need to have this in place, and then on the top of it, if you are a organization which is not of that big size, then basically you can have a single data landing zone where you can have all your data domains within that landing zone. This essentially, for scalability purpose, you can have it in one subscription, and your data management landing zone, which includes Purview, master data management, and other data governance tools, this is also deployed in a separate subscription. And even if you are a larger organization, normally we start with one single landing zone, and then we keep scaling by adding additional landing zones as we actually go into other business units. So moving on, as I said, the other kind of implementation which we have is essentially having multiple landing zones, and there can be different use cases for this. For the customer which I worked with recently, they had different requirements in terms of the regions. Like some of the regions, they wanted to have strict data sovereignty requirements where they could not put the data in other region. So for those kind of scenarios, we had this data landing zone in a subscription specific to that region. And then for other regions, we had a separate landing zone. So if you see in this scenario, like you can easily scale this architecture where for each of the landing zones, you can have a separate subscription where you can stand up this. And then I will talk more about this data domain and data products when we reach there. The third kind of architecture, this is technically for very large scale organizations where you have a separate data management landing zone for a set of data landing zones. Usually this is for very large organizations which are having separate data governance policies, and they don't want those data governance policies to be centralized. So in those specific scenarios, we can even spin up data management landing zones separately. So you can see for in this specific slide that we have two data management landing zones, and for each of the data management landing zones, we have a set of data landing zones which are connected to it. Okay, but as I said, this is a scenario which we normally don't advise unless we have customers who have very specific requirements of having multiple management landing zones because of the way their company is set up or how they want this data governance to be separated out. This is one slide on the foundation, which I talked about. Using the cloud adoption framework in Azure, we actually can spin up Azure landing zone, right? And you can see here, like as I was talking about, so these are different subscriptions, so as to speak, in Azure. So basically, if you look at it, this is your connectivity subscription where you can have your express routes, your VPNs, your firewalls set up. You have an identity subscription where you can have Azure Active Directory set up. And then you have your landing zone subscriptions. This is a subscription or the landing zones where you have your cloud, using your cloud scale analytics, you can deploy your data landing zones in this subscription and then, set up your data management zones as well. So this is like the fundamental landing zone. And on top of this, then we can have our data landing zones and data management landing zones being set up using the cloud scale analytics. So moving further, within the data management landing zone, we have all these different components. So basically, these different components are for data cataloging, data quality, data governance, and Purview is the tool which we recommend for doing this data quality catalog and governance. And for master data management, we have a separate prophecy tool that can also be used. So basically, if you look at this, it gives you all the different components that can be used in Azure to deploy the data management landing zone. And that is something which we normally do, like for the customer which I was talking about, they were having this setup using Purview. The second zone which I talked about is a data landing zone. So in this data landing zone, you can have the different data products being set up as it's shown here. And these data products, think about it like these are based on the domains. For example, the financial data products can be here. Then you can have products coming in for sales, marketing from SAP and other sources. And these products sit on top of all these core services which I was talking about, where you have the networking and other core services like ingestion service using Spark setup. So in terms of the key components, if you look at in Azure for deploying data management and data landing zone, which are part of data mesh, what I have been working with this customer and some of the customers is on using Azure Purview, which is our go-to tool for data governance, along with log analytics and some of the other components which you see here. Log analytics is basically for auditing your data. And if you look at the data landing zone, Synapse, Databricks, Data Factory, these are all some of the analytics tools that we have in Azure that can help you to ingest your data and then build your data products. All right. So one of the questions that I normally hear from customers is that this is all good, but it seems to be too complex, So we have a set of best practices. We know that this is not a small undertaking. Creating a data mesh, if you think about it, it's going to impact the entire organization, and doing this in a way that will give you the business results, we recommend a set of best practices for that. So if you look at this slide, what we normally recommend is like to set up a single landing zone first, right? And that you do is like first you define your use case specific to a business unit. So for example, in the customer I was talking about, they were large, they had many business units, but what I ended up doing was to talk to them and see which business unit they wanted to go with first, and then define the use case for that unit, so that it's not like a big bang where we are trying to set this up for many of the business units at once. So the recommendation here is to start small and define the use case specific to a business unit if you're talking about larger organizations, and make sure that you are deploying your data management and landing zone for that unit first. So it will be like your first data landing zone or your zone for that specific unit. You define your ingestion patterns, you use Data Factory and other tools to do that ingestion. You can use batch streaming depending upon the use case. And then, once you have this landing zone set up, then you set up your data management zone as well using Purview. So once you have your data product using this first landing zones, and there can be like first data product which you define this way, where you actually go into and define what is the business purpose for that data product and how that data product is going to be used. You develop your product. So once you have this data product defined and you are able to prove the value from that product, you can always register that product in your Purview so that it's discoverable by the other consumers. So that is the first stage. So it's always beneficial to start small and then prove the value of the first setup or the first product that you develop using this. And then once you have proved your success in this stage, then you go to the next step of refining your architecture and then adding more data landing zones, which you can do easily in Azure using your subscriptions, right? You can have separate subscriptions for each of your landing zones, which will give you more scalability. As you might know that for each of the subscriptions, we have limits in terms of resources. So if you want to scale your landing zones, it's advisable to have a separate one for each of the, it is having to have a separate subscription, I mean to say, for each of the landing zones. So basically in the next stage, if you see here, it's more about refining your architecture and then, extending that with deploying more landing zones. And in the case of the customer I was talking about, we started with one business unit, and then we essentially expanded to other business units. And the way we did that was for the other business units, we added more data landing zones. And then for each of those landing zones, Then we added the products, the separate data products. These can be your second, third, fourth products as we speak. Sorry. And then, as I said, you can have all these different products registered in your metadata repository, which can be in Purview, and then implement your data quality and schema validation and other checks. The third and fourth stage, which you see here, these are more kind of enhancements where you can even go further and improve on the architecture in terms of the landing zone. For example, you can offer new transformation patterns. You can make sure that your transformation framework is robust. So this can be done in Azure Data Factory or in Databricks if you're using that. You can even have your clause-free, lineage, linkage. These are all the different kinds of metadata artifacts, which I've seen is very useful for the customers for their data discovery and seeing how the data is transformed right from the source to the target. So this can also help in making sure that data is trustable. So many customers I work with, they always ask for the lineage, for example, because they want to make sure that the data they are getting is from a trusted source, and they want to see how that transformation has happened. So these artifacts can be easily built using Purview. And then we have other things like, which again is related to the approvals of your data, whether it's a trusted. You can even have a workflow where it can be certified by certain data owners, and it can be more like a trusted kind of source. So this again is a workflow you can build using data governance tools. And then the other thing is on the people and process side. So I think I talked about the technology side, which can be implemented using this architecture. But the other important thing is definitely on the people and process side in data mesh. So this is not only a technology thing, but also organizational, where your process for data governance can be established. And then on the fourth step, I can see here, like you can go and define your data product guidelines. You can even define this further as needed. So I think we are coming to the end of time, but yeah, I would like to conclude by saying that this is a journey, and these are some of the best practices you can implement if you are using Azure along this journey. With that, I'm going to conclude this. I think we are right on time.
Thanks, Rahul. That's awesome. Yeah, a fascinating subject for sure. We've got a couple of questions, which I'll just quickly bring up for you before we move on to our next speaker. So our first question comes from Alexander. So he'd like to know, how do you determine what your landing zone should be in a specific case? Could you give it a couple of examples? And in addition to that, could you briefly talk about duplicating data across landing zones?
So the learnings, and what was the second part of the question, if you can repeat?
Can data be duplicated across many landing zones?
Yeah, good question. So yeah, learnings, what I specifically have come across is that it's a big undertaking. Many of the customers I talk to, they don't have a plan on how to start on data mesh. It's not something like a project or a small project which can be completed. It takes sometimes years to implement this architecture. But I think, as I talked about this, one of the learnings is to start small. Instead of trying to boil the ocean, As I talked about, we need to make sure that we have a success shown earlier in the process. So as you can see, as I talked about, first start with one landing zone and a data management zone, prove the value of this architecture for few data products. And once you get a business buy-in, and then you slowly expand into other business units and by adding more data landing zones. So start small and prove your value and then slowly expand. The other thing is like it's data mesh um, involves people, process, and technology. All three of these elements, they will require changes. Technology side, basically, if you implement in Azure, um, you will find that we have templates for it, for data landing zones, data management zones, which you can easily use. Process side of it, there are going to be organizational changes for this customer. For example, they were having a central IT organization which was becoming a bottleneck, so they had to basically, with our help and guidance, break that IT organization into more of a business unit embedded IT organization, which was a big change for them. That was something which required a lot of changes in their organization structure. So some of the organizations, if we look at it, they may not be ready to go with that kind of change in their organization. So we'll have to slowly go in and give them guidance on how best they can do that.
Interesting. We might have time for just one last question. We can probably sneak in before our next speaker. Just another question here. Just wanting to know about if you could talk about what the roadblocks for deriving value from data and how people can optimize this for their platform strategy.
So if I can understand, you're talking about the right blocks?
They're talking about roadblocks. So talk about in terms of deriving value from data, what are some of the typical roadblocks that you would encounter?
Yeah, good question. So one of the roadblocks definitely is that data is siloed. It is spread across many systems in the organization. Integrating that data is a big challenge. Then the second challenge is on data governance, where your data is not trustworthy or it's not in the format in which you can consume. So I'm sorry. So those are some of the roadblocks which we come across many of the customers like they deal with today. They don't know how to scale the data architecture. The data architecture which they have is not able to cope up with the new data sources that come in. For example, the agility of data is not there. They are not able to consume the data in a timely way. It takes too much time to prepare the data, for example. So all those are the big roadblocks, I would say, today, which many of the organizations face.
Fantastic, awesome. Hey, thank you so much for your presentation, Rahul. Very, very informative.
Yeah, thank you.
I'll just get my act together here. So, moving on to our next speaker is Rahat Yasir.
Hey.
Welcome, Rahat.
Hey, Adrian. How are you?
Very well, thank you. Very well, thank you. How are you today?
Very good, actually.
Yeah, and have you presented at Geekle before?
Yeah, maybe last year. Yeah.
Oh, what did you talk about on that topic?
Data and AI platform architecture, I believe. Yeah.
Oh,
in
nice.
Azure.
And oh, excellent. So for those who don't know, Rahat, he's selected as Canada's top 30 software developer under 30 in 2018. Quite an achievement. 8 times Microsoft Most Valuable Professional Award holder in the artificial intelligence category. He's going to speak to us today on designing and applying AI for large volume of IoT telemetry data in Azure. Sounds fascinating. And I see you've got your deck there, so I'll hand it over to you and off we go. Good luck.
Perfect. Thank you so much. So as I have presented at the Geekle like sessions before, so today, before I jump into the technical session and the presentation, what I was thinking was to not showing too detailed, but at the same time to talk about the how are we collecting the data, how big the data we collect, what are we doing with the data that we are collecting from IoT. So we'll mostly talk about that part. And as my topic is designing and applying AI on large volume of IoT telemetry data, and my name is Rahat Yasir. Like my role is Director of Data Science and AI of Isaac Instruments. You can see the logo at the right. Isaac is based on Montreal, Canada, but we have office in Toronto, Calgary, Ohio, and other parts of North America. So what we do is all those big trucks that you see, we we install IoT and hardware and software for those big trucks, and we collect a lot of data. And a lot of times, one of the interesting thing is in data and AI domain, a lot of people doesn't have the data. That is a problem. But in our case, we have too much data. That is another problem. So we'll just talk about how are we dealing with those data and how we are collecting the data. And thank you, Adrian, for the nice introduction. Yes, outside of my main job, I'm a Microsoft MVP in AI, and it's been quite a few years, 8 years that I'm an MVP in AI. So as I said, we'll talk about Isaac IoT solution, Isaac big data operation, some of the telemetry, how the telemetry platform looks like, what is the agenda behind that, how the big data and AI journey looks like, and big data and AI operation overall. So before I jump in, when we talk about we collect a lot of data, Isaac installed that thing on the truck. So how are we exactly collecting the data? What type of data it is? Structured, unstructured, tabular? So first, let's talk about that. So what we do is we have a black box, we call it, in Metric. We install that one in big trucks, and we collect all those truck engine information. There are like 70 to 80 plus parameter of values that we collect from each truck per second. And everything is collected from the sensors that is installed on this in-metric. And it is also connected with, it has a GPS communication to send the data back to our cloud platform, data platform, something like that. So you can see a lot of trucks are using our solution in North America, 45,000 trucks. And every single second, all those trucks that are running on the street are sending data to us. So that's 45,000 trucks sending data, and each of the JSON or whatever the way we are collecting the data has 80 plus parameter information. So you can think how big of a data we are collecting. And the data that we are collecting from the IoT, it's more into like a tabular format. We call it structured data. Then the second type of solution that we are offering is in view. What we do is we install a camera at the front of the truck, and then we capture based on the event what is happening in front of the truck. So if there is a hard brake or some sort of acceleration, that is a critical event, and right away we kind of start to store those 1 minute of video or 30 seconds or during the around the duration of the event, those videos, stored them in our captured them and stored them in our in-view camera, and then send it back to our cloud. We also have in control, so it's a tablet with an app that is used by the driver in the coach, and you can see a driver is using on the left. And what happened? This device is connected with the black box, which is in metric. So all those operational activities our truck drivers are doing, we are capturing it here, and we are helping with those data for different types of decision making, where the truck is, did it deliver the product or not? Is it in the around the 1 kilometer radius of the a client zone or not? That kind of things. Plus, we also have two types of software: in real time and on record. In real time is a web application, and on record is a desktop application. In real time, you can see if you have a truck fleet of 500 trucks, you will see where are those trucks, if there is any issue, and how they are moving from one corner to another. And the on record is the software. where it helps you with the like tax report, old report, trip report, that kind. So you can ask why we need those report. Suppose your truck drove from Montreal to Texas. So it took fuel in Montreal, it took fuel in Ontario, it took fuel in Texas. In 3 different areas, the GST, HST, taxation code, and everything is very different. So we also need to prepare a list how much fuel we have burned in which area, how much which area, so that we can prepare the full tax report. And then all the data are collected by the Isaac Big Data Cloud Platform. And after collecting the data, we are also doing a lot of like data analytics and AI operation on that one. So the AI we have started, we are doing, I will talk about at the end, but the data analytics, like the BI, those things are currently ongoing, plus those operational systems. Now the question is how big of a data we are collecting. We have built a big data platform with the IoT data. Now how big it is. The first thing I wanted to tell is any kind of platform to be considered as a big data platform, it needs to take on 5 different properties. And those properties are volume, velocity, variety, veracity, and value. So any kind of platform to be considered as big data, it needs to have a good amount of volume. So it needs to have a lot of data. So at Isaac, we literally collect 200 plus terabyte of operational and telemetry data through our systems. So the volume is pretty big. Second thing is one of the most critical property of big data is if we just have that big volume of data and it's just sitting in the corner, it's lazy data. It's not big data. So it is not fresh. It's not like coming. It doesn't have good velocity. So that kind of platform cannot be considered as a big data. So for big data, you need to have real-time data ingestion. You need to have good velocity of data. So at Isaac, we literally receive 10,000 plus records of data per second in our platform. Then the variety. Just having one type of data doesn't mean you have a big data platform. Big data means you need to have different categories of data, structured data, unstructured data. Structured data means the tabular data or IoT data that we are collecting, which is category 1 data. That's the data we are collecting. Most of our data are category 1 structured data. We also collect a lot of like on the tablet app, there are like conversational data. Whenever a driver is arriving, he's saying something. Whenever getting a message, he's getting some response. So that conversational data is category 2 data. We are also like collecting that. And we are also collecting all those image and video data, which is unstructured data or category 3 data. Fourth one is the data needs to have good quality and it needs to be fresh as well. At Isaac, the veracity of the data is very high because the data that we collect is high quality, fresh, high fidelity, because the in-metric solution is designed by us, or those in real-time on record is also designed by us. And the most important one is value. Is anyone taking decision, or is there any data-driven value based on the data that we are collecting? Yes. As I said, we have a lot of like 400 plus clients in North America. They're taking all their telemetry decision or fleet related decision based on the data that we are collecting today. So it's bringing a lot of like data driven operational decision making capabilities. So it's bringing a lot of values. So that's the Isaac big data platform. So we are collecting a lot of data. I also talked about how are we collecting the data. So I just want to like give a quick overview how this data looks like. So it's from a truck that sent us data for a few minutes, and you can see that's a lot of data that we are getting, and that's a lot of like rows of data that we are also getting, and it's nicely organized, well structured, it's clean, properly maintained as well. So this is the kind of like data that we usually receive. Now, what is the goal? As I said, the goal is to do BI, AI with the data that we collect. So the goal is to like, we are building we have already built an Azure cloud platform, which is unifying the entire approach of IoT telematics data collection. So what is happening in our cloud platform, which is in Azure? So first, we have connected truck telematics gateway with our cloud platform. So all those trucks that you see that we have said from like 40,000 plus 45,000 trucks that are using our solution, they're sending real-time data to our cloud platform. So that's one of the way. We are also like ingesting outside data sources. Like just having the truck data is not enough. We also need weather data. We also need historical accident data. We also need vehicle information data when it was made, any kind of like known issues. We also need other third parties. So that kind of like outside data sources, we are also writing pipelines using ADF or like other app services based services that is bringing the data to our cloud platform, so that our data platform is kind of like unifying the approach of data collection, and then it transform the data, process the data, organize the data, so that we can serve our existing ecosystem, plus share back the data with third parties, with our clients, and do a lot of like BI, AI, that kind. So as a user of our platform, you can see we talked about the driver app that reads a lot of like operational information. We also have operational systems that also like loads the data and show it. And we also have analytics dashboard that shows last 1 year, what are the trends, what happened, what is happening, that kind of things, plus the third party integration. So that's the telemetry platform looks like, which is mostly full of like lots of IoT data of truck engine, location, plus operational information as well regarding supply chain. Now the thing is, it's good that we are collecting the data, but what is the goal? For any organization in the transportation industry or transportation domain, how this journey looks like, what are the step-by-step like mapping looks like, how this productivity map goes up. So this is a typical map for a big data and AI journey, for even for a transportation industry or any other industry actually. So the first, like the productivity goes up into the y-axis, and the maturity is on the x-axis. So the first step is collecting the data, serving operational like approaches or like issues. So in this first phase, we need to collect data, and we are collecting data, raw data with in-metric, in-control through third parties, plus operational activities. Once we collect the data for any organization, we need to give data-driven operational support. We need to tell the clients what is happening right now based on all the data that we're collecting. So showing the data in a web portal, showing the data for operational decision making. That's what we are doing today. Then the third one is, when we are seeing what is happening, we also need to say recent reports or what has happened. So we also need to prepare some sort of like standard reporting. So that's what we are offering through like our on record software, which gives ad hoc reporting, OLAP, operational reporting, and those systems are .NET based mostly. So this is like driven by human driven decision, where a human is like manually choosing which data to show, which platform to show, that kind, which report to show. But then the second approach is to make it more automated, more productive, having like more productive impact. We need to have a big data platform. So what we are doing is we build our cloud data platform, and the data platform, just having a cloud doesn't mean it's like everything is done. It needs to have proper security. It needs to have a scalability. It needs to be efficient, and also like it needs to have proper data governance, because we are ingesting a lot of data. Some of the data has driver information, license information. We cannot keep them just as it is. We need to add enough security on top of that. So that's what we have done in Azure platform. Once we build the cloud platform that is secure, completely untouchable from outside or all those like cyber attacks, then the next step is to integrate other data sources, like adding more data, making it more resourceful. So we added other data sources, as I said, external data sources related to weather, accident, vehicle information. Then once we have the data, once we have the platform, now what? So the first step of the big data and AI is to have descriptive analytics. So a lot of times, a lot of organization jump about for AI or some POCs or something. No, we need to see, is the data is bringing value or not? Is the data is showing pattern or not before thinking about AI? So that's what we did, is descriptive analytics. We built a BI that is showing what happened with your fleet last 1 year. Who is the best performing truck driver last 1 year or 2 years? Which truck engine is struggling last 1-2 years, based on full information, how the safety and compliance looks like over the year of period, or something more, and how the fuel consumption, CO2 emission looks like, so that you can save them. So the purpose is to like show why did it happen, whatever has happened. So it is more into human crafted and data driven decision support, because data is preparing everything, but human is still selecting what they want to see, which feature they want to see. Then the last one and the most important one is high productive impact section, which is AI part. So first we do predictive analytics, like mostly classification model, regression model. This is the place where we say what will happen. We are predicting. So which truck is going to fail, which driver is a high risk category, and where this driver is struggling in city driving, uphill driving, something like that. Once we design some AI model, predictive maintenance and predictive analytics based, then the next one is prescriptive. Prescriptive analytics is more into optimization model, recommendation model, proposing a solution, like recommending something, and then mentioning the impact of that action. If I take action based on this recommendation, what will happen? If I don't take action based on this like recommendation, what will happen? So the purpose is to whatever is happening with your truck fleet, with your data, so that things doesn't happen again, and it needs to be fixed in a prescriptive manner. So and it's more into data centric and big on automated decision making capability. So that's how the journey looks like. First, collect the data, do operational activities, reporting, then big data platform, keep all the data secured, safe, have descriptive analytics or BI, and then have predictive analytics, AI model, and then more into prescriptive analytics. So that's how the step-by-step journey looks like. And it's interesting that we are building this entire platform, the cloud platform, descriptive analytics, predictive and prescriptive in an Azure ecosystem. So, but again, at the same time, as a SaaS software platform, you need to also have, when you're collecting the data, you also need to have certain data principles, because the data that we are collecting, a lot of times it's not owned by us. We are the one who are building the platform, but our clients are the ones sending their data, their truck information, to our platform, so that we can store them, we can keep them, and provide different types of insight to them. So that's what is happening in our case as well. So we maintain some very strict data operational principles. The first one is, we always say we are just the pipeline. Any SaaS company, usually we are the pipeline between their consumer or the company, or we are the we are the pipeline between truck and the company. So we are storing the data so that they can get more insights from the data that they're sending us, and we are the platform provider, and we charge based on that. We are not supposed to share the data or monetize the data, because in most of the cases in SaaS systems, the data is owned by the client. But at the same time, one thing we can always do, based on the consent of the client, if client wants to share it to someone or give it to someone, we can always do that one. And a lot of times when a data arrives in our platform or in any platform, in any SaaS software, we often forget that the data solely belongs to our client. Right now, because of those like data privacy laws and like data sensitivity laws, it's getting more severe, and companies are getting more serious about that. So it's one thing we need to add it, in our principle, that the data always belongs to the client. If we can do it based on for product improvement and for to help clients with more insights, but the data is owned by our client. One thing we are strictly focusing on client specific personalized BI and AI. So a lot of organizations, they think you can build BI and AI based on one company or organization and just deploy it or roll it for other clients. No, that's also like unethical, and you cannot do that. If there is any auditing process, it can get you in issues. So, and that's the reason why the BI and AI that we are designing are specific to one customer, their data, their process, and it's not personal. It's completely personalized and it's not shared. So just build one and deploy all. No, that's not the approach we can do for data products. Then the data. How are we treating the data? That is also extremely important. When we are dealing with PII data and health data, we need to keep it masked. when we are training any model with the data that we collect, it needs to be anonymized. So why? So that those individuals are like ethnicity, those needs to be removed completely. But it's still, if there is any kind of like data that can be like, we cannot remove it, and it is one of the key value for the feature engineering or model training. In that case, anonymize that one, so that there is no like ethical issues with the model that you're training, and mostly on the sensitive data. But if it is just like sensor data or like basic like mission information, then that is fine. And the last one is like the data platform needs to be, it is secured. It needs to have proper governance. We need to have full list of like access management. Who are the people have access to the data? How are we managing the access of those data? How often we review the access management, and also why those people have the access? Because if they are not supposed to, if they are not data engineer or something like that, they should not have access to the data. So that's another thing, at least the PII data. So that's one thing you need to maintain. We need to maintain with the proper governance and auditing. So these are the like key principles that we are following, but there are more obviously. But at the same time, any organization that are going to work with AI, data science, and BI, they need to keep certain things in their mind as well if you are a SaaS platform. So how are we doing the data processing, and how big the data processing looks like? So suppose we did like a quick test and just like wanted to share the result, and just so suppose for 1,000 truck, we have like ingested all the data for 90 days, and the data that we collect are stored in our own like proprietary format. Once we collect the data, it's more into like a raw files. Like you can see for 90 days, 1,000 truck, the size is 208 gigabyte almost. And when we enrich it, because on a machine readable format or raw format, it's very compressed. When we uncompress it to get more readable format or understandable format, we call it ISA. It's our own file format as well. We see the data grows like significantly from 208 gig to 751 gig, but the same number of files are the same. And then what we do is we don't store it into this format because it's still pretty big, or even CSV is also pretty big. We store the data in our as ADLS Gen 2 into Parquet format, so that it's way more smaller in size. And we also like break the file into the time, the segment, and a lot of other cases. So you can see the 751 gig became 4.52 gig of data. And then when we collect all the data, it's just like raw information, but we cannot load that much information and show it because the platform cannot like deal with that much data. What we do is we summarize the data, we transform that, organize that, so that at the end, our clients can just see the insight, and we store the insight into a BI platform. So the same 1.5 million files and 450 gig of data, which 2.8 billion rows, after summarization and aggregation, we use proper star schema, we use proper Power BI, the data becomes only 82,000 rows of data, which is only 20 megabyte of data stored in a proper warehouse. So for that kind of processing, for the database we are using like data lake, we are using Azure Data Lake storage. We also put the data into archive storage. We have also a lot of APIs because our clients wants to see where this truck was at 5 p.m., 2 p.m., that kind of like reporting purpose or operational purpose. So what we have noticed is for those small point queries, Azure Data Explorer is a very useful tool. It's very fast, very efficient, very cost effective as well. So for telemetry data storage of the location information or that kind, we are using Azure Data Explorer. To ingest the data, we are using as we're not just using telemetry, we have other type of data sources as well. We are using like Azure Data Factory. We also have our own app service-based services that is running on client servers, bringing data through different types of ways. We have service bus-based mechanism as well. For data transformation, we tried both Databricks and Synapse Analytics, Spark Pool. What we have noticed that Synapse Analytics Spark Pool is cheaper because we don't need to run the Spark Pool 24 hours. We were running it like once a day, 2 to 3 hours, something like that, for summarize the full day of data. Plus for warehouse, we are using a Synapse SQL pool. For data cataloging, we have just started to use Azure Purview for the data mapping to see where the data is, how much data flow is, movement. That is also pretty nice. And storing the anonymized keys, we use Azure Key Vault. Plus, we have for visualization, we use Power BI based visualization as well. So what kind of things we are showing? As just to give a high level idea, we are putting a lot of reports like truck benchmarking, which trucks are doing good, average miles and MPG per truck per like a driver, so that we can find out which drivers are the best performing drivers, which are the worst performing drivers. We're also finding all those critical safety events and compliance events, why it's happening, when it's happening, to find some sort of pattern if any driver is struggling any type of roads or any type of driving pattern, so that we can help them. The fuel consumption, that is one of the important one reporting we are doing, so which has direct impact of saving a lot of money, because we know if we can save more fuel, which is gonna save more money because fuel is expensive these days, plus which is also help us with less CO2 emission, and we will be able to reduce the emission as well. Plus, what we all have also noticed that with this approach, with those reporting, we can also help with driver turnover percentage. So that also helps us a lot. So that's how the data is showed, and we are working more to have more comprehensive report on those IoT data that we are collecting. And for AI, so one of the key thing is in AI industry is identifying the ideal use case for the AI development. So we reviewed a lot of use cases in different segments for making the driving more safe, making the driver more productive, plus making those trucks more safe as well, plus more efficient. So out of that, what we have done is we have chosen multiple AI ideas that we are currently building, and reducing overall cost of a trip is one of the top AI that we are working today, so that we can reduce the fuel, we can identify which truck configuration is wasting more fuel, what is the best speed or acceleration that a driver needs to maintain to reduce the fuel and CO2 emission. Driver performance and safety is another one we are identifying with AI, which driver is a high risk driver and why, so that we can provide some sort of training more into adaptive learning manner, so that they can fix their issues or struggling cases and be more safe on the street. And we are also trying to understand and monitor assets like engine or trailers or trucks, so that we can avoid downtime, and also we can predict which truck is going to fail based on predictive maintenance, and help them to go to the a garage and fix it as soon as possible. For AI and ML toolset, we are using Azure Machine Learning Platform, as our data is in Azure platform, and we are using Azure content Kubernetes services, container registry, different types of Azure pipeline for CI/CD and ML ops. We are also storing all those inferencing information into a Cosmos DB, which is later showing on a Power BI based report for operational activities regarding ML ops. And within the Azure ML, we also have option for data drift, retraining model monitoring as well. Plus, one thing we are also doing is develop 3 dashboard within Azure. One is data ops dashboard, which shows from end to end how many pipelines are running, if any of the pipeline has failed today or not. So that gives a full glimpse. Same for ML ops, a single dashboard in Azure that shows how many models are running, how many model replicas are running, how many inferencing has failed, so that it also gives us a full idea about the peak hour, so that we can have more replicas as well. And the last one is cost dashboard, based on all the activities in Azure that we are using. What is the cost? Where is the cost threshold today? Which specific component is making us spend more money, so that we can reduce the dollar value? So that is the overall approach of AI. Next time I will come again to show more AI use results. Right now we are not, but that's it. Thank you so much, and hopefully it was useful. And if anyone has any question, feel free to ask me.
Thanks, Rahat. That was fantastic. Fascinating topic. We don't have any questions at the moment in the chat, so if anyone's got any questions, if you can pop those in now, we should be able to get to those if you're quick. Could I just ask you, while we're waiting for those, Rahat, what you've given is quite a mature example of what Isaac's done. For those of us starting out with IoT, what are the key considerations for building a platform that might end up being something like what you've built one day?
So one of the issue is the cost. When we talk about IoT, IoT has a lot of data, but bringing that much data, maintaining that much data, because as I was the example that I was showing, we collect like suppose like 3 billion rows of data information. That's a lot for only 1,000 trucks of 90 days, but we cannot load that much information in a dashboard or in a software because it's gonna like crash, or it's too much like input. So that's why what we do is we do different level of aggregation, 15-minute segregation. Sometimes we do like a more once a day aggregation on driver level, truck level, so that we have this summarized insight. So the purpose of the data analytics and AI is finding the insight, not just like loading the data and dumping the data. So that's one of the thing we need to like make sure. And reducing the cost, keeping the cost within the limit, that is also like a big challenge, because when you have a lot of data, you cannot just like dump the data and the archive storage. You need to load it, you need to keep it, you need to preserve it, so that you need to design the architecture in a way where you need to be smart so that it's not super costly.
Oh, interesting. Oh, here we go. Here's the question. So, according to data volumes, do you use some part of the data, for example, a week ago, to process those?
Yes. So for the data volume, what we do is we have all the data that we collect, we keep them into a like Azure data lake, into a processed like container. It is available for like next few months if anyone wants to like pull that data back. But on a daily basis, we summarize that data, put them into the warehouse so that daily insights are available. We also have SQL operational data, which is more into like not summarized. We like less number of parameter, so that the data that our operational activities needs, we just make it available on that much. And some of the data where clients needs to see even like on a weekly basis, or this kind of where this truck was 1 week ago at 2 p.m., or if there is any accident, someone can like do a quickly query. We use Azure Data Explorer to keep those telemetry data available right away, so that our clients have access to the data that they need. Yeah.
Fantastic. And one last question that we've got here, which has just come in. What features do you use in your AI machine learning models, and how do you extract those features from the raw, refined, prepared data?
So different types of model has different types of features. So suppose one of the model is a driver retention model that we are currently working on. So it's a very interesting part. It's like a churn analysis. Which driver is going to voluntarily quit the company? So what we do is we review their like average like driving MPGs. We review their like shifting. We review their HOS on duty. We also review their like fuel consumption, how they're driving. We also review like their benchmarking as well. The purpose is to like identify last 3 months before quitting the job, are they happy? Are their performances going up or going down? If it is going down, what is the pattern that it looks like? So that we can take that pattern and apply it on new drivers, so that we can predict, okay, this new driver, he has a similar pattern of this bunch of driver that left, so that we can, he's struggling on something, we can go and talk to him. So something like that. Plus we also have like high risk driver, which driver is having more like critical events, which driver is like when a truck driver is driving a massive 4,000 ton, say 8,000 ton truck, they cannot just like do hard brake or something like that. So we are also like reviewing all the impactful activities that a human is responsible for when they're driving. So there are like 8 to 10 parameter, like brake, shift, acceleration, clutch, that kind of gear, that kind of things. So based on that, we are saying this driver had a very high risk driving activity or aggressive driving behavior. So it's a mix of a lot of things.
Fantastic. Well, hey, thank you so much for your presentation, Rahat. Really, really fascinating. I'm a real newbie to IoT myself, so thanks for sharing.
Thank you so much. Thank you. Bye.
Have a great day ahead. And now moving on to our last presentation, we have Aaron Torres and Ala Shaban with us. They've got a recording for their presentation, which we're going to play for you, but they will be available for Q&A at the end. So just by way of a quick introduction, I've got an introduction here for Aaron. So for those of you who are a huge fan of the Go language, so is Aaron. He's a VP of Engineering and co-founder at Clotho, a startup building the next cloud architecture. And with him, he has got his colleague and co-founder, Ala Shaban. So I believe we'll get going now we'll just jump into the recording. So Yura, I'll leave it to you to take it away. Is that cool?
My name is Aaron Torres, and today I'll be presenting Adaptive Architectures, the cloud architecture of the next 10 years. Originally, my background was in high-performance computing at Los Alamos National Laboratory, and more recently, I worked on the central platform team at Riot Games, where we deployed the core platform for some of the largest games in the world. In 5 years, mid-sized companies and fast-growing startups won't be developing with microservices. In the next 30 minutes, I'll show you why and what they'll be using instead. Spoiler alert, the answer to that is adaptive architectures. So what is an adaptive architecture? Well, it's a superset architecture that provides all the benefits of monoliths, microservices, and serverless. And the intention is that we'll also hopefully be able to pull in future architectures as well. And it'll do so without having any of the drawbacks of the existing architectures. Specifically, you can change individual components of your architecture from the compute type you're using, in other words, something like EKS or Lambda, all the way down to network protocol, things like TCP versus using gRPC. And it's cloud agnostic, meaning you can target AWS, GCP, Azure, as well as future cloud providers, smaller cloud providers, IaaS, and PaaS services as well. What problems does adaptive architecture solve? Well, first and foremost, it speeds up development. And this is because developers are able to pick a technology or set of technologies and change them later as the requirements change. They're able to adapt their application. It reduces technical and organizational friction for the same reason. Because it's so easy to adapt, there is less of a handshake between the operators, the ones who are going to spin up infrastructure, and the developers who are writing the application logic. Normally, this is highly coupled, and it would require changes on both sides. It makes local development easier because your base application is just a native, normal application on your machine, meaning you can run debuggers, you can run your favorite SDKs and development tools that you would use today without having to compromise. You can scale out application components independently. In other words, you can break out parts of your code that are maybe more compute heavy and need more resources, similar to the kind of benefits you might get in a microservice architecture. It enables repeatable deployments. And by that, I mean, you can very quickly stamp out environments, whether it's going to be global deployments, testing environments, or if you're conducting proof of concepts. It also future-proofs your application because as new technologies are introduced and the adaptive architecture is able to support them, you're able to incorporate them into your app, even if you built and designed your app without knowing they existed. What does an adaptive architecture look like? Well, in our case, the adaptive architecture is a semantic parser on the language that you might be using. So you would write a plain native application. It would read that and compile it or transpile it to support all of these underlying details. So in other words, it can quickly change your original application to be more like a monolith or be like microservices or otherwise. And the lower level details, what cloud you're using and everything else is just an implementation detail. We'd like to solve a problem here, and that problem is that we want a web service that takes an image as a URL and it produces a JSON payload like the one we see on the right. So in other words, it's doing some sort of text recognition on the image, OCR, so to speak, and what we should get back is the URL that was passed in and the text that was translated using our app. For this application, we'll be using this image that we're hosting on the website, which is just a PNG with a gradient, and the text intelligence is the ability to adapt to change by Stephen Hawking. But let's assume for a minute that you are inheriting this application. Someone already wrote this, and this is the architecture that they came up with. In this case, it's AWS based. And for the remainder of this talk, our examples will be using AWS. And so the references to compute units and code will all be AWS specific. But in this case, let's take a look at this existing architecture. So we have an OCR gateway here, which is an API gateway, and it's able to communicate to two Lambda processes. 2 of our Lambda processes are communicating via PubSub, and they're storing and retrieving results in this DynamoDB table called text result. But let's assume for a moment that your requirements changed. We no longer are able to use these Lambdas. We need to use EKS pods instead. EKS, for those who aren't aware, is Kubernetes running on AWS. And some questions I'd like you to consider is why, first off, would you want to adapt the architecture from Lambdas to EKS in the first place? How would you do this today without an adaptive architecture? And if you had an adaptive architecture, how would that help you? So why adapt? The first reason is we made the best choices with the information we had. We didn't know that there was a better choice that was going to become apparent down the road. Another reason is organizational change. And this could be anything from an org-wide shift to a technology or platform. It could also be something as simple as teams merging or inheriting a product from another team. Next is changing customer sizes. And this is really a question of the amount of customers you have. So maybe in the beginning, you were under-provisioned and you had way more customers than you were expecting. And so you had to very quickly adapt and change your architecture to handle that. And maybe down the road, you're over-provisioned because you have a lot less customers, but you're spending that money keeping your infrastructure alive. Next up is new technologies or requirements. And this could be everything from someone who's excited about something new and exciting and a new tech that they want to play with, to maybe your latency requirements are much lower than you expected, and the network protocol you chose is just not going to ever work for that scale. To begin with, you would need to learn a large number of new technologies and best practices. Whenever you pick up a new tech, there's a long learning curve of how you best use that tech. In our case, there's a high likelihood that the original app didn't have anything special going on with VPCs, because none of those AWS components required it. But now that we're using EKS, you absolutely do need VPCs. So let's assume that you're spinning up VPCs, configuring subnets, security groups, IAM permissions, everything you need in order to wire up that EKS setup. Not to mention the long, arduous step of actually spinning up and configuring an EKS cluster, which is a large bit all on its own, in addition to the investment you did in understanding EKS in the beginning. Next, you'd have to reorganize and rewrite your application in order to use the EKS interface, which is most likely going to be REST-based or gRPC versus the Lambda case, which is using invokes, which means you're going to have to revisit inter-module communication, decide what protocol you're using and what transport you're using to communicate between your modules. Next, you have to create Helm charts, YAML specs, Docker things, anything you need in order to wire up your app and actually make it deployable. And lastly, you need to redo your CI/CD pipeline in order to target that Kubernetes cluster and actually deploy your pods to it. And what's not mentioned here is the last bits are testing and validation, and making sure everything works once you're done. If we had an adaptive architecture, what would this take instead? Well, this is really the whole purpose of an adaptive architecture. Being able to change your compute type from a Lambda to an EKS is one of the minimal requirements for an adaptive architecture. So this should be very, very simple. For the remainder of this talk, it might sound like it would be very difficult to take an app and make it into an adaptive application, but I'd like to show you is it's actually quite simple and relatively straightforward with a tool that we produced. That tool is called Clotho. Clotho is a cloud-aware coding toolbox that allows you to produce adaptive architectures. It does this using 4 simple capabilities. Clotho takes plain code, annotations, and config, and produces, on the other side, transpiled code and infras code. It's transpiled code in the sense that it's still human readable, and it's a version of your code that has been modified in order to work with the infra that we're going to provision as part of the infrastructure as code process. With that in mind, we're going to start with this basic node service for our demo. This is a vanilla node application. It has application level dependencies only. What's not in here is any kind of specialized SDKs, any kind of specs, Docker files, anything related to our app. You can see from the list of dependencies that it's just a vanilla node app. And just for context, it's written in TypeScript as well. Here is that app pulled up here. And what I'm going to do is just kind of showcase how it works and what it does. So the first thing I am going to do is I'm going to run tsnode on my main file. You can see that we're listening locally. So this app exposes 2 endpoints. One is a post where you post a URL for it to do the text recognition on. The other is a GET request where you'll get the result from it. In our basic version today, the post version also returns the result directly. And I'm going to be piping this through to JQ to make it print a little bit more friendly here. And what you can see, our original image now is coming back with this resultant URL. You can see that it matches the text that was in the image. And if we were to go look back at it, as a reminder, this is what it looked like. And lastly, if we were to curl the results page version of this, we'll get back the same results as we did on the original endpoint where we did the recognize. Next, what we want to do is we want to make this a cloud native application, meaning that the minimum bar for that is that we're deployed to the internet and we're able to hit it from a public endpoint. To accomplish that, we want two pieces. We want to bundle our app and put it in some sort of compute unit, in this case, a Lambda, and we want to wire that Lambda to handle requests from an API gateway. So what would this take without Flow, though? At a minimum, we would need to modify our Express app to communicate with Lambda, since Lambda is using Invoke and Express is a long-running web service. We would need to spin up the API gateway itself, which would either need to be created manually through the AWS console, or we would need to invest in IAC, either Terraform or Pulumi or the equivalent, in order to manage this in a repeatable way. We would need to set up IAM policies and security groups for all the new pieces, in this case, the Lambda and the API gateway. And I can't stress enough that this process here is often one of the longer tails of the development cycle, where you frequently need to test an IAM policy and then rewrite it. And we'll be seeing that trend throughout these slides. Next, we have to package up our app in a Docker container and upload it to a registry. We'll be using ECR in this case. And we need to set up a deploy pipeline to take our infrastructure and spin it up and deploy our Lambda to its appropriate place as well. In the Clotho world, we would accomplish this using the expose capability. I'll be showcasing how the expose annotation works. What it does is it exposes a resource publicly or privately. And that's perfect for us because we had a web server listening on a port, and we would like that to be exposed publicly to the internet. So we'll come back to our application and take a look at our index.ts. And what you can see is here is where we're listening on port 3000. Here's the message we saw earlier, app listening locally. And what I'm going to do is I will add the expose annotation to it. The target choices are public or private. We're going with public because we want it to be exposed to the public internet. And I will call this OCR gateway. And actually, we'll call it OCR demo gateway. So it's slightly different from the diagrams we had before, and to show how this all works together. This ID is just a placeholder identifier, meaning it can be any name you want. It has to be unique to your application. It should be something representative so that you know what it is when you're looking at diagrams, etc. So in our case, OCR demo gateway. Next, I'm going to transpile our application using TSC, which will take the TypeScript and produce a JavaScript version of the app. And then I'm going to feed that into the Clotho tool, and let's see what happens. After running this, we're given two directories, dist, which is the transpiled TypeScript, and compiled, which is produced by Clotho. Within this compiled directory is everything you need to deploy, run, and operate your service. That means that all of the IAC, this time in the form of Pulumi, but it could also be something like Terraform, the modified version of your source code, plus specs, configs. The thing of interest to us is this OCR demo.png, which I'm going to pull to the side. And this is the topology of your application from Clotho's perspective based on the annotations we've added so far. So in our case, we used expose, and expose told Clotho that we needed to add an API gateway connecting to our compute unit, and by default, our compute units are Lambdas. If you were to run a Pulumi up at this point from this compiled directory after doing a npm install, it would create this on your AWS account and would return to you a public URL that you could curl. Your app would operate exactly the same as the original local version, only it would be in the cloud. Next up, we'd like to add some persistence to our app. So today, our app is storing intermediate results inside of an ES6 map called status map. If we were to go look at our module, you would see that whenever recognized text gets called, it checks to see if status map contains the result for that URL and returns it. And if not, then we set it after it's done recognizing. This is to reduce the compute time that we'd have to do recognizing the same text over and over again. However, there's some limitations to this as designed today. Because it's an ES6 map and because we're using Lambdas, it will wipe the map every time that your Lambda spins down or has a cold start. And as a result, maybe we want to make this be persistent. Maybe we want to store this in long-term storage so that through restarts, we're able to persist all of those results. So what we'd like to do is modify our app to store those results in a DynamoDB table called text result. If you were to do this today and generate this DynamoDB table, the minimum steps are these. You would need to first actually create the DynamoDB table, again, IAC or directly through the console. You would need to then pick an SDK to interface with DynamoDB for your application itself, meaning you'd have to change the app to understand DynamoDB. Next, you'd have to rewrite the app to create a schema, index, make use of DynamoDB, re-provision IAM rules, And this time I'm showing 3 IAM policies because you are spending a lot of time rewriting, testing, and validating that your changes worked. So it's most likely a case of deploy, test, redeploy until everything connects. In the Clotho world, the capability we would use to handle this is persist. And persist allows you to persist a resource to the cloud. Today, we support key value maps, the ES6 map I showed earlier, for example, secrets, file system to blob storage, ORMs, and Redis, and there's more to come. But those are some of the examples of things that you can persist today. We would like to persist our ES6 map, which is living here in status.ts. So to do that, all we need to do is call persist, give it a name. We'll call this status results because we're storing the results of our status in there. Again, ID is arbitrary name. You can pick whatever you want. And all we're going to do is recompile and see how our image changes. And just like that, now we have status results. This is the point where I want to point out the IAM policies we were discussing earlier. In the Clotho world, these lines represent the boundaries by which these different units can talk. So main can talk to status results. That means it should have the appropriate IAM permissions to do so. You don't need to troubleshoot and start off with an overly permissive model and then reduce it. You get that for free when you compile and deploy. So in this case, only main can talk to status results. Now, let's say our requirements changed here, or maybe our understanding of the app changed, and we realized we needed to independently scale out certain parts of our compute. In this case, we wanted to separate out the APIs as well as the execution unit or Lambda in this case that is doing the image recognition itself. So what we want is when requests come into our gateway, we want some to be routed to this API exec to read from text results. Others go to this OCR API exec, which is doing an RPC call to this one that does the actual recognition, which then stores the results inside of text result. Without Clotho, what would this take? Well, it would take quite a bit. And the reason why is because this is fundamentally the first time that we're going from a monolith app into microservices app. So suddenly, rather than supporting one app, we're supporting 3 applications. We would need to break our app into multiple repos or set up hooks for monorepo where different directories fire off different deploy events. We would need to create Docker files for all 3 of services, as well as config and everything else you need to operate individual services. We would also need to set up additional complexity so that services can talk to one another, including service discovery, additional configurations, and other tweaks. And we would need to rewrite all the IACs. So I mentioned before the IAM policies and otherwise. You can see in this how all of those things would change, right? Before you had a single Lambda that could talk to text results. Now there's 2 Lambdas. One of them can't talk to it. There's a lot of tweaks to all of your rules and everything to make this change. In the Clotho world, we accomplish this with a capability called execution unit, which is the smallest deployable grouping of code. And what this allows a developer to do is delineate the boundaries on which their application is split. So they can choose which parts of their program live in one execution unit and which part lives in another execution unit. In our case, we mentioned we wanted to split our routers and our worker itself, the one that's actually doing the OCR. So I'm going to come to our API router. I'm going to come to the very top of the file, and I'm going to call exec unit. And what we will call this is API router. We'll do the same on the OCR router, again, at the very top. OCR router. And lastly, on our module, we'll call it OCR module, just for simplicity. Recompile. And there you have it. Now, if you were to look at this code, what you would find is that today, OCR router is importing a function from OCR module, but now they're in different Lambdas. So what's happening there? Well, the answer is that Clotho is translating what was before just function calls in memory to RPC calls. So this is handled all by RPC calls. Again, it handles all the wiring, permissions, and everything you need. But for clarity, what's happening here is now an RPC call instead of just a function call. This will continue to work the same as the original application, meaning that even though there's 3 Lambdas and the topology is more complex, you still have 2 endpoints that return the same results. Now that we've separated out the workflow and we actually have these 2 paths, one that's writing to the database ultimately and one that's reading from it ultimately, we now want to make this asynchronous because it no longer makes sense to have the bottom path wait for the write to complete. So what we're going to do instead is when a request comes in through the gateway, We will enqueue it onto an SNS queue from this API execution unit, and it'll be read from the exec execution unit to actually do the processing. Once it's received the work, it will just do the processing and store it in text results. So for all intents and purposes, these are now independent units. They don't communicate directly anymore via RPC calls. It's now done all directly via SNS. What would this take? Well, at a minimum, you would have to rewrite the transport layer between the lambdas to allow for SNS. So before they were perhaps using some custom RPC or invoking one another, now they need to use an SNS message queue. You would need the IAC for the SNS as well. Everything, again, that would be required to spin this up or to do it manually. You would need to also set up topics, rewrite the application to use those topics, and you would also have to do a pretty lengthy investigation of how using SNS with lambdas would work, since normally SNS requires a listener. Having a long-running listener on a lambda doesn't make sense. And as always, more IAM rules to tie it all together. In the Clotho world, we have a capability called pub/sub, which enables asynchronous message passing. This is the capability that lets you make a event-driven architecture. In our case, the main thing that we have worked on is an ES6 JavaScript emitter from the events package that we are able to decorate with pub/sub in order to turn it into a cloud-native pub/sub instead. So what I'm going to do is I'm going to modify our application slightly to make use of this emitter. What I'm going to do is I'll come to our module, and I'm going to create a listener on this that is going to listen for recognized messages and then do the recognized text that come in. And because this is just JavaScript and it's a monolith application, I'm able to just handle the dependencies by letting the editor autocomplete them for me. Similarly, we'll come down here to the router. Instead of just doing the recognized text, this RPC call, and getting our result, what we'll do instead is we will enqueue a recognized event passing in the URL, once again, resolving the import. And instead of storing the result, which was the translated text, we're just going to stick in recognizing text. So now you have to use both endpoints together in order to get the same result, but now it's asynchronous. And lastly, we'll come back to our emitter itself. And the emitter, once again, is just an event.event emitter. We're importing OCR module here for some JavaScript reasons to let the listen work in that other file. But what I'm going to do is I will decorate this or annotate this with pub/sub. And we will call this OCR pub/sub. And once again, we will rerun Clotho and our TypeScript compiler to get this diagram here. And as mentioned before, this has all the characteristics we just described. Now, these are no longer talking with RPC, they're talking via SNS. With those steps, Clotho transformed our original simple app into a cloud-native one. But remember, the original requirement is that we needed to reconfigure our app to use EKS instead of lambdas. We needed to adapt the application. The way Clotho handles this is with our configuration mechanism. So the way you configure an app in Clotho is as simple as this. You can just change your execution unit type, and it will, on next compile, change it from whatever you specified to the new thing you specified. And again, I mentioned before was by default it was Lambda. So in our case, we're going to come over here, and inside of our compile directory, what we have is a clotho.yaml file, which contains all of the application-specific defaults that Clotho generated for us. So this is populated based on the annotations in your application, meaning you'll see the exact same execution units, you'll see the same names for different gateways, etc. This is additive, meaning that we can go ahead and delete anything here that we're not going to be using. So in this case, I'm just going to blow away everything but our execution units and some of the front matter up here. I'm also going to blow away these parameters. These things here, memory size and timeout, these are Pulumi parameters, meaning that they're passed through directly to Pulumi, and it would support config that we may not even be aware of because we're not a shim, we're just a pass-through in this case. But for our demo, we don't care about these, so I'm going to blow all of these away as well. And we are going to change both of our routers to EKS. I'll rerun the compilation, but this time I'm going to pass in, I'm also going to copy out this clotho.yaml file because the compile directory is ephemeral, meaning that we would clobber it the next time we ran. So now that it's sitting outside, I can pass in the clotho.yaml. It will take these, overlay them on the old defaults, and now you can see that our diagram represents that these are EKS instead. And I mentioned before, this is a much more complex thing than just targeting EKS. This is spinning up the cluster if it doesn't exist, as well as connecting to it. So this is the total effort without an adaptive architecture. And these bullets are gathered from the previous slides. Something to note here is, although this is already a lot of bullets, some of these, such as spinning up and configuring an EKS cluster, might be another page of this size or more. So not all of these are created equal, right? It's a mind-boggling amount of stuff that needs to be absorbed in order to do this. With our adaptive architecture, from a plain vanilla app, it took 6 annotations and 2 config changes to accomplish that same architecture. Now I want to end with some of the rough edges. So to be clear, this product is still in beta today. And today we have a few limitations. Namely, we still have limited configurability. Although I mentioned the goal is to change every component down to the network layer, right now it's much more a high level, and we're still working on designs and patterns to make that more digestible. There's limited supported tech, meaning although we would love to support every AWS service, right now we're only supporting a subset, and it's an ever-growing story. And also, our early multi-repo story is still very early on, meaning we work much better in a monolith environment rather than a multi-repo one today. It will require rethinking the line between developing and operating a service. Having this really easy intermediate layer to make changes could make communication between those two sides much more rapid and require some changes where before people were expecting to have much more alignment early on. And next, the layers of abstraction are still very much in flux. So the example I talked about earlier was taking ES6 map and making it a cloud map. That's extremely portable. You could use that in any cloud with different storage layers underneath. But if you were to do something like decorate an SDK for DynamoDB directly, it would be very much still DynamoDB. You wouldn't be able to migrate that to another cloud provider if you wanted to. And we're still playing with the layers there. And I believe a plugin system will be the solution to really bridge everything together and get kind of the best of both worlds. Lastly, we're in beta today. Check us out at clo.dev. We are excited to build the community and hear how you like the tool. Thank you very much for your time, and I'm happy to take questions.
Fantastic. Well, hey, welcome, Aaron and Alla. Thanks for your presentation. That was pretty awesome. So, don't have any questions yet from the chat. So, everyone out there, hope you've enjoyed the presentation. If you've got any questions, we've got Alla and Aaron for a little while now. So, throw those in the chat, and we can put your questions to them. So, just while we wait for some questions to come in, guys. Do you mind if I ask, what was your inspiration for this? I mean, clearly you were talking about adaptive architecture and responding to change. How did you sort of arrive at this being the challenge that you wanted to tackle?
Yeah, I'll talk about that a bit. So both Al and I have been in organizations that were central platform teams and had to do this type of migration from one architecture to another. I've been on teams that have taken existing monoliths to microservices. We've also taken microservices from like one runtime being something like DCOS and migrating to Kubernetes as an example. And so we just realized that this was a recurring pattern, and a lot of these bits are the same. You're just kind of reinventing it for the new technology each time. And we just realized that there was capacity here to make this far simpler and make some of these transitions be far less painful.
Yeah, I think it's always exciting in the beginning to say, like, I'm going to use new technology. Kubernetes is fun. And then you actually have to maintain and talk to the 17 teams in the company and ask them to migrate Docker files or systems. And, you now need to maybe re-instrument to use gRPC or Linkerd. And that becomes a drain. Like, initially, it's fun until you have to get everybody to use the tech. And after doing these enough times, because they happen at different stages of every company's life cycle, we realized that we're spending people's time over years to do like recurring work that isn't stopping. And so that's where we really wanted to solve the problem rather than just make it like streamline it.
Yeah, for sure. Do you think that with the rise of cloud-based architecture that there's finally a chance to do this? Because I mean, these problems would have been around since the dawn of programming, I guess.
Yeah, and they've been solved in the different domains. So a few things, like this doesn't just have to target cloud. We envision this also working with on-prem systems, right? It's just a different target mechanism. It's just right now it's much easier to work with something that is much more accessible and configurable. But the key about being there from the initial programming days, if you think about compilers in general, I mean, you can take code that was written in the 70s, 80s, 90s, and recompile it to ARM, to iPhones, to Androids. And because it uses the same kind of approach and mechanism, which is the underlying bits, underlying infra of those machines needs to still be targetable, while the upper layer doesn't change necessarily or not a lot. And so this is very much influenced by approaches in that space, while still taking into account the uniqueness of distributed systems.
Cool. So obviously this is the architecture is based on an AWS implementation. Do you mind just talking to why or how you arrived at AWS as being the platform that you've adopted for this rather than GCP or Azure?
Yeah, so the plan has always been that we would love to be multi-cloud. It's really just that we don't want to spread ourselves too thin early. So AWS happens to have the biggest footprint. It has the most users. We also have the most familiarity with it and have worked with it in the past. So really, it was more of a pragmatic choice rather than a specific reason. Like eventually, we will definitely support all of the clouds.
More so, like there's two layers to this. One is our original prototype, which had a subset of the features, already works with both AWS and GCP. We have one customer that's already like running on GCP. We've tested same application. You recompile it, literally just change one flag that says GCP instead of AWS, and it just works. It also targets native services, so it's not a lowest common denominator, which is important. And I forgot the second point. So.
Oh, I do that all the time. I'd like to say it's a sign of genius, but we'll see.
I doubt it's just a sign of bad memory.
So so if I'm a solution architect out there looking for a platform like this, and I guess it's probably more of a, is it fair to say it'd be more of an option for a greenfield type development rather than, I mean, obviously you can't really throw it into an existing tech structure, can you? I mean, you could migrate onto it. Any comments on that?
Yeah, so we definitely designed this for, it was always designed for existing infrastructure in mind, because almost everyone has something in place. And so there's a few ways to integrate this into your existing stack. One is just by, let's assume that you already have infrastructure as code. You can import, we always assume that we are the secondary. So you can take every object that we generate through Terraform or Pulumi and import it into your main infra as code, and then just refer to the different objects or resources that we generate. So you can have, we may generate an API gateway and you have a custom domain defined in your Terraform or Pulumi, and you just grab the API gateway we generated and bind it to your custom domain as an example, and now you are within the Clotho world. And for the newer things that you want in the Clotho world, you get all the benefits. And for everything else, you kind of either maintain or continue having the separation, but they deploy together. And more importantly, you can slowly either move things together, but the worst case in our world is that you keep doing what you're doing today. There's no regressions. You can expose anything, a gRPC interface, you can have a web API and just interface them with existing systems exactly as you would today.
Cool. It's been pointed out to me that we've actually got some questions from the audience. So let me go to the first of those. So learning curve for developers, using your platform, complexity, is that something you can speak to?
Yeah, we made these cards kind of to convey this message. So everything you need to learn is on these. Let's see. Oh. This is literally the entire surface of the capabilities that you need to learn. What we just showed you is kind of the core building blocks of building most cloud systems with configurability and being able to select different types. But what we just showed you is basically what you would need to get you started. The users that we have already build non-trivial systems with secret management, with multiple security boundaries, with persistence, etc. And as far as we can tell, it took them, they reported at least twice the acceleration, and they've been running in production for quite a while now, months.
Yeah, and I'll also say that if you're looking at using this for something like a hackathon, the productivity feels amazing. It's bridges that gap between I've gotten my program working locally and I want to get it to the cloud quickly. It feels much better to be able to take that step in one leap rather than invest a couple more weekends to get that hackathon deployable.
So just to expand on that question about the learning curve, so is Is this something that could be used by junior developers, or is it more sort of pitched at intermediate devs? Is there, in terms of the learning curves, in terms of where people might be coming at it from?
I'll say this. I think it serves itself quite well as a learning tool as well. So it will deploy stuff and make it very visible, and you'll be able to operate in like you have to be able to log into AWS. You have to be at the point where you're able to use AWS versus something else. But it's a very great onboarding activity for like, here's how you might write Plotka or go about writing infrastructure as code. And here, like it makes it quicker to adopt best practices in some of those regions, even though that's sort of a side effect of the tool.
But from a junior dev perspective, you write a plain application, you add the expose annotation, you have a web API, you add the persist annotation, you have a API and data persistence, and you can start then deciding to break up the application into multiple pieces. Literally, it'll take you 2 annotations and a command line to have something deployable to AWS. And it doesn't have to be just AWS, GCP, Azure. We are planning things like Cloudflare, and we could target other systems like Heroku and even any kind of PaaS type of cloud. There's no boundary, there's no limitation on the targets.
Cool. Moving on to our next question here. So do you have an overview for other language integration roadmap? I guess timings, that sort of thing.
Yeah, I can speak to this. So we just did a big push for Python support. We're getting very close to having parity between Python and TypeScript/JavaScript. The next on the list is going to be Go. So we'll be doing some implementation of Go next, and then Java and C# are following that.
So Python is on the website right now. You can start using Python.
Cool. And what I think is our last question at the moment. So if you've got any other questions there, team, get those added in now. Got another one coming in. Okay, so whoops. Sorry, bit of a finger fumble on my part. Okay, how do you see adaptive architectures differentiating from Clotho versus Hadoop?
I would say in the Hadoop world, and I haven't used Hadoop for a while, whether it's Spark or Hadoop, you have a pre-described way of running, like selecting the node types or how nodes communicate with one another, or having to even specify that and register them manually. Like it's part of the kind of the building within Hadoop. Whereas in our world, the idea here is that the application would not change, and you can just swap out technologies, and you wouldn't have to do any changes to how you set up the infra, how they talk to one another, how they differ from characteristics of reacting with one another, the SDKs they need to have to talk to each other. All of that is absorbed into the into the tool that generates the adaptive architecture, in this case Clotho. But as far as I know, in the Hadoop world, you can't just swap out different components of the system, at least not to this degree of abstraction. Cool. And I'm happy, any conversations or like follow-ups, we're happy to answer them. Like just tweet at us or add us on LinkedIn, or we're happy to share our emails. We're happy to have those conversations. We love having those conversations.
Oh, it's good. That's excellent. It's always good to see people who are passionate about their product. Another question here, which I think is our last one at the moment. Can you talk to us about, another one coming in, maybe, extensive resource configuration, load balancing, auto scaling, that kind of thing? Is that something you can talk to?
Yeah, I can speak to this a bit today. So the intention is to have all of these things be fully configurable, like top to bottom. Right now, the answer for this is, because we have the pass-through to Plotka, it's possible to use some Plotka configuration to, for example, turn on auto-scaling for something. Beyond that, though, I would say this is still an early story, and we're still trying to iron this out to make it better, right? Like right now, it's much more of like a high-level tweak than changing, for example, whether it has auto-scaling.
Now that said, like when you see that Kubernetes cluster or Fargate, behind the scenes there is, if we had a different example around Fargate, you would actually see the NLB being added to the diagram. Like we're going to have a full diagram that shows you all the specific details that are also included in the actual instantiation. But in the case, if you mean, does it introduce all the different components needed to make this work? The answer is yes. And like Aaron mentioned, the design decision around being able to, we're not trying to invent a spec. There's actually no specs in our system. From a configuration perspective, we want you to be able to use the entire surface of infrastructure as tools or infrastructure as code tools, Pulumi, Terraform, without us being in the middle, even at the expense of you breaking us, right? But you're not going to be waiting on us to support load balancer configurations or changing instance type because we somehow didn't expose it or map it. So you can use everything that exists in those frameworks.
Cool. Just moving on from that, got a question here around AWS Event Bridge. Is that something that you support now or will be supporting soon?
We will support soon. I don't know. We're very much customer focused or user focused right now. So whenever the need comes up, but Event Bridge is something we kind of look at continuously. It's fantastic. So we're fans. Don't know if we have deep integration today.
Now, I haven't checked out your website. Is there somewhere on your website that people could request features and that kind of thing?
Yes, we're also on Discord. Like you'll find our Discord info once you we're in beta, so you just join the beta. We're gonna open source a bunch of like the core Clodo pieces soon. But join us on Discord. The entire team is there. We're happy to answer questions. You can also, if something doesn't work or you have feature requests that you wanna convey with more detail. But yeah, on the website you can also ask for features.
That's fantastic. Hey, well, Aaron, Ala, thanks for joining us here at the Geekle Architecture Summit, and all the best with your platform.
Thank you.
Thank you very much.
See you, folks.
Cheers. Well, and that's it. Thank you from me. That's the end of our block and the sessions for today. Join us tomorrow for more great content from me in New Zealand. Adrian, all the best. Take care, and see you again.